Vision without action is a dream. Action without vision is simply passing the time. Action with vision is making a difference. A very warm good morning to all. As said by Thomas Jefferson, consider chemistry among the most useful of sciences and big with future discoveries for the utility and safety of the human race. With due respect to his belief, on behalf of the Department of Chemistry and Adarsh College for Women, we cordially invite you all for the International Virtual Conference on Emerging Trends in Chemical Science and Technology, ETCST 2023. Adarsh College for Women, affiliated to University of Madras, is a premier self-financing institution situated in the heart of the Chennai city. The college is re-accredited with A++ grade in the third scale by NAC. Our college has been placed in the rank band of 100 to 150 among the top colleges by National Institutional Ranking Framework (NIRF). The Department of Chemistry was started in 1986 with a vision of laying a strong foundation in chemistry. The department equips the students with necessary knowledge and skills required to excel in the field of chemistry. We are committed towards producing chemists to meet the strategic needs to the present society. This virtual international conference focuses on various developments in the field of science and technology. This conference will be a platform to exchange ideas and innovations among the experts and the upcoming researchers in the field of science and technology. This will also provide a space for new collaboration and opportunities with the experts. A day without prayer is a day without blessing, and a life without prayer is a life without prayer, without power, by Edwin Harvey. With this note, I call upon Sahana of 2nd BSc Chemistry for the invocation song.
वक्रतुण्डमहाकाय सूर्यकोटि समप्रभ निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा श्रीशुक्लां ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनी वीणापुस्तकधारिणी अभयदां जाड्यान्तकारापहा हस्ते स्फाटिकमालिका जठदधी पद्मासने संस्थिता वन्दे काम्परदेवता भगवती बुद्धिप्रदा शारदा.
Thank you, Sahana. Small cheer and a great welcome makes a merry feast. I would request our Madam Principal, Dr. R. Shanti, a rare combination of compassion and with intelligence, to present the earnest welcome address.
Good morning.
Morning, ma'am.
I just believe in the goodwill of people, the power of people to do something positive. With this positive quote by A.D. Izzard, I wish you all a happy morning. On behalf of the management, Punjab Association, I extend a hearty welcome to all who have joined us for the 2-day virtual international conference on emerging trends in chemical science and technology. I extend a warm welcome to the chief guest for the inaugural session, Professor S. Sriman Narayanan, Vice Chancellor, Wales Institute of Science, Technology and Advanced Studies, VISTAS, the deemed to be university. We are elated with your presence, sir. I extend a special welcome to the keynote speaker of our conference, Professor S. Susai Rajendran, Adjunct Professor, Center for Nanoscience and Technology, Pondicherry University, co-editor, Journal of Materials Protection. I welcome the invited speakers from overseas, Dr. Po Wai Chia, Faculty of Science and Marine Environment, University of Malaysia, and Dr. Ramachandran Kuppan, Emory University, Atlanta, USA. A special welcome to the scientists from Serbia who have joined us. I also welcome the chairpersons for the oral and poster presentations for today's grand event. I welcome us. I wish the entire postgraduate department of chemistry the very best for the event. Thank you all.
Thank you very much, ma'am, for your delightful welcome address. When reasons are enough, there is nothing that we cannot accomplish. I may now request our sturdiest pillar, Dr. T. Shobna Premlata, Head, Postgraduate Department of Chemistry, to brief us about the conference.
Thank you, Sangeeta. Virtual conferences are definitely a different experience. It is a part of a larger hybrid event strategy that combines both in-person and digital experiences. While nothing can compare to the power of in-person, unprecedented circumstances have had a major impact on the future of events. ETCST 2023 strives to provide an international forum for scholarly exchange and discussion about research, theoretical and applied, and it will create an amazing opportunity to bridge research and practice. The 2-day international conference program has been carefully structured to encourage fruitful mutual inspiration among researchers. Whether it is inspiration to do more, a spark to reimagine, or a challenge to establish a new norm, you can find what you are looking for in our invited sessions. The 2-day of the conference will be centered on distinguished invited speakers and in-depth discussions of presentations. We are proud to offer more collaborative sessions than ever possible, including opportunities which facilitate a gateway to invaluable connections. Our oral presentations are a great opportunity for our budding researchers to share their work in a less structured environment. PowerPoints will be displayed in a designed virtual space that is open for exploration across 2 days of the conference. We will provide a short time where presenters can do a formal live presentation to those interested in their research. We hope that this virtual conference will definitely be a unique experience on methodological and focused research strategies. Once again, on behalf of Adarsh College, we are proud and pleased to invite students, researchers, scientists, and industrialists from all over the world to take part in these 2 days international virtual conference on emerging trends in chemical science and technology, ETCST 2023, to learn from each other and share experiences. Thank you all.
Thank you very much, ma'am, for your insightful overview of the conference. The key to growth is the introduction of higher dimensions of consciousness into our awareness. I may now request our respectable Vice Principal, Dr. Anita Raman, ma'am, the Dean Academics and President IAC, to introduce our chief guest.
Good morning to one and all. I hope you can hear me now.
Yes, ma'am, we can hear you, ma'am.
Sorry, there was some problem. I could not be heard that side. Good morning to one and all. I am pleased to introduce the distinguished guest of the inaugural session of the International Conference, Professor S. Sriman Narayanan, Vice Chancellor, Wales Institute of Science, Technology and Advanced Studies, a deemed to be university. Sir has a rich experience of more than 3 decades of teaching and research and more than 2 decades of administration leadership. Sir is a renowned academician and an erudite scholar. He received his PhD degree from IIT Madras and is an university gold medalist from the University of Madras in MSc Analytical Chemistry. He had been selected for the prestigious INSA DFT Exchange Visitor and Indo-German governmental collaboration. He has guided 28 PhD research scholars and 25 MPhil research scholars. Some of the distinguished positions held by him are Member Syndicate, University of Madras, Dean Research, University of Madras, Director, Guindy Campus, University of Madras, Professor and Head, Department of Analytical Chemistry, Director, National Center for Nanoscience and Nanotechnology, Chairperson, School of Chemical Science, School of Photonics and Nanosciences, Member Senate, University of Madras, Member Academic Council, University of Madras. The list appears exhaustive, but it speaks volumes of his merit and caliber. Dr. Sriman Narayanan has collaborated with foreign researchers and has been a visiting faculty to foreign universities such as Clemson University, South Carolina, USA, National Taipei University, Taiwan, Germany. He has facilitated around 142 crore rupees of research grant and completed 15 projects. He has 121 research publications in international journals with 2,233 research citations in Scopus indexed journals and a H index score of 25. He has presented 187 papers in conferences, of which he has won Best Paper Award 16 times. His laurels testify to his dedication to research. Sir is the illustrious recipient of the following honors and awards: Tamil Nadu Scientist Award for Chemical Sciences by Government of Tamil Nadu and Academic Achievement Award by University of Madras. Sir, we are honored by your eminent presence and are eagerly looking forward to get enlightened by your profound knowledge. I will end with the quote by Aristotle: "We are what we repeatedly do. Excellence, therefore, is not an act but a habit." Thank you.
Thank you very much, ma'am. As said, each person must live their lives as a model for others. We have one such model amongst us today. I take immense pleasure in welcoming Professor S. Sriman Narayanan, Vice Chancellor, Wales Institute of Science, Technology and Advanced Sciences, VISTAS, Chairman, Indian Society of Analytical Scientists, and former Head, Department of Analytical Chemistry, University of Madras, to address the gathering.
Good morning to all, and thank you very much for your kind words. Respected Dr. R. Shanti, Principal, Anna Adarsh College. Respected Dr. T. Shobana, Premalata, Head, Department of Chemistry, Anna Adarsh College. Dr. Anita, the Vice Principal, Anna Adarsh College. And Professor Susai Rajendran from Pondicherry University. And experts from various countries and the participants from various institutions and my dear students. I'm very happy to be part of this international virtual conference organized by the Anna Adarsh College. Let me start with a quote by Mahatma Gandhi. Our life is a long and arduous quest after truth. The search for truth and knowledge is compulsive. The search is what derives the endeavor. The search is your task. The pursuit of science is to unravel the mysteries as well as the miseries and establish the truth. The virtual international conference on emerging trends in science and technology, organized by the Postgraduate Department of Chemistry, Anna Adarsh College for Women, is one such pursuit to share the knowledge. I understand that the management of Punjab Association has a heritage of benevolent service to the community and that the college upholds the lofty ideals of empowering young women with higher education. An education in science sets the minds to think and develop solutions to everyday challenges. The science of today is the technology of tomorrow, said Edward Teller. The need of the modern society has necessitated the development of technology. As the students of chemistry and the experts of chemistry, you must be knowing that the chemistry is a wonderful subject because you know the whole world is made of materials and matter, and all the materials are made of elements which you study from the periodic table. And if you have a sound knowledge in chemistry, then you will find that is going to be very helpful whichever field you are going to work in your future. So, I am sharing the knowledge from one expert to another experts and disseminating knowledge to the students should be done by way of conducting various conferences and over discussions during the conferences. Normally, the conferences are eye opener for the researchers to think of new field for doing research in future. See, Claude Strauss, a French anthropologist, once said, a scientist is not a person who gives the right answers, rather, he is the one who asks the right questions. So, never stop asking questions. The answer you may receive may be illuminate so many people. The conference, by way of interaction with eminent scientists, will ignite the young minds to pursue research in chemical science and technology. So the chemistry, any achievements that have been taken place in this throughout the world is because of the chemistry, a better understanding in chemistry. Whether it is the revolution that has taken place in the Silicon Valley, or whether the achievements we have got from the ISRO or any intercontinental missiles, nuclear power reactors, everywhere you will find the basic principle of chemistry, which is responsible for all the achievements that we have achieved throughout our lifetime. I am sure that this conference will be a knowledge pool of high quality research findings in the broad field of chemistry, and it will contribute significantly to the scientific community and to the humanity. I congratulate the head and the entire team of staff of the Department of Chemistry for coming up with the conference on such an important topic. I wish the conference a grand success. I also wish that the participants make use of the opportunity by participating in the conference enthusiastically, well, and become great researchers. And I do human service to the world outside. And I am very happy to inaugurate the conference. And I am thankful to the organizers for giving me an opportunity to inaugurate this conference. Thank you. Thank you very much.
Thank you very much, sir, for a contemplative inaugural address. I will now request all our delegates and my dear colleagues to kindly switch on their cameras so that we can take a photograph with the delegates.
VC sir, good morning, sir. I'm Professor Rajendran. I hope that I have met you in 1970s when you were there at the Analytical Chemistry Department headed by Professor Kanathan and Agnes Paul Madam, then Subhaya sir.
Could be, sir. Could be.
You were there, and Dr. Raju was the junior most during that time.
Yes.
I attended one analytical chemistry department. And Mr. Dina Dayalan, he was my colleague at Dindigal, sir. I hope
Okay.
you remember
Oh,
us.
great, great, sir.
Just
It's nice meeting you.
Yes, sir. After a long time.
Okay.
Once again, I request all the delegates and the dear colleagues to kindly switch on your cameras. so that we can take a photograph.
This will be useful for NAC and all.
Morning, one and all. It's my honor and privilege to introduce the speaker of our keynote address, Professor Dr. Suze Rajendran. If one line could sum up the persona of an esteemed speaker, could be this quote by John Ruskin, the English writer and philosopher: "Mighty of heart, mighty of mind, magnanimous. To be this, indeed, is to be great in life. However, this greatness rests lightly on the shoulders of the towering personality of Professor Suze Rajendran, a stalwart academician, a brilliant researcher, and a teacher par excellence. Sir has 5 decades of teaching experience in which he has mentored students and scholars in his long and distinguished. Sir is currently the Professor of Chemistry and Research, directed at St. Anthony's College of Arts and Science for Women, Vindigal. He's also Adjunct Professor, Center for Nanoscience and Technology, Pondicherry University. Sir holds the distinction of receiving 2 PhD degrees, one in chemistry and another in education. This amazing achievement definitely deserves applause. He has guided 60 plus PhD degree holders. Professor Rajendran has more than 600 publications in peer-reviewed journals and more than 4,000 citations. Sir has served as a reviewer and editor for international journals. Sir has 200 plus presentations in national and international conferences, of which 3 were in Kuwait and 1 in Hungary. Sir has completed a prestigious DRDO research project and has 4 patents to his credit. Sir has authored 20 books. He is still continuing his research activities in the field of corrosion and its control, green inhibitors, corrosion resistance for metals and alloys, and various body fluids. Synthesis and characterization of nanoparticles, electro-organic synthesis, inhibitors for pipelines carrying oil, well water. His career highlights include being a member of several councils and professional bodies. Sir has served as a member in Board of Studies for several colleges and universities. He has been a member of Academic Council, Tamil Nadu, Teachers Education University, Chennai. Professor Suze Rajendran is a Fellow of Society for Advancement of Electrochemical Science and Technology, CSIR-CE. He is also a Life Fellow of Electrochemical Society of India, Indian Institute of Science, Bangalore. Sir has been honored with Lifetime Achievement Award for Scientists by the Government of Tamil Nadu. He has received the National Meritorious Award in the field of corrosion twice from the Indian chapter of NACE, an American organization. Professor Suze Rajendran is a lover of music and a mellifluous singer. He is kind and large-hearted. His simplicity and humility teaches life's valuable lessons. Indeed, we are fortunate to have such an esteemed speaker to deliver the keynote address. Thank you, sir, and thank you all.
Thank you very much, Sudha ma'am. I'm very glad and fortunate to welcome Dr. Suze Rajendran, Adjunct Professor, Center for Nanoscience and Technology, Pondicherry University, and co-editor, Journal of Materials Protection, to give the keynote address. We welcome you, sir.
Thank you, madam. Thank you for your kind words. And I hope I am audible to all of you.
Yes, sir, you're audible, sir.
Good morning to all. I am very much delightful to address this August gathering. Today is an important day in the history of our institution, started by the Punjab Association. We are thankful and grateful to you. Through this organization, so many wonderful things are happening. It has talented teachers. It has educated teachers. It has able teachers. It has charming teachers. It has healthy teachers. It has effective teachers and resourceful teachers. I am very much thankful to the organizers for having given me this opportunity to meet one old-time friend, Dr. Sriman Narayanan of Analytical Chemistry Department. I have seen him as a young researcher, but still he maintains that stamina and smiling face. I am very thankful to the organizers for having given this opportunity. When I come to Madras, sir, I wish to meet you in your
Please,
institution
please.
so that my services will be very much useful to you. I am reminded of those days. Dr. Agnes Paul, Sriman Narayanan, Raju sir, Chumbaya sir. We have forgotten Rajeshwari madam also. Rajeshwari madam. Unfortunately, we have missed Dr. Raju at this young age. So- and the prayer song by Dr. Sangeeta was a melodious song. I was very much impressed. I hope that she can become a famous singer if we switch over this her field. By organizing this international conference, the principal of this college, the management of this magnanimous college, the talented HOD of this college, through an active and able teachers. All of them have spread the message of science and technology throughout the world. By 2 p.m. Indian Standard Times, I hope that scientists from Serbia will deliver lectures through this webinar. This is an really international seminar, international conference. From Serbia, a Scopus indexed journal is published, namely Materials Protection, also known as Zastita Materijala. When we approached the editor-in-chief of this reputed journal, Dr. Kaslow from Belgrade University, he readily expressed his acceptance and willingness to publish our conference papers in their Scopus tendency to all people all the time. It is a really wonderful thing. They are promoting science and technology in all possible ways. They give recognition to all talented people. They believe in human values and humanism. They are examples for the saying in our Tamil poet. I think you are familiar with the Kaniyan Pungundranar, Tamil poet, the astrologer poet. He has said, Yadum Bure Yavarum Teli. It means that my friends, my relatives, my kith and kin are living throughout the world. We are world citizens to all all people throughout the world. We congratulate the organizers, the management, the principal madam, HOD madam, the team of scientists, the team consisting of very intelligent teachers, scientists from various parts of the world, especially from Serbia, scientists from all parts of the country. My dear student friends, make use of this opportunity. This is meant only for you, for the uplift of students, not for a vice chancellor, not for a professor, and not for myself. Because we have already achieved something in our life. It is for the organizers. I mean, it is for the students that will be very useful, very much useful this conference. My dear students, make use of this opportunity. I am thankful to my students like Sri Bharati of your college, your institution. I am standing on the shoulders of my student friends. I have produced 60 plus PhD scholars throughout the world and throughout from Kashmir to Kanyakumari. My students are there. It will be very helpful to me. As I told that I have published more than 500 papers. I have received that Lifetime Achievement Award given by Tamil Nadu government in the year 2017. And it was without any recommendation from any side because Dr. Sahayam IAS officer was the chairman of the Science City at that time. So I am very much it is all because due to our student friends and my professors at various levels. I am for the students, I am by the students, and I am of the students. I thank you one and all. I wish that this function may be successful to all the people throughout the world. Thank you. Wish you best of luck. May God bless you all and may God bless this function. Thank you one and all. Thank you.
Please unmute your mic, Dr. Sangeeta.
Yes, sir. Sorry, sir. With this, we come to the end of the inaugural session. We thank all our special guests, delegates, and our dear colleagues who have joined with us for our inaugural session. We are deeply honored by your presence. We may now proceed with our first invited talk. I'm really glad to call upon Dr. R. Vasantha, Assistant Professor, Postgraduate Department of Chemistry, to introduce the speaker of our first session, Dr. Po Waichia.
Good morning, all. I'm filled with immense pleasure to introduce Dr. Po Waichia, Associate Professor, Faculty of Science and Marine Environment, University of Malaysia. He started his Bachelor of Science in Industrial Chemistry, Master of Science in Natural Product Chemistry at University of Petra, Malaysia, and PhD in University of St. Anne's, Scotland. Sir has excelled on various topics such as organic synthesis, green chemistry, and chemical education, etc. He published over 45 research papers, out of which 5 papers are published in this year. This is very remarkable, and with notable 842 citation units. Sir has guided 1 doctoral thesis and 5 master dissertations. He also written a book chapter and also worked as an associate editor for Applied Nanoscience, Journal of Sustainability Science and Management, Bioresource Technology, and SN Applied Sciences, etc. He is the principal investigator of 6 research projects under the grant awarded by Malaysian government, of which he has completed 3 projects and 3 are ongoing. It's an honor for me to welcome you, sir, and thank you for joining with us in this event. Thank you.
Okay, thank you so much.
Thank you, Vasantha ma'am. Green chemistry is a newly emerging field that benefits our planet by finding creative and innovative methods to reduce waste, conserve energy, and discover replacements for hazardous substances. We are really very happy to host our first session on green chemistry, catalysis, and valorization of waste biomass. I may now request our renowned and distinguished international speaker, Dr. Poi Waichia, Faculty of Science and Marine Environment, University Malaysia Terengganu, to take over the session.
Thank you. Thank you so much for the moderator for your kind introduction. May I know how much time I was given for this talk?
Sir, you can go on for 45 minutes.
45 minutes. All right. Thank you. Cheers. Yeah. So let me share with you about my slide today. Where is it? Okay. Share. Okay. Right. Yeah. Here you go. Okay. Can you see my slide?
Yes, sir, we can. We can, sir.
Okay. So, all right. Thank you so much. Hello, everyone. So, my name is Chapowai, and I'm from University Malaysia Terengganu. And thank you so much to the vice principal of Adarsh College for Women, and also to my fellow colleagues. Today, I would like to present to you on the topic green chemistry, catalysis, and valorization of biomass. And I believe everyone here, most of you here, are researchers and also educators for chemistry or at least science subject. And we can be in the front line of movement to train more environmental friendly or conscious chemists. And the discussion today will provide an overview and also a great opportunity to explore what green chemistry means to scientists or to chemists, and the role that we can play so that we can relate our teaching and also research to the sustainability. So this is a little bit about myself. I'm a researcher in the field of organic synthesis with 11 years of independent research experience. And I also branch out in the field of green chemistry and also chemical education. And I've been actively associated with the Institute of Chemistry Malaysia. And previously, I was co-opted for 2 times as a co-opted members. And also, I was a consultant for Green to You company, which is a pest control company, right? And also, I'm now recently serving as the associate editor for Journal of Sustainability Science and Management, and also Applied Nanoscience. All right, so this is the outline of my talk today. Okay, initially, so I'm going to talk to you about the research on green and sustainable organic transformation. Okay, using the bio waste, and followed by the topic on the use of food additive as a sustainable catalyst for organic transformation. Next, it will be followed by the topic on using on the research on radical chemistry. Okay, and also I would like to talk about the merit of working as a green chemist. Okay, and how can we build what they call industrial collaboration. Last but not least, I will also share on my chemical education research. Okay, which focus mainly on chemistry and also environmental sustainability development, ESD, as the whole. So I would like to share on some of the memorable quote that I read from this book that inspired me when I was looking for my research direction. So which led to my current interest, and it is about the green and sustainable chemistry. So here are some of their famous quote. Waste, we need to recognize it is a man-made concept. In nature, there's no waste. Every time a waste is generated, an organism evolves to use that waste as a feedstock. And also, when we think about how to do the same thing in industry, how you either prevent or avoid waste or utilize whatever waste in a variable way. Okay, so in light of this, I was wondering about how can we realize the zero waste concept and how can we apply in the context of sustainable synthesis in chemistry. So as I mentioned earlier, we are a project group which tackling the issue of sustainability, so via the green chemistry approach. And one of my current research lies primarily in the area of waste valorization. And in my research group, we managed to transform the waste onion peel in many useful catalytic systems, and including to synthesize some nanoparticle. And most of these waste, they are derived from nature, right? So this is one of the bio waste that I mentioned, onion peel. Okay, so onion peel is a ubiquitous crop. They are grown not only for human consumption, but also for other therapeutic and also functional purposes. All right. So statistics have shown that the US and the European country, alone, they have disposed about 100K to 500K tons of onion peel annually. Okay, and later on, so some idea pop up in my mind. Okay, how can we relate this bio waste, to green and sustainable, chemistry, and can we find a more effective method or safer method to handle this waste, and also can we find a way to reduce, this what they call it bio waste, so are we able to recycle this bio waste? as a result of high demand, okay, from agriculture and foods, okay. So all this, okay, will has prompted me to my first paper in my research career, okay. So my first idea was to use the water extract from the onion peel, okay, as a catalytic system, right? So this catalytic system, okay, was derived from onion peel waste, whereby I just separate the waste peel from the onion, okay, and then slice it in the smaller pieces, and I soak it into water. And after that, the water extract is separated from the onion peel, okay, and I name it as a water extract of onion peel, right? So based on the pH evaluation, so it is quite acidic, and it is about 3.68 in pH, all right? So once we have obtained the acidic water extract, all right, and then we quickly run some preliminary reactions, okay, using benzaldehyde and also indole as the substrate. So in this way, we can synthesize the the bis indole methanes, right? So surprisingly, we find that the result is quite promising, okay, for this system, okay, and we managed to get a good yield for these reactions. And to widen the scope of my study, okay, so I have bought some commercial available aldehyde. Different aldehyde have been utilized to synthesize, okay, or maybe to prepare different bis indole methanes, right? So in all the cases, so the pure these indole methanes were purified, okay, over a short column, and we have managed to get a quite decent yield, okay, from 62 to 90%, all right. And next, we have explored the the chemoselectivity, okay, of the catalytic system. So in order to do that, I have chucked in, okay, the acetophenone and also the benzaldehyde plus the indole, okay, and we would like to see whether we can get the the set product also, okay, which is the 3I. So gratifyingly, we managed to obtain 3A as the only product, okay, with no 3I being observed in these reactions. All right. So we are also interested to study about the recyclability, okay, of the catalytic system, and based on the laboratory result, so it shows that the catalytic system can be recovered and it can be reused for 5 successive cycles, all right, for synthesis of the bis indole methane, right, with good use. And the next thing we are interested was we are interested to find out about the chemical constituent of onion peel, right? And based on the LCMS result, so it revealed that the most abundant phytochemical in the catalytic system was they are mainly derived from water soluble compounds, okay? So such as the ferulic, caffeic acid, synapinic, cyanidine, canic acid, gallic acid, and other organic compounds, right? And finally, we would like to investigate about the mechanism for these reactions, all right? Although the the catalytic system is not well understood, but based on our understanding and also literature survey, we find that some of these organic acid, they can play a role here to facilitate the organic reactions, all right? So for example, okay, based on the study of Singh et al. 2014, published in Arabian Journal of Chemistry, we find that the canic acid, which also part of the chemical constituent in the onion peel catalytic system. So canic acid can be used as organic catalyst to facilitate the MCR reactions, multi-component reactions. And also we find that some of the chemical constituent identified in henna leaf, okay, such as gallic acid, tannic acid, and so on. It has been published that this compound, okay, can be used to perform the North vinegar condensation, right? And therefore, in our project, we propose that the organic acid, okay, present in the onion peel water extract, okay, they serve to protonate the oxygen, okay, and then on the carbonyl group of aldehyde, and then facilitate the nucleophile attack on the indole, okay, and promote the synthesis of bis indole methanes, all right. And our work has been published in one of the journal, okay, in 2019. All right. So next, We have also explored the synthesis of bisphenol, right, using what do you call that, the ash water extract. And this time we managed to, how do you say, produce a basic catalytic system, right? So what we have done is we also separate the onion peel, okay, from the what do you call the sample onion peel, and then we slice the onion peel into smaller pieces, and then we ash it, okay, in the furnace, right? And we also, what do you call, after we manage to get the ash, we wash it with the distilled water, and the filtered, okay, what do you call, the filtrate is named as the ash water extract. And when we perform the pH measurement, it shows that the pH is quite basic indeed, which is in pH 11. Next, so we have explored the synthesis of bisphenol, right, using different kinds of aldehyde, right? So all these aldehyde were purchased from Adarsh Sigma. So based on the result, okay, we can see that the yield for all these derivatives were quite decent, right, from ranging from 62 to 94%. Next, we also investigated the recyclability for the ash water extract, right? So in most of the cases, all right, from the 5 successive cycle, we can see that the yield, okay, of the synthesis is not much different, okay. So and also we can conclude that this system is what you call is recyclable, okay, and it can also regenerate the desired compound, right, without the significant loss of the synthetic yield. And we are also interested to know about the what you call the element, okay, in the ash water system, right? So based on the LCMS or based on the ICP OES, so we found that the magnesium, okay, is part of the major constituent, right? And also based on one of the literature that published in 2014, we find that magnesium oxide nanoparticle, okay, has been utilized to facilitate the MCR reactions, right? So with this in our mind, so we have just utilized the magnesium oxide, okay, magnesium oxide as the single catalyst to facilitate, okay, the organic synthesis for bisphenol. So we find that by using magnesium oxide alone, so we can also obtain the same result, okay, for the synthesis of bisphenol, right? So in this case, okay, we hypothesize that the element, okay, in particular the magnesium oxide, has played a crucial role in facilitating the synthesis of bisphenol. So this work has been published, okay, in one of the what they call chemistry journal, which is Environmental Chemistry Letters, okay, in 2018. Next, okay, so we have also investigated the synthesis of what do you call that, silver nanoparticle using the water extract, okay, of onion peel as a reducing agent, right? So, and based on our result, okay, the characterization results such as UVVs, TEM, okay, SEM, and so on. So it proved that, okay, we managed to synthesize a very nice, okay, crystallized and also what do you call that, spherical nanoparticles, okay. And this is the result, okay, from what we call it, the HRTM, okay, and also EDX, okay. So in most of the cases, so the TM shows that these nanoparticles, they are in spherical size, all right. So they are in between 0 to 100 nanometer. And we also find that the average of the size of nanoparticle out of 200 nanoparticle, the mean size is about 12.55 nanometer, right? And also, we have tried out the silver nanoparticle, okay, over the catalytic system. So one of the system that I've chosen is acetylation, because previously, most of the method that employed for acetylation, they involve the use of hazardous chemical or hazardous catalysts such as boron, zinc triflate, silver triflate, okay. And in this work, okay, in my case, I've utilized the silver nanoparticle derived from onion peel, okay, and the system worked quite nicely, all right. And we managed to publish this result in one of the journals, right, in 2020. And next, we have also reported the what they call the harnessed dihydropyridine and north vinegar synthesis, all right. So facilitated by using silver nanoparticle derived from onion peel, right? And inspired by our previous success in the green and sustainable organic synthesis, we continue to explore new materials or catalysts to facilitate organic synthesis. So one of the key aspects of my work is using food additive to perform the organic what they call catalysis or organic transformation, right? So one of the what they call paper they have published in 2021, it was about using the what they call SHMP, sodium hexametaphosphate, as organic catalyst to facilitate the oxidation of benzoyl carboxylic acid. So for information, SHMP has been utilized as a food preservative, and in my case, I've utilized SHMP as an organic catalyst, and also in the presence of hydrogen peroxide to perform the oxidation reactions, right? And also we managed to to prepare a manuscript, all right, using food additive as catalyst, to facilitate the organic reactions. And this book was published in 2021. All right. So next, I'm quite interested in radical chemistry. All right. So as you know, this is aryl-nitrile. The end product is aryl-nitrile. So aryl-nitrile is found as the main moieties in variety of compound, and, such as the medicine, agriculture, natural product, and so on and so forth. So the traditional way of making the aryl-nitrile is via the the Sand-Meyer method. So they have utilized some method. So in my case, so I've reported metal-free reactions whereby I just using the third butyl isocyanide as the cyano source to convert the aniline into aryl-nitrile, right? And we have published this result also in the Bulletin of Korean Chemical Society, right, in 2019. So in this slide, I just want to show you about the value and the contribution of in this field, towards industry, right? So as a green chemist, we can also act as an advisory group or play an important role in designing new chemicals, to be used in place of the one that have been proven to be problematic. So in 2021 to 2022, I have been investigating a cheap and green termiticide for pest control company. All right. So in my case, so I've been using some what they call green material, and what they call that in natural material, as a bait, and then I just stuff everything inside in the box, and then put this into a termite infected area, So based on the result, after 1 month or 2 months, the termites have been ceased to be observed, in that area. So this research is still ongoing, and we hope it can produce more promising result. And also, I've been taking part in some competition, right? So I've been innovating some green organic weed preventer, all right, with my collaborator. So we have won some medals and also make some copyright for our product also. And recently we have switched to the use of the palm oil, all right? We also study about the feasibility of using palm oil as a termiticide, all right? And this study is still ongoing, all right? And we also published a paper on using waste cooking oil or cooking oil, as a termiticide. And so I have a chance to collaborate or work closely with a chemical education researcher from South Korea. So he is Professor Daniel Cha Jong-ho, and he's from Daegu University. So far, we have published about 10 to 11 papers, mainly on sustainability and also how to facilitate learning in organic chemistry, right? So as you know, we have gone through the phase of outbreak of COVID-19, and we have learned there are many lessons that we have taken from 2020, right? So one of the main lessons that we learned, from the pandemic is not in my opinion, it is about technology, all right? So the technology about how chemistry can be more relevant and also useful and effective, all right? So this is the the what do you call one of the thing that I noticed, okay, when I teach in my organic chemistry classroom. So I would like to form a bigger picture or coherent framework in my teaching in basic organic chemistry. So as you know, okay, there's a general agreement that organic chemistry is one of the toughest subject, okay, among chemistry, okay. And as a science or chemistry educator, so we believe that what they call an expert learner or a lecturer, okay, they should possess an what they call organized, coherent framework. So in which the knowledge should be linked and contextualized, and making the learned knowledge accessible and form a bigger picture. So in order to do this, all right, so I have incorporated this slide, okay, in my teaching, all right. So at first, okay, so what I do is in my first chapter, okay, in my basic organic chemistry course, I will start remind my student, okay, about the big picture of this topic here. So let's say in the common organic chemistry, in the basic organic chemistry teaching, the first chapter must have involved some Lewis structure, all right. So I will ask my student to focus on the concept of what they call Lewis structure, okay, drawing. And in the second chapter, so we are focusing much on orbitals, atomic orbitals, hybridization, and molecular geometry. And the big idea here that I want my student to learn is about the molecular shape. And next, in the third chapter, my student will be introduced with some fundamental concepts such as the polarity, electron flows within the molecule, and also the polarity, okay, of the bonds and molecules. All right. So the big idea, okay, in the chapter 3 is about learn distribution, okay, of electron within the molecules. And moving on to chapter 4, we can discuss about the acid-base reactions, okay, by applying our previous knowledge on electron distribution, okay, within molecule, okay. And now they know how to explain, okay, the acid-base reaction by using the arrow pushing, all right. So the next chapter, okay, we can apply whatever we learned, okay, such as the theory about Lewis base and acid, okay, to tackle the issue about the organic synthesis, right? So in this way, we can apply, okay, the what they call the big picture in our organic chemistry teaching. So this is how I managed to conduct my lesson online, okay, and also form a bigger picture, so that I can make my teaching more relevant and compelling, okay, to the student, okay, and not merely hypnotize my student, okay, over the what do you call it, the online teaching. So I managed to design some activities, all right, to enable my students to study about sustainability, all right. So this is one of the work they have published, all right. So the main thing here is I would like to students to ponder about what are the ways, okay, that they encounter every day. So how can they reduce it, okay, by recycle it, then reuse it, okay, in their daily life, all right. So, and this is the slide that shows some of the publications that I made, okay, previously, okay. So mainly it is about environmental chemistry and also sustainability, right? And this is my future work, okay, which mainly focusing on green and sustainable chemistry. So, so I would like to thank all these people because without them, I think I cannot accomplish, okay, I cannot go beyond, okay, from what I am now, okay. And so before I end this session, I would like to share with you a quote, okay. So labels put on the people in the school or society such as smart and not very bright, so are not very great importance. Rather, persistence and energy to complete what you have set out to accomplish are the strength that will be the real asset in life, right? And thank you for your kind attention, and feel free to ask any question. I will try my best to handle. Okay, so I pass back the session to the moderator. Thank you so much.
Thank you so much, sir.
Thank you, sir. I am Professor Rajendran. I am very happy to note that you have presented a very good thing. You are talking on food items and kitchen items. It seems that you are very familiar in the kitchen activity, and you have prepared nanoparticles,
Yes.
making use of onion peel extract. Onion peel extract that has been used as reducing agent to reduce and prepare silver nanoparticles. There, I was expecting that UV visible absorption spectrum at 400 nanometer. Have you done that work, sir? Onion peel extract? UV visible absorption spectrum is missing there. Please check up. And I would like to suggest that you can make use of the biocidal activity of these your prepared materials. It will be very useful to the society. That is very my suggestion. I congratulate that your team is doing some wonderful work, sir. Congratulations.
Thank you so much, Professor. Yeah, thank you so much for your kind suggestion.
Professor, we had two questions being posted in the YouTube link. Can I just read it out for you, sir?
Yes, please.
Yes. Sir, you had used water extract of ash of onion peel for organic synthesis. Did you identify the components present in the ash extract which are responsible for catalytic activity?
Yeah, I have done some ICMS, what do you call it, the LCMS experiment, and we also found that there are several what you call water soluble organic acid. Okay, and these organic acid could be some potential organic catalysts that are helpful in facilitating the organic reactions in my case.
Thank you, sir. One more question we have. Can onion peel be substituted by any other bio-waste for acylation of alcohols?
Okay, I don't quite understand about the questions. Can the onion peel extract facilitate alcohol formation?
I have done some work on onion extract also. They have used it in corrosion inhibition study, garlic extract and the onion extract. There the organic compound present is allium cepa, a sulfur derivative, allium cepa. That is responsible for the lacrimatory effect also.
Yeah.
It's boiled, the double bond will shift its position. Then the lacrimatory effect is lost. Before cooking, we have lacrimatory effect. Then after cooking, that effect is lost. So that allium cepa, you can check up all of you. Allium cepa is responsible for your, it acts as actually a reducing agent. It has the ability, that is, it donates the electrons from sulfur and double bond. It donates the electron to the Ag plus. So Ag plus becomes automatically Ag, which is nothing but in the beginning you shown that it is yellow in color. Afterwards, when it is gets precipitated, it becomes black in color. Maybe the size may be growing because of aggregation. If you record UV visual absorption spectrum, will be noticing yellow color will be at 400 nanometer. There is aggregation and growth of the size of the particles, nanoparticles size increasing. The lambda, there will be red shift that will be shifted to longer wavelength, 400, 500, 600. These are my observations. I am also working in this synthesis and characterization of nanoparticles using extracts of seaweeds and plant extracts.
Right, thank you, Professor, for clarification. I learned something today.
Yes. Thank you, sir.
Professor Chia, we have one more question.
Yes, please.
Is there any other medium that can be used for preparation of silver nanoparticles other than aqueous?
Other than?
Then aqueous medium, sir. Other than aqueous medium.
Other than aqueous system. Because all the while I've been using aqueous extract. So far I've only used it aqueous extract only. All right. So I can't comment too much. Maybe Professor Rajendran can give some comment on this issue.
Usually we are doing in aqueous medium only. Maybe we try in alcohol medium. Actually, we have to add some reducing agent, that's all. We have reducing agents like sodium, potassium, tartrate, trisodium citrate. Even you can add glucose, starch, and other. And there are extracts from so many plant extracts. Guava extract has been used to reduce. Seaweeds, many seaweeds have been extracted. That the extracts are from alcohol or from aqueous only. Aqueous is easy and simple. Organic extract will be difficult and
Difficult.
complicated.
Yeah, thank you so much, Prof. Rajendra. Yeah.
Thank you so much, Professor Chia. We would like to thank you on the outstanding presentation. We felt that you have addressed the subject with openness and sensitivity, sir. I believe many of us now would have understood the importance of green materials and how to deal with it much better than before. Thank you so much, sir. Thanks for joining us.
Thank you very much.
We may now move on to our second session. I may now request Dr. A. Sumita, Assistant Professor, Postgraduate Department of Chemistry, to introduce our speaker of second session, Dr. Ramachandran Kuppan, Emory University, Atlanta, USA.
Good morning once again. It gives me immense pleasure in introducing our next speaker for today's session, Dr. Ramachandran Kuppan. Dr. Ramachandran is currently doing his postdoctoral research at the Atwood Department of Chemistry, Emory University, Atlanta. Dr. Ramachandran completed his doctoral studies from IIT Madras under the supervision of Professor Parimalai Anbarasan. He has also worked in R&D lab of PCCL Private Limited, Chennai for a short duration of 2 years. Dr. Ramachandran has been bestowed with many scholastic awards and honors for his contributions to the field of chemistry. Dr. Ramachandran has published many articles in various reputed international journals and has presented his papers in many national and international conferences. We are delightful to have such an accomplished person amongst us to share his expertise. We welcome you once again, sir.
With great privilege and honor, I invite Dr. Ramachandran Kuppan to take over the session.
Thank you ma'am, for your kind introduction. May I share my screen?
Sir, yes, one second.
Yeah.
Yes, sir, you can.
Okay. Is this visible, ma'am?
No, sir, we are not. Yes, sir, now we can see this. Thank you, sir. It's visible.
The slides are visible?
Yes, sir, it's visible, sir.
Okay. So before going to the research thing, I just wanted to share a thing. Like I want to share my experience rather than my research experience. I just started maybe one of the student may get inspired, or so this guy can able to do me, so we can also able to. So they can have some kind of idea. For that reason only, I'm just telling. I just started my career from a small village from Tamil Nadu. Then I did my undergraduate and postgraduate from Loyola College, Chennai. Then I moved to industry. Then I thought maybe this monotonous life is not good. Then I switched to the research. So I'm not a top scoring guy. I'm just average guy. So but my research career end up with a distinction with the best thesis award. So it's all possible. Only thing is just we have to focus on what we need. With that, I'm just like sharing my experience only. My research things are secondary. Okay. So with this, I just move on to my research topic. My research topic is mainly based on group 9 metal catalyzed functionation of CH bonds with strain rings. Okay. So first I will in the introduction part, then followed by I will explain the alkylation using the transition metal, followed by in the chapter 5 and 6 I will explain the allylation of the hines and etorin using the transition metals and strain 3 member rings. And finally I will conclude my talk with current research at Emory. So as we know, like in a textbook level, strain rings are largely present in the natural products and also the biological molecules, and also strain rings are highly reactive in nature, so that it can be exclusively used in the classical as well as the modern organic synthesis. And here I have given the some of the example of the biologically active molecules containing the three-member rings, and also here I have given the few example of three-member rings with their corresponding strain ring. This ring strain energy is the main reason for this exclusive reactivity of the strain ring systems. And also, in the presence of transition metal or any acid or base, strain rings are highly reactive, and it can show diversified reactions such as 1,3 dipolar reaction, 1,2 additions, and so on. So, in the alkylation reaction, if you see the literature, the first CH bond functionation of using the transition metal, 1986 first report was reported. After that, using various transition metals such as 3D, 4D, and 5D metals, there are humpty number of reports are available, and using the various alkylating reagents. Here I have given some of the alkylating reagents. Though here a variety of alkylating reagents are well explored in the literature, they are having a significant drawbacks, such as this kind of starting materials, it is difficult to synthesize, and we cannot explore on the much scope level. Let us say, if you put any substitution on this R2 or any functional groups, most of the reactions won't work. So, to overcome this issue, the hypothesis that maybe we can use the cyclopropanol could be the alternative alkylating reagent, because in the presence of transition metal, cyclopropanol can undergo the ring opening followed by the metal homoenolate formation. These metal homoenolates are highly reactive. It can be act as the electrophile as well as the nucleophile and particular circumstances. So with this idea, we went on to check the literature. If you see the literature, maybe the last 6-7 years, there are a good number of reports are reported. The first work was reported by Lee and Koverga in 2016. Later on, various groups reported. So we also work on this particular cyclopropanol. So first we took the aryl pyrazole as a directing group and cyclopropanol as a coupling partner. In the presence of rhodium catalyst, we screened the various additive as well as the solvents. And the entry number 7, we found that in the presence of copper acetate 100 mole percentage and methanol, we achieved the 88% of field. With this, we went on to explore the scope of this aryl pyrazole as well as the cyclopropanol. In all the cases, we found the good excellent yield, and also this method is applicable for the aliphatic systems also. So then, after exploring the scope of this methodology, then we wanted to understand the reaction nature. So for that, we conducted the control study. In the control study, in the presence of catalyst and metal, it shows the very good yield. But in the absence of the metal as well as the additives, the reaction is not giving the desired product. It shows that the importance of the catalyst and also the additives. Then we went on to check the intermolecular competitive experiment of directing groups. So we took the electronically biased methoxy and nitro substituted directing groups and subjected under the standard condition. We found that electronically rich methox substituted system show the good conversion. It shows that maybe the reaction may going via electrophilic pathway. So then we would like to check the intermolecular competitive experiment between the cyclopropanol. Here also we took the electronically biased system. So here electronically rich cyclopropanol shows the higher reactivity. It shows that the electron rich arene will push this electron towards the ring. Thereby, the ring cleavage might be more faster in the electronically enriched system. Then we wanted to study the competitive experiment between the cyclopropanol as well as the alpha beta unsaturated compound. Actually, this cyclopropanol and the alpha beta unsaturated compounds are equivalent to each other. So, under our optimized condition, we subjected both the system, but unfortunately, the alpha beta, 1,3-diketones not giving the desired product. It shows that the reaction may not proceed via the beta hydrogen elimination. I will explain this one in the, sorry, it's hanging. Hello. Yeah, fine. Okay. So then we wanted to conduct the stoichiometric experiment to trap our potential intermediate. This is the 5-member Rhoda cyclic intermediate expected in our methodology. So under the 60 degrees Celsius and stoichiometric amount of the catalyst, we found that the intermediate 5 was observed. We attempted to isolate this intermediate, but we failed. Then the intermediate was confirmed with the HRMS with very good abundant. Then the intermediate 5 was further subjected under the standard condition. Then we got our desired product of 3A with 43% of yield. Then we extend this methodology to the dialkyl synthesis. The dialkyl synthesis, first we achieved in the 2 direction. One is 1-part manner as well as the 2-step manner. In the 1-part manner, first we conducted we took the directing group and subjected with the cyclopropanol. Under the optimized condition, we got our desired product with 33% yield. To improve the yield, we thought that maybe we can perform the first 2A with the directing group and the standard condition. Then we isolated our desired product. Then we introduced our tertiary butyl substitute cyclopropanol in the second step under the optimized condition. Then we got our desired product 3AH with 71% of yield. So this methodology is very useful for the preparation of the different alkyl substituted systems. So this is the possible mechanism. First, the stable rhodium catalyst in the presence of silver salt and the copper additive. It is giving the intermediate 1, followed by it is interacting with the directing group. It forming the Rhoda cyclic intermediate 5. This potential intermediate further it interacting with the cyclopropanol, forming the rhodium alkoxy intermediate 3. Then the rhodium alkoxy intermediate undergo the ring cleavage. It's forming the intermediate 4. Then the intermediate 4, as I said earlier, this is the equivalent of the alpha beta unsaturated system. So here the beta hydrate cleavage happening mean you will get the 1,4 Michael system. So that can also give our desired product 3A. But in the control study, we could not able to observe our desired product. Instead, the reaction is so fast, it is going via the intermediate 4 to 6 directly, and it deliver the desired product 3A with the help of the copper salt. So next, we wanted to extend this methodology to the benzamide system. So as we know, in the CH1 functionation reactions, almost for a decade, only a strong directing group was well explored, such as indole or aripyrazole or 2-phenylpyridine. They are the example for the strong directing groups. But the major drawback of using this strong directing group is you cannot, once the reaction is completed, you cannot remove this directing group. That is the major drawback. To overcome this issue, people have come up with the idea of using the benzoic acid or amide as a directing group. So after completion of the reaction, using simple chemical transformation, we can detach this unwanted directing group. So with this idea, we extend this methodology to the benzamide also. So there also we explore with a variety of benzamide derivative as well as the cyclopropanol, and all the cases we found the good results. And also here also we conduct the various experiment. I didn't give here for the time consuming purpose. So, and also we explore with this methodology for the naphthalene, as well as the, interestingly, we attached the naproxen, ibuprofen, and gemifroxil medicinal based molecule also we have attached using this strategy. And here also we conducted various control experiment to understand this methodology, and all the results are having good agreement with the existing literature reports. And also we extend this methodology to the NN dialkyl carbamyl attached indole system. As I said earlier, the strong directing groups are having the drawback of after completion of the reaction, we could not able to cleave that one. So for that, the one we can use is benzoic acid or benzamide based derivative. Otherwise, there is a other concept called traceless directing group. This traceless directing group, during the course of the reaction, it will direct the electrophile to add on to the chemoselectively C2 position, then followed by it will cleave during the reaction. So you don't want to perform the extra additional reaction to remove the directing group. This is the advantage of using the traceless directing group. So with this idea, we just subjected our previous optimized condition, and here also we found the very good results. And here also we explored the variety of cyclopropanol, and other directing groups also we explored, and they also given the very good results. And here also we conducted the various experiment, and to show this synthetic utility of this methodology, here you can see the free NHs available. Then also here carbonyl group is there. So we thought that why can't we cyclize this one? So directly I have performed using different bases at host conditions to cyclize directly, but I could not able to achieve because maybe this is not nucleophilic enough to attack here for the further cyclization reaction. So then I thought maybe why can't we reduce this carbonyl group to achieve the desired product? Because they, as we know, like once it become the alcohol, so easily we can eliminate using the any mild bases. So having this idea in our mind, just we subjected and we got our desired product with decent yield. So then here we conducted the control experiment study. So under the standard condition, after completion of the reaction, then I introduced this potassium hydroxide into the reaction mixture. So after 4 hours, we found that our desired product is also formed in a significant yield, and also along with that I isolated the compound 6 with 28% of yield. It might be during the course of the reaction we will get the byproduct, as the after cleavage of this one we will get the acetyl acetamide, we will get the byproduct. Maybe that can be further added on to this alpha to the carbonyl group. And also here we conducted the control experiment. Under the standard condition, we found that our desired product formed in a very good yield, but in the absence of metal as well as the additive, we could not able to achieve our desired product. It shows the importance of the catalyst and the additives. And also here we conducted the deuterium experiment. In the deuterium experiment, we found that the deuterium exchange happening C2 position exclusively 60%. As we know that in generally in indole system, C3s are more reactive. Maybe like we can say like 1 lakh time more faster C3 position is more faster reactive system. But here you can see but exchange is happening at 60% at C2 position. It shows that the 5-member rhodocyclic intermediate help the exchange of the deuterium at the C2 position selectively. So here also we wanted to isolate our potential intermediate. So we conducted various experiment. At this particular condition, we found that this particular intermediate date was isolated and it is further crystallized and it was confirmed by the single crystal XRD. And also this intermediate 8 further subjected with the cyclopropanol, we got our desired product 3A with 33% yield. It shows that maybe this is the pre-catalyst during the course of the reaction. This rhodium dimer catalyst further rearranged to give the intermediate 8. This intermediate 8 can act as the pre-catalyst for the achievement of this our desired product 3A. So then we wanted to study whether the directing group is cleaving concerted manner or stepwise manner. It means the reaction is, I will explain with this mechanism. So first, this rhodium catalyst in the presence of the additive, it formed the active catalyst A. Then the active catalyst A interacting with the directing group forming the intermediate B. Then the intermediate B interacting with the cyclopropanol forming the rhodium alkox intermediate. Then the rhodium alkox intermediate can undergo the bond cleavage, and it is giving the intermediate D. Then the intermediate D may give the intermediate E. Then it undergo the insertion followed by giving the intermediate F. Then after forming the intermediate F, may be presence of the acetate can attack this carbonyl group, further rearrange to give the acetamide derivative, and also with the help of the copper salt, it give our desired product with reductive elimination process. So based on our experiment, you can see here, this is the time dependent control study. You can see this is the you can see around let us say around 6.7 and 6.5 region. You can see the two singlet. These two singlets are corresponding to the one is corresponding to 3A and the other one is corresponding to the 1A. So you can see always from the 3 hour to 28 hour, you can see only these two peak. It shows that the reaction is concerted. You cannot see the our desired product with the directing group. So it means both the directing group cleavage and alkylation reaction happening at the same time, or it is happening so faster. So NMR could not able to detect the detect or distinguish this process. Okay. So like when I explore with group 9 metals, so our aim is to exclusively explore on the cobalt catalyst. But unfortunately, if you see reactivity of the tangential metals, always 4D and 5D metal shows a higher reactivity than the 3D metals. So first, when we explore with the cyclopropanol, equally I given importance to the rhodium as well as the cobalt. But unfortunately, rhodium gave the very good result in the initial stage. So still parallelly we attempted to achieve with the 3D metal copper. So in this case, in the presence of directing group and the cyclopropanol with the 3D metal, we could not able to achieve most of the time our desired product. Instead, we got the 1,6-diketone. So by spending a lot of time, we achieve our desired product 9. So here, as I said earlier, we will get a lot of byproduct. To nullify that byproduct formation, just small modification only I have made. Instead of using the methanol, tertiamyl alcohol with methanol combination can bring down the formation of the byproduct formation and give our desired product 9 with a very good significant yield. Maybe the reason is the methanol is boiling point approximately like 66 degrees Celsius. Maybe it is too high to activate this cyclopropanol and cleaving this bond. So instead of getting our desired product, we are getting always the cyclopropanol cleavage and giving the other unwanted byproduct. So to introduce the amyl alcohol, that boiling point is maybe 128, I think. So the combination of these two, it will bring down the reaction medium temperature moderate. So thereby, it can direct the our desired product formation. So with this idea, just we explore with the variety of first indole directing group. Further, we explore with the cyclopropanol. In all the cases, we found the very good results. And here also we conducted the various experiment. Here I didn't include. Then, so after getting our desired product, so I wanted to extend this this methodology for the very good synthetic application. So first, in the initial stage, so I wanted to cyclize this alkyl group with the C3 indoor system. But unfortunately, as I said earlier, same way I used a variety of acid and bases, but directly it is not happening. Maybe the poor reactivity. So then I thought maybe we can treat with sodium borohydride or a grignard. We can get the alcohol, then we can further cyclize easily. So with this idea, we just explore with a different condition. At 40 mole percentage, 80 degrees Celsius, we got the cyclized product. At room temperature, with 10 mole percentage of PTSA monohydrate, we got the allylated product with 80 percentage. So when you increase the reaction temperature, further it is getting cyclized. So here also sodium borohydride also same principle. First you treat sodium borohydride, you will get the corresponding alcohol. Then you treat with the BF3 thread, you will get the our cyclized product. So this is the my first part of the work. Then I wanted to explore the allylation reactions of arenes and heteroarenes. So equal to the alkylation reaction also well explored in the literature, but it has its own limitations. I will explain in future. Like these are the some representative example of allyl group containing natural product and also biological molecule. So this is the copal catalyzed allylation of arenes and heteroarene literatures. Maybe like last 10 decades, various group like leading research group around the world explore the variety of directing group as well as the different allylating reagents. So, but our idea is most of the reports or every reports are, when we are seeing the literature, every reports are only explore with the heteroarenes. You can see every rings are having the, every molecules having the hetero systems. So we wanted to explore with the arene system. So we took the aryl pyrazole as the directing group. So generally, when you subject with the transition metal with the allylating reagents, heteroarenes will show the higher reactivity. But when you come for the arene system, the reactivity is little slower, particularly with the 3D metals. When you treat with the 4D or 5D metal, the reactivity, you can see the very good reactivity. When it comes for the 3D metal, always it show the poor reactivity. So we screened various conditions and we got our better optimized condition. Using that, we explore with the variety of RL pyrazole, and all the cases we got the good results. Then, so you can see this work we reported in 2017, and also we explored the variety variety of allylating reagents. Still, the major drawback of this allylating reagents, here you can see I have given a variety of allylating reagent present in the literature right now. So the major disadvantage of these allylating reagents are these allylating reagents synthesis is very challenging, and these allylating reagents are synthesis is very easy, but when you subject any bulky group here like R1, R2, any bulky group, let it be any aliphatic or RL system, most of the cases you don't see the reactivity using the existing allylating reagents. So we thought, what could be the alternative allylating reagent for this particular methodology? So we thought, as we know, strain 3 member rings are highly reactive in nature due to its ring strain. So we thought, in generally, in the presence of transition metal, cyclopropene can undergo the metal carbonide intermediates. These metal carbonide intermediates are superelectrophiles that can be further treated with various nucleophile or a desired condition. We can achieve the variety of interesting molecules. So having this hypothesis in our mind, we wanted to check the literature report. So you can see here tetrafuran synthesis as well as the furan synthesis. So many reports are available, but none of them give the allylator product. So we wanted to achieve the allylator product. So we took the indole as the directing group as well as the cyclopropene as a coupling partner. We initially screened with the various metal, then we screened with various additive, and we screened with various solvent. In the presence of copal catalyst 10 mole percentage and sodium acetate 10 mole percentage, in the presence of DCE at 100 degrees Celsius, we got our desired product with 90% yield, and also the reaction is so fast. The reaction is like within 1 to 4 hour reaction complete. So after getting our best condition, we wanted to explore with indole as well as this method is further extended to the aryl pyrazole system. In the aryl pyrazole system, initially we will get the allylator product. Further, it is isomerized to give the vinylator product with a single isomer. But in the case of aryl pyrrole, we got only allylator product with the moderate yield. Then we wanted to mainly explore the cyclopropenes. We synthesized a variety of cyclopropene using literature report. Then we explored, in all the cases, we found the good to excellent yield. In the case of unsymmetrical cyclopropene, we got the mixture of EZ isomers. And also, we wanted to explore this methodology with the aliphatic cyclopropene also. There also, we found the very good yield. Then this method was further extended to the even indoline allylation reaction. The indoline at C7 position getting allylated with a moderate yield. Then we wanted to check the importance of the directing group. What is the role of this particular directing group? So we synthesize the compound with the N-methyl tethered one as well as the directing group attached one. So we subjected under the optimized condition our synthesized probe. So you can see exclusively the allylation reaction taking place at the C2 position of the pyridyl attached one, not the methyl one. It shows that importance of the directing group. This directing group selectively allylate this C2 position of this particular indole, not the methyl one. And also pyrimidal directing group also gave the good to moderate yield. Then we wanted to extend this methodology for the synthetic application aspect. So once we get the allylated product, further it was treated with the BF3 and we achieve the cyclized product with the good to moderate yield. And here we presented with some 10 example. So here also we conducted a variety of control experiment to understand the methodology. So in that, so our idea is to actually to trap this particular intermediate. So during this process, I have screened with a variety of solvent, different temperature, additive. In all the cases, I could not able to isolate this particular intermediate Z, but I can see potentially in formation. Potential formation in the HRMS analysis. So at one point of time, we got some nice purple color solid. So then we just kept for the crystallization. So we recorded the single crystal XRD. We expected maybe the Z, but to our delight, we isolated the intermediate X with 15% of yield. It was very surprise to us. And also here you can see the possible mechanism. So first that copal catalyst in the presence of the additive forming the intermediate A, then it is interacting with the directing group forming the copalta cyclic intermediate. Then this it is coordinated with the cyclopropene. Then the cyclopropene can undergo the ring opening and giving the cobalt metal carbonide intermediate. This active cobalt metal carbonide intermediate D undergo the insertion reaction, then followed by reductive elimination give the desired product 3. And these are the other experiments. So as I said earlier, so always we wanted to explore for the in CH bond functionation reaction with the removal directing group as well as the 3D metal. So some cases we may achieve, some cases we may not achieve our target. So here also cyclopropene we treated with the removal directing group. So in that, if you treat cyclopropene with the removal directing group such as benzoic acid, you will get the lactone formation. So here I have given the some of the interesting biologically important lactone scaffold. So during our initial studies, we exclusively conducted a variety of reaction with the cobalt as the rhodium, but unfortunately, cobalt not giving with the cobalt with combination of removal directing groups such as benzoic acid, benzamide, with cyclopropene not giving the desired product. Most of the cases we observe the byproduct formation, but in the case of using the rhodium, we observe the phthalate formation. So we screened a variety of catalyst, metal, and solvent. Here I did not give the details. So under this particular optimized condition, we got our desired product 17 with moderate to good yield. And when you took the unsymmetrical benzoic acid, we found that mixture of the product formations. So this continuation of this work is still under progress, and also this is the possible mechanism of this methodology. First, the rhodium catalyst will form intermediate A, then it is interacting the benzoic acid, forming the rhodocyclic intermediate. Then it is forming the, by interacting with the rhodium catalyst, then it is undergoing the ring cleavage, forming the rhodium carbonate intermediate. Then the rhodium carbonate intermediate can undergo the insertion at this particular position. Then with the help of this silver salt, it gives our desired product. Then the active catalyst further going for the next catalytic cycle. So here silver is acting as the reducing reagent. So we found the exclusively formation of the silver ring. It indicates that the silver getting reduced during the course of the reaction. So this is this is my current research work. So here I just give just outline of this what I'm doing right now. So whatever we are doing in India, it's just a learning process, and it is just a gate pass to go around, explore outside India. So this is entirely different research work. As we know, like our human bodies or any living being made up of proteins, and proteins made up of amino acids. As we know, naturally existing amino acid, here I have given like 20 amino acids. These are the notation for the 20 amino acids. These 20 amino acids having the unique functional groups. These unique functional groups can be modified. You can see the post-translational modification. Let us say I will explain with this particular slide. You can understand. Okay. So here you can see this is the one peptide. So this is the cysteine. This cysteine can exclusively undergo few reactions. So it can interact the malimide, alkyl halide, and vinyl sulfone. And also here you can see the imidazole. Imidazole can selectively can undergo the iodination reaction, alkyl halides. So by targeting this selectively, one particular amino acid in the protein or a peptide can be used in the biological or medicinal field, and also this selective modification can be used to understand the what are the like defects happening in our body or any living being. Like you can see here. So for what we do first, we will take the protein or peptide, then we will target particular group, particular amino acids. Let us say here I have given the classification of amino acids. These are the amino acids are well explored in the literature. You can see cysteine, lysine, and tyrosines are well explored in the literature. You can see here. Whereas these are the few amino acids are explored not in an extensive manner. But if you see here, valine, isoleucine, leucine, asparagine, glutamine, aspartic acid, these are not at all explored. There is no methods are till now available. So mainly we are working on this particular projects only. So modification of the valine, isoleucine, leucine, asparagine, glutamine. These are the area we are exclusively working on. So modification of selective modification of these amino acids may help us to understand the function of the DNA, RNA, or what kind of like diseases, to understand the disease, and after understanding the disease, how we can resolve this. So these are the thing mainly I'm working on. So I cannot explore. Explore this particular thing here due to like confidential thing. Okay, so these are overall summary. In first we discussed about the allylation of the arenes and heteroarenes using the various directing group as well as the transition metal using the cyclopropanol as the coupling partner. And also here we discussed about the allylation of the arenes and heteroarene using the various directing group as well as the transition metal and cyclopropene as the coupling partner. And these are my research outputs. And I acknowledgement. I would like to thank my professor, Professor P. Anbarasan, for his constant support. And also, I would like to thank my current project investigator, Dr. Monica. And thank you all. Any question?
Thank you very much, sir. So we have some questions being posted in YouTube live stream, sir. So shall I just read it out?
Yeah.
Yeah. Can group 9 catalysts be used for alkalization of thiazoles with cyclopropanols instead of pyrazoles and indoles?
Sorry, ma'am, I don't get your question.
Can
Hello?
group 9 catalyst be used
Yeah.
for alkalization of thiazoles with cyclopropanols instead of pyrazoles and indoles?
Actually, few examples I have reported. Maybe I didn't include. It is possible actually, but you have the directing group should be attached in a proper manner. Then only it is possible. Like, yeah, I will explain with any of the mechanistic scheme. Maybe you may understand better. Like you can see, this is the potential intermediate. So you have to attach. Let us say this is your arene or heteroarene, any arene or heteroarene. So you have to attach your directing group such a way it has to form this potential 5-member or 6-member metallocycle intermediate. If that is the possible, then we can functionalize it. So this is the very crucial. Got it? Hello?
Yeah, thank you, sir.
Yeah,
One
it
more
is
question
possible.
we have, sir.
Yeah.
Can similar reactions be explored with other cyclic alcohols?
Kind of like you mean like 4-member cyclopropanol or
Yeah, maybe, yes,
I
sir.
mean sorry for like butanol
Yes, sir.
cyclic butanol like that.
Yes, sir.
Cyclic. Yes, it is possible, but unfortunately, you know, like the reactivity is mainly depending on the strain rings. Strain, right? The 3-member rings are highly strained. So that is the main reason for this exclusive selective reactivity of cyclopropanol. When it go for the let us say like cyclobutanol or cyclic pentanol, you may not see the same reactivity because you can see the ring size is increasing. So ultimately, the reactivity get reduced. So you don't see the same reactivity, but it is possible because right you can you know in chemistry is nothing is impossible, everything is possible, but you have to find out the route map. You have to day and night you have to try and you have to find out the methodology, but it is possible. But the reactivity wise, like 3-member ring, 4-member, 5-member, this is the order, so accordingly only it will show the reactivity. Okay. Hello.
Yes, sir. Thank you so much, sir.
Yeah.
I especially appreciate your eloquent discussion and the efforts you have taken to enlighten us, sir. We are looking forward for another chance to hear from you. Thank you so much, sir.
Okay. Thank you. May I leave now?
Yes, sir. Yes.
Yeah. Thank you. Already here 2:30.
Yeah. Thank you so much, sir. Thank you. Sir.
Okay. Thank you for the chance. Yeah.
Dear participants, now we'll be taking a break and we'll be joining back at 11:45 a.m. Next session will be our oral presentation 1 to 24. We request all the participants to kindly be ready with your slides. We'll join back at 11:45 a.m. Thank you. Dear participants, the oral presentations will start at 11:30 a.m. in this Gmeet link. We have a separate link for the poster presentation, which is being shared with the participants. The poster presentations will also start at 11:30. We request all the participants to kindly be ready with your presentations to avoid the delay. Good morning, everyone. Once again, we welcome you all on behalf of Postgraduate Department of Chemistry, Adarsh College for Women, for this international conference on emerging trends in science and technology. So now we are moving on to our technical session, oral and poster presentations. Participants of oral presentation 1 to 24 are requested to be ready with their presentations. As we've already mentioned, separate link has been shared to the participants of poster presentations 1 to 11, and we request you to kindly join in that link to give your presentations. Oral presentations will be chaired by Dr. R. Kumaran, Associate Professor, PG and Research Department of Chemistry, DG Vaishnav College, Arambakam, Chennai. And our poster presentations will be chaired by Dr. L. Devraj Stephen, Assistant Professor and Head, Department of Chemistry, SRM Valiamai Engineering College, Katankulattur, Chennai. We are very much delighted to welcome our chairpersons. I may now request Dr. A. Sumita to introduce our chairperson of oral presentation.
Good morning, Madam. It gives me immense pleasure in introducing our chairperson, Dr. R. Kumaran, Associate Professor, Department of Chemistry, DG Vaishnav College. Dr. Kumaran joined DG Vaishnav College in the year 2008, and since then he has been teaching both UG and PG students. Apart from being a great teacher, he's also under his supervision, 5 research scholars and 6 are currently pursuing. Dr. Kumaran applications in various reputable has an H-index score of 11. Area of interest is photophysics and electrochemical hydrogen bodies. Sir has acted as examiner for PhD and MPhil Viva OC examination and is also member of Dr. IQAC Core Vice President of Institution Innovative and member of college also has adorned the board of additional exams in examination camp officer in semester examination at various institutions. Have such an accomplished as a chairperson. I welcome you once again, sir. Mentor not only imparts knowledge but also shares their wisdom gained through their experience by time and civic. Today, I wish all the participants may gain knowledge and wisdom from immense experience.
Thank you, Dr. Sumita ma'am. Kumaran sir, can we start the session?
Yes, ma'am. You can start now.
Good morning, sir.
Good morning, ma'am.
I may now request participant OP1, Suresh V. Nambodari, to kindly share his screen.
Okay, thank you, ma'am. Thank you, sir. എന്താ വേണ്ട ഇത് കഴിഞ്ഞിട്ട്
We request all the oral.
Can you see my slides, sir?
No, I can't able to see the slide. Just give a present screen.
Now?
Yeah,
Okay,
it's fine. Yeah.
Wow, thank you, sir. Myself, I am Dr. Suresh V. Nambudri, Assistant Professor, Department of Chemistry, Sri Krishna College. My topic is phytochemical evaluation of Rasnadi Churnam. Introduction. Rasnadi Churnam is a well-known Ayurvedic formulation mainly used for the treatment of headache, sinusitis, and it is explained in the Ayurvedic text Sahasra Yoga. It contains 23 important medicinal plants. The major plant is Alpinia galenga. In Tamil, it is called as Chittarathai. It is used for the external application, that is rubbing over the crown. The objective of the study: evaluation of anti-inflammatory, antioxidant activity of Rasana Churna, and to identify the major chemical constituents responsible for their activity. Methodology: isolation and analysis of essential oil. Rasana Churnam was hydrodistilled for 5 years in a Clevenger type apparatus, and the essential oil obtained was analyzed by gas chromatography coupled with mass spectroscopy. The aqueous extract of the formulation was also taken, and phytochemical screening was done. The total phenolic content of the uh, formulation was estimated by following Siakotis reagent method, and the total flavonoid content is estimated by aluminum chloride method using quercetin as standard. The total antioxidant activity of the formulation was determined by ammonium molybdate method based upon the principle that molybdenum 6 is reduced to molybdenum 5 to give a green phosphate complex. The antibacterial activity of the formulation was measured by Muller-Hinton method against gram-positive and gram-negative bacteria. And the anti-inflammatory activity of the Rasnadi Churnam was evaluated by inhibition of protein denaturation method using anti-inflammatory drug diclofenac sodium as a standard. The result and discussion. The phytochemical screening shows that the formulation contains bioactive compounds such as alkaloids, polyphenols, and flavonoids. The GCMS analysis revealed that the major compounds present in the Rasnadi Churnam are humulene 1,6-diene-triol and non-decane. This is the GCMS spectrum. The quantitative estimation of polyphenols and flavonoids. Total polyphenols content in the formulation is 15%, and the flavonoid is 6.25. The polyphenols and flavonoids are potent antioxidants, and they possess several biological activities. The antioxidant activity evaluation. The total antioxidant activity of the formulation was found to be 22.35 milligram of ascorbic acid per gram of extract. It indicates that the ability to scavenge the free radicals and to convert it into a neutral species. Antibacterial activity. Antimicrobial activity, the antibacterial activity of the Rasnadi Churnam was tested, and it shows that it did not given any zone of inhibition against gram-positive and gram-negative bacteria at this concentration. The anti-inflammatory activity of Rasnadi Churnam was evaluated by inhibition of denaturation of bovine serum albumin, and it was found to be 92.8 microgram per ml. And that of standard drug diclofenac sodium is 618.52 microgram per ml. The result shows that the Rasnadi Churnam showed a better activity than the synthetic anti-inflammatory drug. So it indicates the potential of that Churnam. Conclusion. Rasnadi Churnam on phytochemical screening found that it contains various classes of bioactive compounds such as polyphenols, flavonoids, and terpenoids. This Ayurvedic formulation showed a good anti-inflammatory and antioxidant activity. The activity is due to the better activity is due to the synergic effect of the identified compounds, polyphenols, flavonoids, and terpenoids. However, further detailed studies at various concentrations are required to prove the biological activities of this important Ayurvedic formulation. Thank you.
Okay, thank you, Mr. Suresh, for your presentation. I have specific doubts regarding your work. In your article, you have said about the anti-microbial activity, anti-inflammatory activity. Why did you choose bovine serum albumin? What is the reason?
Because protein denaturation method, the available simple method is bovine serum albumin, so that we can choose that method. So one of the simple method for evaluating the anti-inflammatory activities, denaturation of protein. This denaturation inhibition is possible by this mechanism, by this drug.
So how did you check for the denaturation by any method?
First we control and then standard using diclofenac sodium, and this our sample, and then it is estimated by that method.
Okay. So the work is in progress, or have you finished this work?
Our first step is completed. Then further studies are going on.
Okay, fine. Thank you.
Thank you, sir.
Thank you, Mr. Suresh, sir. I may now call upon oral presentation to Dr. Sister Jimmy Jose to give a presentation.
Yes, ma'am. Whether my slides are visible, sir?
Yes, it's visible. Fine.
I am Gemini Jose, and my topic for presentation is graphene oxide incorporated iron oxide as a potential electromaterial for supercapacitors. As we know, energy is the driving force behind our existence. And with the rising population and the increasing adoption of technology in developing countries, energy shortage is a situation and which leads to the demand for energy exceeds the available supply. So energy shortage plays a crucial role in our transition to a sustainable energy future. And there are many energy storage devices like batteries, fuel cells, capacitors, and supercapacitors are available. And my topic is for supercapacitors. Supercapacitors store more power than a battery and more energy than a capacitor. It can be charged or discharged very fast and maintain a reasonable energy stored per unit mass. And there are different types of supercapacitors like double layer capacitors, pseudo capacitors, and we can have hybrid capacitors too. And here, especially, I will talk about the graphene-based supercapacitor. As we know, graphene is a single layer of carbon atoms with a hexagonal lattice resembling a two-dimensional sheet, and which has high surface area and good electrical properties too. Here, my objectives are to synthesize graphene oxide from pure graphite powder.
Your slides are not moving, ma'am. Only the first slide is visible.
But here it is moving, sir.
Yeah.
Ma'am, please present your screen in the full screen mode, ma'am. Presentation mode.
It is in for presentation mode only, ma'am, here.
Give it in slide share.
Now it is visible.
It is visible. Just try to move around. No.
Yeah.
Yeah, it's now fine. Yeah.
Okay. Here my objectives are to synthesize graphene oxide from pure graphite powder and to synthesize graphene oxide incorporated iron oxide, characterization by SEM, FTIR, and XRD, and finally conduct the electrochemical studies of graphene oxide incorporated iron oxide by cyclic altimetry. We synthesize graphene oxide by modified Hammer's method, and graphene oxide incorporated iron oxide by ultrasonication method. We characterize the material by X-ray diffraction, and the intense peak of 10.5 is obtained, which confirms that the graphene oxide is formed. And when we come to the XRD of RGO Fe2O3, we understood that the peak at 10.5 is shifted to 26.9, which confirms that graphene oxide is reduced to reduced graphene oxide. The peaks obtained at 26.9, 35.4, 39.6, and 56.0 suggest that there is an formation of alpha Fe2O3 incorporated GO. Coming to the scanning electron microscopy, we got a sheet-like structure for GO, and this is the structure we obtained for iron oxide incorporated RGO. And the IDAS mapping also shows the presence of iron, oxygen, and carbon. Coming to the here we got the OH peak, phenolic peak, and COH peak, and EPC peaks for GO, and FeO peak obtained at 531 centimeter inverse for RGO, iron oxide incorporated RGO. After the characterization, we performed the electrochemical studies after the preparation of the working electrode in the carbon cloth, and here we took 85% of the active material. Then we performed the cyclic altimetry, and we obtained the aerial capacitance of iron oxide incorporated RGO as 119 Faraday per centimeter squared at the current density of 10 millijoule per second, which is 4 times higher than that of GO. Conclusion: we developed graphene oxide and iron oxide incorporated graphene oxide electromaterials for supercapacitor performance and energy storage. Our discovery paves the way for improved capacitors in electronics, vehicles, and renewable energy. Thank you.
Thank you for the presentation. The work was good. I have a basic doubt regarding the iron oxide. So if you are taking Fe2O3,
Yes.
what is the symmetry of that molecule Fe2O3? Is it paramagnetic or diamagnetic there? Because when you're saying about conducting properties, the magnetic properties will also influence the role on graphene oxide.
Paramagnetic maybe, sir.
It will be Fe3 plus. So you say it is an big strong field ligand, it will be.
Yes.
So how did you justify that it's only paramagnetic? Have you taken any study regarding that one?
No, I am not taken, sir. I performed only the cyclic altimetry studies and the JCD studies only, sir. The further studies are going on.
Yeah, but sometimes Fe2 plus and 3 plus also gives a variation in the peak. So that is why I wanted to confirm whether it's a paramagnetic species or diamagnetic.
Okay, I'll check that. So,
Okay,
thank
fine.
you for the comment.
Thank you. Fine.
Thank you, sir.
Thank you, ma'am. I may now call upon oral presenter 3, Ms. P. Vijay Lakshmi, to give her presentation. Ms. P. Vijay Lakshmi, can you kindly proceed with your presentation?
Excuse me, Sangeeta.
Yeah,
Vijay
tell me.
Lakshmi posted a message, ma. She couldn't share a PPT.
Okay, so shall we proceed on with the
Ask
next presenter?
Kavita if her PPT is there in the mail.
Okay, ma'am. I'll just ask Kavita.
You can share, ma.
Okay.
Just find out.
Next participant.
Sangeeta,
Yes, ma'am.
there is some problem in sharing a screen, ma. She will
So we'll
mail
just.
to us. So you call the
Okay.
next participant.
Okay. Okay.
After this participant, she will present.
Okay. Sure. Sure.
Ask Kavita to be ready.
Okay, ma'am. I'll now call upon OP4, Mrs. S. Dharani, to give her presentation.
Yes, your screen is visible.
Yes, sir. A pleasant morning to one and all gathered here. So my topic is on potentiality of biosquanders as effective POP chelating agents, a collaborative study. Introduction. So, water covers nearly 70% of the planet, out of which only 3% is fresh water. So, more than 80% of the water are discharged into these streams without being reused or being treated. So, one of the major pollutants affecting the water streams is POPs, that is persistent organic pollutants. So, these are the toxic carbon based chemicals which are affecting the human health and environment. So the sources which accompany this discharge is from industrial processing and due to combustion process, and most commonly it is used in the manufacturing of non-stick components in the form of Teflon, since it contains the carbon fluorine bonds. So here I have listed out the types of POPs and its chemical names. So my topic of research focus on the removal of PFOA, that is perfluorooctanoic acid, using the biomaterials. So the effects which are caused due to the usage of the PFOAs are listed here. So it affects reproductive system and also causes different types of diseases like breast cancer, liver toxicity, etc. So next, my objective focus on the NAT and eco based materials are identified as a effective PFOA sequestrant, and we have assessed its sorption capacity in lab scale experiments and the enhancement of chelating property by chemical modification. And they have characterized using some analytical tools like SIM, EDAX, TG, DTA, and IR, and they have optimized using various parameters in batch experimental setup, and finally it is compared with the batch results. So the materials chosen for my study is APS, that is Anis plantirhinos legs, and also Magnolia champaca fruits. Both were given the treatment with acid and the basis for 3 hours, and it was pounded and categorized into different mesh sizes ranged from 22 to 85 BSS. So the treatment was given in order to enhance the surface properties of both the sorbents. Initially, the pilot study was conducted for 100 ppm of PFOA with 5 milligram dose ranging from this 22 to 85 bss with the contact time of 30 minutes. So all the different type of mesh sizes exhibited 85 percentage removal of PFOA in both the cases, in case of both the sorbents. So batch equilibrium setup was considered for this PFOA anise system and PFOA magnolia champaca fruits. So the particle size was chosen as 85 BSS, that is 0.18 mm. Since smaller the surface area, greater will be the absorption capacity of the toxicant. So initial concentration setup was 3, 6, 9, and 15 ppm, and dosage we have started with 0.5 to 2 milligram, and contact time ranges from 3 to 21 minutes, followed by 25 and 30 minutes. So 50 ml of the sorbate and depicted sources of the sorbent was taken in the iodine flask, and it is kept in the rotatory shaker at 120 rpm. They are shaked for the periodic time intervals and finally filtered and analyzed using UV visible spectrophotometer at the lambda max of 390 nanometer. So here comes the results and discussion of both the ALP and MCF. First, we are going to discuss about this FTIR. So in this case, three IR spectra are depicted. So ALP and treated ALP and PFOA loaded ALP. So in this case, we have obtained the peak band at 3094 and 3284, which confirms the absorption of PFOA by the sorbent material. That is, carboxyl group is absorbed by the sorbent, and a peak which is observed at 1360 centimeter inverse corresponds to the CF2 group which is present in PFOA. So here comes the SEM and EDAX images of native, treated, and the loaded composites. So in this loaded type, we have a new peak which is obtained for the fluorine at 1 keV, finally confirming the absorption of PFOA by the anise. So next comes the FTIR and SEM EDAX images of Magnolia champaca. So in this case, we have obtained the IR spectra. So here, the prominent peak at 793, which shows the supporting nature of the silicon group in the sorbent material, and also the intermolecular or alcoholic OH group is confirmed by the presence of peak at 3486 centimeter. So finally, a peak at 115 and 1327 specifies the CF2 absorption. So the 3191 centimeter inverse corresponds to the carboxylic acid absorption by MCF. So here are the SEM and the EDAX images of PFOA absorption by the fruits. So here we have obtained a new peak at around 2 Kelvin, 2 keV, which corresponds to the absorption of fluorine. So next, coming to the TGDTA and the effect of initial concentration and dosage studies. In case of TGDTA for the anise legs, we have received the two peaks, one exothermic and endothermic peak. Exothermic peak corresponds to the removal of the water molecules around 100, and around 400 to 500 we have received the peak, which may be due to the decomposition of calcium carbonate to calcium oxide and carbon dioxide. So in case of this initial concentration and dosage, the maximum absorption of 94% was obtained for 9 ppm concentration among the various studied concentration. So in case of dosage, we have obtained maximum dosage for 1 milligram, that is with the fixed 9 ppm concentration and 1 milligram dosage at contact time of 9 minutes. It have given the result of 94% PFOA removal. Then coming to this Magnolia champaca fruits, here we have received two endothermic peaks, initially maybe due to hydration. So next peak around 400, which may be due to the rupture of C double bond O and C bonds in the which may be present in the ring. Next, coming to the initial concentration and dosage, here we have received the maximum removal of 91% at 9 ppm concentration. The maximum dose is 1.5 milligram. So conclusion is both this anise and magnolia were chosen and tested for this PFOA, which registered 94% removal with respective anise legs and 91% with that magnolia champaca. And also this characterization of both the pre and post run materials, it revealed the appropriate results. So from the observations, it is evident that both the bioscanders exhibited the excellent sequestration capacity towards PFOA removal. So these are some of the references.
It's a good presentation.
Thank you, sir.
It's a good presentation, and a lot of characterization methods have been carried out.
Thank you, sir.
One question now: what is the role of monitoring the absorbance at 390 nanometer like that? So, what is you have inferred from that?
So usually this PFOA is a colorless liquid. We will prepare the complex in order to get absorbed at lambda max of 390 nanometer. So there are different wavelengths for different materials. In case of, we will be seeing for UV normal visible spectrophotometer. So in that case, the lambda max is fixed as 390 nanometer for this PFOA complex, sir.
Oh, what is the thing you are monitoring at 390?
Absorption, sir. Absorbance.
Absorbance of what species you are monitoring? Any specific nature you are monitoring at 390?
Sir, this is which was reported in the literature for this PFOA and fluorescence studies. The wavelength should be set as 390 nanometers, sir.
Yeah, whether it gives a sharp peak or it's a broad peak. That is my question.
So, sir, we are only noticing the absorbance. With respect to peak, we will be getting the broad band at only in IR, confirming the presence of the functional groups. That is, it been absorbed by the sorbent or not.
Okay, you're just monitoring the absorbance at a particular
Absorbance
level.
value, and we have calculations to carry out the percentage removal. So, only absorbance will be, and that value alone will be taking for calculations,
Okay.
not with respect to any peaks.
Fine. Okay. Fine.
Okay, sir. Thank you. Thank you so much.
Thank you, Dharini ma'am. I may now call upon OP5, Mrs. P. Indumati, to give her presentation.
Good afternoon, ma'am. Is my screen visible, ma'am?
Yes, ma'am, it's visible.
Good afternoon to everyone connected here. Myself, P. Indumati, performing my research in environmental chemistry under the guidance of Dr. Nithalakshmi and all. Is my audio clear?
Yes, you're audible. You can, yeah.
Shall I proceed, sir?
You can carry, can you?
In intro of my work, I have done the treatment of aqueous metal solution using absorption. And based on the data collected, freshwater availability of 3% is highly used for day-to-day activities in our regular life, involving all the industrial processes and household processes. Based on the various processes we carried out, water is highly polluted through point and non-point sources, such as the outlets from factories, vessel washings, farms, and other road and development works. Among the various pollutants that enter the water bodies, pharmaceuticals, dyes, metals, and pathogens, pesticides, and other few toxicants are of main concern. In my current study, I have concerned about the heavy metal pollution in water bodies. The picture depicts the a small bioaccumulating process of heavy metals into the water bodies. So that is the heavy metal loaded wastewaters from industries. That is of various industries, that is including mining and agriculture process and urban development, enters the water's body, and it is non-biodegradable and has a high persistent nature, and hence gets settled in the water bodies for a long time, affecting all the organisms through bioaccumulation process. In this current study, I have particularly studied about the toxicity of zinc from water bodies, and I have performed only the laboratory scale experiments current now. And my metal, the chosen metal zinc as of divalent ion is used in galvanizing industries, spraying, plating, and painting industries. Zinc toxicity causes respiratory problems, neurological problems, and gastrointestinal problems, even in a minute level. The method used for treatment in my study is adsorption, where adsorbate and adsorbent are involved in the study. Adsorbate solution is the metal solution which we employ, and adsorbent is the material which we choose to remove the metal solution from the water medium. In the current study, we have used biosorbents, but commercially available sorbents are also procured and used. But we have focused only on the novel biosorbents, such as materials from sea, natural sludge and soil, ore minerals, industrial wastes, agricultural wastes, etc. In my current study, I have chosen Magnolia Campaca barks as my sorbent material, which is collected from the localities of Coimbatore. And I have cleaned, the barks were cleaned, pulverized, and powdered and crushed into powdered forms, and is labeled as RMCB. The raw material is then treated with a 0.1 normality of hydrochloric acid for 4 hours to enhance the surface area, so that for the further treated material is used for adsorption studies. Batch studies were performed to analyze the removal efficiency of treated bark material, and the influencing parameters such as particle size was varied from 0.18 mm to 0.71 mm, and agitation time of 3 to 30 minutes with 3 minutes interval time, and initial concentration of 2 to 20 milligram per liter with 2 milligram per liter interval, and dosage of 50 to 300 milligram with 50 milligram interval, and pH up to 3 to 13 was characterized, and temperature of 283 to 333 Kelvin was studied. Result and discussion. The microscopic images shown here is of the Magnolia campaca box in the raw and treated form. From the picture micrographs also, it is evident that treated Magnolia campaca box show more surface pores than the untreated material. From semi-redax analysis, it is evident that pores available in the unloaded treated material, and after the absorption of zinc, the pores disappears, which favors the good sorption capacity of TMCB. From the EDAX spectra, change in peak intensity of silicon shows, and the introduction of new peaks for zinc in the range of 2 to 4 electron volt, kilo electron volt, indicates the sorption of zinc to divalent ions onto the material surface. From the FTIR analysis, the unloaded material showed a characteristic peaks at 3251 centimeter inverse and 1090 centimeter inverse, which corresponds to the hydroxyl and alkoxyl group. Shift in the narrow peak of at 1629 centimeters inverse in the unladen spectra to the 1735 centimeters in the lower spectra indicates that the carbonyl group stretching, and introduction of new peak at 2281 in the unloaded spectra also implies the metal sorption and stretching of C double bond over peaks. New peak at 2949 centimeters inverse indicates the stretching of CH bonds, favoring the binding of divalent metal ions onto the material surface. Batch studies result. The influential parameter studies is given in the form of bar diagrams. For particle size, 0.18 mm to 0.71 mm particle size was studied, and better removal of 98% was observed at 0.18 mm particle size, which showed that smaller the surface area, smaller the particle size, greater the surface area, indicating higher absorption efficiency. And the effect of agitation time, 0 to 30 minutes, 3 to 30 minutes of agitation time was performed with 3 minutes interval, and a maximum of 98% removal was observed at 12 minutes, indicating the better removal efficiency of zinc 2 ions by the chosen material. Initial concentration study graphs indicate that concentration removal efficiency was maintained at a removal percentage of 98%, up to an 12 milligram per liter of the initial concentration, and behind which it showed us slow decrease in the removal. Effect of dosage. Increase in sorbent doses increases the removal percentage, and a maximum was attained at 250 milligram, and behind which the saturation point was occurred, and at the 300 milligram it showed a small decline. Effect of pH. Effect of pH plays a major role in the absorption of metal ions onto the material surface. 90% removal was observed at pH of 5, favoring the slightly acidic medium for metal absorption to occur. Effect of temperature. Effect of temperature was carried out from 283 Kelvin to 333 Kelvin, and better removal for observed at room temperature of 303 Kelvin, and behind which the removal efficiency decreased, which favors that the vibration of metal ions on the material surface may decrease the absorption efficiency. Thus, from all these studies, we have concluded that removal of 98% occurred for removal of 98% of zinc ions was occurred for the chosen material, and further studies of employing the laboratory experiments to industrial scale is on process. Thank you.
Okay, thank you for the presentation. I have a basic query on that preparation of your materials. So, how do you classify a metal as a heavy metal or a non-heavy metal?
So based on the atomic numbers, we classify as a heavy metals. That is, heavy metals that comes under with a higher atomic number, such as mercury, cadmium. All those are considered to be heavy metals. And non-heavy metals, we don't classify as non-heavy metals, but based on its toxicity and permissible limits.
Okay, if your information is based on this one, zinc is relatively needed in our body, and it is considered to be a rare toxic metal.
Yes, sir.
So, what is the source of zinc in water? How zinc 2+ would have been there?
So from plating industries, zinc comes under the effluent. So a permissible limit as given by WHO standards indicates that only 0.05 milligram per liter of zinc is allowed to be in the wastewaters. But as of literature review, it is evident that zinc is released at a great large amounts than the prescribed limits. Hence, we have chosen the zinc for the studies.
Okay, if it's from the tanning industry and electroplating industry, we
Yes,
also
sir.
expect a lot of nickel and chromium also. So,
Yes,
are they
sir.
more toxic than nickel? They are considered toxic than zinc. So, how do you separate them if it is the case?
So it's in the case we first here we have concern only on zinc, but the study with chromium is also I have proceeding the study with chromium also, but data have not been obtained. I have not shown here, sir. So comparison.
Okay, fine. Good.
Okay, sir. Thank you, sir.
Thank you, Mrs. Indumati. Next, we have OP6, Mrs. Benazir Ali. Mrs. Benazir?
Can you hear me, ma'am?
Yeah. Yes, Benazir. You can give your presentation.
Is it visible, sir?
Yes, it's visible.
Okay, first screen visible for you.
You can increase the screen size resolution. Yeah, it's okay.
My full screen is seen, sir. First slide.
Yes, Benazir. Yes.
Good morning, sir. Good morning to all staffs. My topic is synthesis of 3,4-dihydropyrimidinones via Bignelli reaction and exploring their ADME profile and antimicrobial and anti-cancer potentials. I'm doing my PhD under the guidance of T.K. Shabir in New College. You can see, sir?
Yeah, you carry on.
Yes, thank you, sir. 3,4-dihydropyrimidinones as a special class of heterocyclic compounds get more attention by the researchers due to their pharmacological properties. In the present study, we are preparing dihydropyrimidinones for the first time from bis dialdehydes and in silico investigation of their ADME properties and molecular simulations to find the lead compound. 5,5-methylene bis salicylaldehyde is used as a starting material in many researches. This 5,5-methylene bisalicylate reacts with acetophenone to produce chalcones, and chalcones are important for many disorders like viral disorder, cardiovascular diseases, parasitic infections, and brain diseases, and many important, and also as preparation for coordination polymers and catalytic reduction. For the first time, we are preparing bisdialdehydes from, dihydropyrimidinones from bisdialdehydes. The scope of my research.
Synthesis and characterization of dihydropyrimidinones. This involves exploring the various synthetic methods and techniques to obtain these compounds and analyzing their structural and chemical properties, and investigate the structural activity relationship of dihydropyrimidinones to understand how different structural variations impact their properties and potential applications, and evaluating the biological activity of dihydropyrimidinones used as drugs, antimicrobial agents, and other bioactive compounds, and investigate their potential applications in various fields. The objective of my research is to, in preparing DHPMs with a focus on yield, purity, and scalability, and efficient synthesis through thorough characterization and structural activity relation, and identify their application and safety and environmental conditions in publication and dissemination and collaboration. Experimental methods. We have carried IR, NMR, mass, and CHN analysis and ADME studies, molecular docking studies, antimicrobial studies, in vitro anti-cancer activity. And first, my first scheme is synthesis of the bis dialdehyde. From salicylaldehyde, using trioxane and H2SO4, we have prepared a bis salicylaldehyde. This is the experimental setup for the bis salicylaldehyde. In nitrogen atmosphere, we have prepared bis salicylaldehyde using salicylaldehyde 80 grams and acetic acid and 7.0 gram. And in nitrogen atmosphere, concentrated H2SO4 and acetic acid was added in drops to produce the bis salicylaldehyde.
Excuse me, Benazir.
Yes, ma'am.
Sorry to interrupt, Benazir. Why don't you give the play option so that the full screen can be viewed properly?
The video, ma'am?
Yeah.
I couldn't.
Go for play option. Yes.
Is it seen, ma'am? I couldn't view actually.
We are not able to view it.
You can view, ma'am?
No.
I couldn't view, ma'am.
Oh, you're not able to play the
I'm playing, but I gave play option, ma'am, but still it's not
okay.
Playing, ma'am.
Okay, then carry on.
Yes. This is my second scheme. You can hear me, ma'am?
Yeah, you carry on.
Yes, sir. Thank you. This is my second scheme. From the prepared bis dialdehyde, we are preparing DHPM. For the first time, many researchers have prepared DHPM because of their many applications in the medicinal field: antiviral, anti-tumor, antibacterial, antioxidant, anti-inflammatory, and anti-hypertensive properties of dihydropyrimidinones. But for the first time, we are preparing from bis dialdehydes. We are preparing a novel compound, new compound, DHPM, using, we have taken the bis dialdehyde with, it is a Bignelli reaction mechanism, bis dialdehyde with the 3 amines, and we have used urea, thiourea, and guanidine, and an active methylene compound like acetyl acetone, ethyl acetoacetate, and dimidone. This is my second scheme. Results and discussion. For the bis, this is the NMR of the bis dialdehyde. The aromatic hydroxyl proton at 11.29, and we confirm the formation of the bis dialdehyde with the CH2 group formed in through IR, and 9.82 peak due to aldehyde proton, and 3.99 at the CH2 singlet proton, and aromatic protons resonating at 6.83 and 7.20. And next is my NMR spectra of DHPM. First, it was the NMR spectra of monomer, and it was now it is the NMR spectra of DHPM. And the NMR spectra of DHPM, the peak emerges at 10.8, attributed to the singlet proton associated with the aromatic OH, and the aromatic NH protons are observable at 2 distinct peaks, one as a singlet and the other at 7.17. The urea moiety in cyclization reaction, additionally, the ethoxy proton resonates at 4.53. This is the IR spectra of the compounds. For a few compounds, we have taken the IR spectra. We have prepared 9 compounds actually for the first scheme, for the first set of DHPM using salicylaldehyde as the monomer compound to prepare the bis-salicylaldehyde. In the first set, we have given the IR for 4 compounds. It is for DHPM1, DHPM4, and DHPM7. The IR values confirm the presence of CH2 group and the other, for NH stretching and OH stretching. And the drug likeness property. The drug likeness property of the DHPM is assessed using the tool SwissADME. We have used the SwissADME tool to we use the SwissADME tool to analyze the drug likeness property of the DHPM. By managing the physicochemical properties, the physicochemical properties tells us the molecular weight, number of hydrogen bond donors, number of hydrogen bond acceptor, and the and log P values and TPSA values. These values have the optimal range. It is a SwissADME free web tool, online tool for assessing the drug likeness properties. The rule of 5 by Lipinski, and DHPM evaluated for the properties of Lipinski rule of 5 to distinguish between the drug likeness and the non-drug likeness molecules. According to the drug likeness, the Lipinski rule of 5, it should have, the monomer must have molecular weight less than or equal to 500, and number of hydrogen bonds must be less than or equal to 10. The number of hydrogen bond acceptor must be less than 10, and log P values are nearly less than 5, and the TPSA values are more or less near 140. All my monomers satisfy 3 criteria, which accepts the properties for the good drug likeness molecule. And we are assessing the ADME properties. From the SwissADME tool, we can assess more than 25 properties, but still for consideration, we have taken few properties and listed here. From the ADME properties, we can, so how the ADME stands for administration, distribution, metabolism, and excretion of how the drug enters the body and leaves the excretion. After how it is enters the body and how it affects our cells, we can, this ADME, early prediction of ADME properties in the clinical trials exhibit pharmacokinetic related failure in the clinical trials. Next is the bioavailability radar. The bioavailability radar is the bioavailability radar provides us the optimal range for all these properties like lipophilicity, size, flexibility, insaturation, insolubility, and polarity. And if the radar, if our compound falls within the radar, it is considered as a good drug likeness molecule. The boiled egg is the bioavailability radar itself rapidly assesses the molecule for becoming an oral drug. The boiled egg radar provides an insight of the passive gastrointestinal absorption. It is the white of the egg is of high passive intestinal absorption, yellow is of high blood-brain penetration. So our molecules say in the safer area, which has low absorption and the molecule does not affect the brain. And we have considered, conducted the antimicrobial activity. DHPM shows moderate to good sensitivity against Enterococcus fecalis, Salmonella typhi, and Candida sp compared to the standard nalidixic acid and niacin. Among these, interestingly, the compounds 4, 6, 7, 8, and 9 found to be selectively active against gram-positive bacteria. And in vitro anti-cancer activity. We have performed the in vitro anti-cancer activity in collaboration with the Rajkot University, Saurashtra. Priya Patel ma'am, HOD of Rajkot University, she has done the anti-cancer activity for us in collaboration. From the in vitro anti-cancer activity studies was tested by using the NTT assay against A549 lung HeLa cell. The lower IC50 values indicate higher potency, meaning that the compound is effective at low concentration, inhibiting the cell viability or the biological process being studied. Higher IC50 values indicate lower potency. DHPM's 219 displays high cytotoxic activity with a statistical significant reduction in cell viability. The IC50 values is a measure of compound's potency. Lower IC50 values indicates higher potency, meaning the compound is effective at lower concentration, inhibiting the cell viability for the biological process being studied. Conversely, higher IC50 values indicate the lower potency. Molecular docking studies. Molecular docking studies examine the binding affinity and nature and type of interaction, both non-bonding and bonding interaction between the compounds and the amino acid residues of the compounds. Among all the compounds 1 to 9, compound 9 observed higher negative docking score. They found to have minus 7.791 kilocalories. The docking results are clearly indicate the compound bind the active site of the receptor. Conclusion. It is important to note that pharmacokinetic properties of DHPM can vary widely depending on their specific chemical structure, which can be modified to optimize their properties for the drug development. The early prediction of ADME properties in drug designing phases considerably diminishes the fraction of pharmacokinetics-related failure in the clinical trials. Dihydropyrimidinones and related compounds have been investigated as a potential lead compounds for developing new antimicrobial agents. All DHPMs are cytotoxic against the tested model. Further, the DHPMs can cause a decrease in cell viability as a function of increase in concentration, demonstrating the concentration dependency. Dihydropyrimidinones have demonstrated activity against a wide range of microorganisms, including bacteria and fungi. Thank you, sir.
Thank you. Thank you, Mr. Benazir. You've given a very elaborate presentation of your work. I have 2 queries regarding your studies.
Yes, sir.
So you have mentioned something like molecular docking studies. So
Yes,
what is
sir.
the protein you have taken?
Come again, sir.
What is the protein you have taken, the receptor?
Receptor, we have VGFR kinase protein, sir.
Okay, it is a PDB structure what you have given. Okay.
Yes, sir.
So what is the major force of interaction which is governing the stability? Hydrogen bonding or hydrophobic?
Hydrophobic bond, sir.
So what is the color signifies that? Can you just get back? You need not get back to the slide. What is the colors refer the green color, the pink color? Can you just get, no, need not, slide is not needed. Can you just tell?
Okay. 1 minute. We have given the 2D and 3D structures is given, sir.
Yeah, in
Actually,
2D structure.
Yes, sir. The pink colors are nothing but the aromatic rings, sir, actually.
Yeah, in hydrophobic interactions, which do you feel it's more predominant?
The table, actually, I didn't mention here, sir, actually.
Okay. Okay, given ADME. So
Yes,
you have
sir.
left that T. What is the T stands for?
Admit, actually, T stands for transportation, actually.
Toxicity.
Yes.
So you have not carried that work?
We have, for ADME and ADMET, we didn't study, sir. For ADME properties alone, we have taken there, actually.
Okay, fine. Good.
Metabolism and excretion we have.
Okay, fine. Okay.
Thank you, sir.
Thank you, Mrs. Benzir.
Thank you, ma'am.
Sir, OP3, Mrs. Vijay Lakshmi is ready with her presentation, sir. Can she
Okay, fine.
present now?
Yeah.
Actually, she's having some, she's not in a position to do her share her presentation, so we will be sharing it, sir.
Okay, fine.
Mrs. Vijay Lakshmi, are you ready?
Yes, ma'am, ready.
Yeah.
Full screen. So myself, Vijay Lakshmi, I'm doing PhD under the guidance of Dr. Shanmugavalan, Assistant Professor, Department of Chemistry, Tamil Nadu Open University. So my topic is enhanced photocatalytic removal of chlorophyrifos with a novel vanadium pentoxide, nitrogen doped graphite carbon, and zinc oxide nanocomposite under visible active. So define introduction of my work. A substance is activated by absorbing a photon and is capable of accelerating a photoreaction without being consuming, said the photocatalyst. So the substance are invariably semiconductor. So there are so many semiconductor using in application oriented, which means semiconductor means titanium dioxide and zinc oxide, graphite carbon nitride, so zirconium oxide. So many semiconductors are there. It is application for environmental oriented. So semiconductor oxide photocatalysts have been increasingly focused in recent years due to their potential application of the solar energy as well as the environmental purification. So my work is the environmental purification. So photocatalyst. So what is the word can split it? Photo means light. Catalyst means using a photocatalyst. The catalyst means it is just the alternate the reaction, whether speed up or slow up. The slide shown the mechanism of the basic mechanism of
I
the
can't see the
photocatalyst.
slides, ma'am. Slides are not moving.
So next slide one. The next one. Next slide one. Third one. Next one. Synthesis part. Next slide one. Yes, ma'am. Okay. So I just chosen the three material. Why have chosen the vanadium pentoxide? It is more visible active catalyst. And then why I said it is visible active means from the previous work I chosen this catalyst, and then nitrogen doped graphite carbon also the visible active. The zinc oxide is the low cost but it is the semiconductor. And then how the way I used to synthesis the material means weight implication technique is used to synthesis material. It is the low cost one, and simply used to make the composite. So just from this work I chose to only the equal ratio of the catalyst, which means 1 gram of milligram of the vanadium pentoxide and nitrogen graphite carbonated and zinc oxide taken and put in the 30 ml of ethanol. The obtained solution was continuously and subsequently heated at 70 degree from still evaporate the solution, then kept in the oven and take over the next day for the further work. So the composite are prepared for the conformation. So conformation first move for the X-ray diffraction. So X-ray diffraction I chosen. I took a nitrogen doped graphite carbon as well as the vanadium pentoxide and zinc oxide and composite. So X-ray is used to analyze the structure characterization and the phase determination of the three component. And then the pure nitrogen doped graphite carbon is the phase of the. It's shown the two peaks. So one is the 100 and next one peak is 002. It is graphited phase. The two diffraction peak is the 2 theta value is 13 degree and as well as the 27 degree Celsius. It is matched with the JCPDS card, that is at 871526, and then next I move toward the vanadium pentoxide. It should also show on the peak 200 and 010. 110, 101, 400, 111, 020, and then 600, 021, as well as it is shown in the phase level is orthorhombic phase, and it is also matched with the JCPDS card, which is 010359. And next moves one zinc oxide. It also matched with the JCPD card. It's a sweat structure. So my composite, there is no the previous slide one. A previous slide one. Yes, ma'am. So there is no extra peak in my composite. Though as it is, what I taken the zinc oxide and vanadium pentoxide, nitrogen doped they showing the same peak, only the present in my composite also. Next slide, ma'am. Next. Yes, ma'am. Next I move for the transition time analysis, ma'am. Next. Next slide. Yes, next. Yes. Yes, and the theme showing the theme image showing to the vanadium pentoxide and nitrogen doped graphite carbons, and the composite shown. It's a vanadium pentoxide composed in small typing packed. It's showing the nano rod structure like it's shown in my figure, as well as the composite as shown, and then the vanadium pentoxide structure is the nano rod, and the composite as well as shown. The D spacing is I have gotten from the image. It is a 0.305 nanometers, and then the zinc oxide is agglomerated with the nano composite. my graphic carbonate compound is it look like a sheet-like structure. Then zinc oxides and vanadium pentoxide also agglomerated with the graphic carbonate. Next slide. So XPS next one, XPS. So XPS determined the chemical bonding and the composite of the composites, which I have mentioned before. So what are the things I have taken? The vanadium, oxygen, carbon, nitrogen, zinc, all the material presented in my XPS. Vanadium is shown the two peak located. It is shown in the V2 peak, and then the zinc 2p also shown in the 2 peaks, and carbon also having the 2 peaks 248.62, and then 287 for the carbon, and nitrogen also having the 3 peaks, and oxygen also having the 3 peaks. It is currently presented in the located phase. Next slide. Yes, it is the graphical abstract of my work. So I just put the my all over the work in here. The Weddy implication method used to synthesize the taken catalyst to synthesize the composite. Next move to the photocatalytic reaction. It's oxidation reduction or taking place in the photocatalytic reaction. I chosen the pollutant, which is the chloropyrifos. Chloropyrifos giving us the much more effective for the environmental as well as the effect for the harmful for the our human being as well as living things. It is a graphical abstract of my work. Next slide. Next slide. Yes. So many pesticides are. I just put in the so many pesticides are. I put few only here. So I show on the figure, which are the commercially using in our environment. Next slide. Next is asthma. So how it is adverse for the human being is it is mostly giving the nerves issues, brain issues. So many issues are giving for how the way it's affecting from the pesticides, chlorofyrifos as well as so many pesticides as shown in the figure. Next slide. So how the way it mixed to the environment, living beings and a human being. I just put the little figure for the schematic diagram. Next slide. Nice. So, this is the reason I chosen the chloropyrifos. It is a pesticide. The structure of the pesticide. The absorption maximum is 291 nanometer. Next slide. Next slide. Yes, ma'am. So I chosen the photocatalytic reaction. I used for this procedure for degradation work. So 20 ppm of 100 ml of 100 ml measured and poured into the 200 ml of beaker, and put into the I put here only the composite. I took the photocatalytic reaction for the separator catalyst also, which means vanadium pentoxide I have taken, and nitrogen doped graphite carbon also I taken, and zinc oxide, and then finally composite also I taken. So 50 gram of I taken, and then that 30 minutes for the equilibrium condition. Then moves toward the white light irradiation lamp, which has I mentioned the visible active one. The 300 watt xenon is the visible active lamp I have used in the photoreactor. So totally 90 minutes take over the reaction completed. Next slide. Next slide. Yes, no. Photocatalytic degradation of the chloropyrifos. Next slide. Yes. So I have mentioned the separately also I taken compared to the separated catalyst. My composite are more effective from other. The D1 is I put it here. I have the 90 minutes completely degradation. Next slide. Next slide. Yes. So here I put in the photo degradation rate as the efficiency as well as the pseudo first order kinetic reaction. The chlorophylls are taken. Here I mention the degradation ratio compared to the other separate compound. I have the composite as 97.33% degraded within the 90 minutes. Next slide. Yes. Yeah, I took the recyclic reaction also. So I planned to 5 cycle, but I done only the 3 cycle here, and I done the scavenger test also. This is a rate constant degradation work, which I mentioned the previous also. It is rate constant rate orders here I mentioned. Next slide. Next slide. Yes, conclusion of the mic. Well, the composite have been successfully synthesized by the weight implication method under the visible light, and then I have took XRD 10 XPS I given for the UEDRS. I didn't get the results. So that's why I mentioned here. I didn't mention here the nano crystalline nature of the nanocomposite masked with the JCPDS card. I have mentioned in the XRD data, and then 97.3% of the degradation within the 90%. The nanocomposite I have gotten from under the visible active. The further work I plan to degradation undergo the work for the antiviral drug I plan to choose, which is the amoxicillin, and antibacterial drug I plan to choose and the amoxicillin, antiviral drug as well as the dyes also I plan to done the degradation with the same composition. Next slide. I have put a few reference work from the chlorophyricus. Thank you. Next slide. Thank you.
Thank you for your presentation. It's a vast presentation. I have some doubts regarding your presentation work.
Okay.
You have given in a composite material V2O5
yes,
nitrogen doped with C3 and 4 and zinc oxide.
Yes, yes, sir.
You have given in an abstract, that graphical abstract,
Yes,
the valence band and conduction band.
Yes, sir.
So where do you think the valence band electron would have come from?
Sir, sorry, sir.
You have given valence band and conduction band.
Yes, sir.
So in V2O5, the oxidation state of vanadium is D5, 5 plus, so it becomes D0. And zinc oxide Zn2 plus is D3, D10.
Yes,
so
sir.
where do you expect the electron to move from the composite?
It's oxygen to reduction or moves from.
No, some electron has been moving towards the band. So here the vanadium has D0
yes,
and zinc has D10. So where do the electron would be expecting from the composite to move to the conduction band? So I have one query in that one. And another thing, in your XRD pattern, you are given a one of the point as 0101. I think there won't be 4 values for an XRD pattern. I think you have, maybe it's a typographic error or something like that.
It's a typographic error, sir.
Okay. Then in UV spectrum, you have taken the zinc oxide absorption is around 220. It's showing 220 nanometer. What is the solvent you have taken?
So for synthesis method, sir?
No, the absorption UV visible spectroscopy.
Just water only I taken, sir. Just water only done.
Water. Okay, water absorbs around 200 to 220. So how do you get that spectrum for water, pure water?
Sir, sorry, sir. I couldn't hear, sir.
No, water absorbs around 200 nanometer.
Yes, sir.
So you would have got a spectrum around from 190 itself. You have got a spectrum for zinc oxide. So what is the color of zinc oxide in that case?
Sir, I didn't have it. See any.
What is the color of zinc oxide?
Zinc oxide, I have a colorless only, sir. So, it's not observe any color, sir. From the.
Okay. Check. Fine. Okay. Check.
Thank you.
Hello. 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 Hello.
Thank you, Mrs. Vijayalakshmi.
Hello. I have one doubt.
Mrs. Vijayalakshmi?
Yes, ma'am.
Yeah, one of the participants has a question for you.
Okay.
Ma'am, what are the pollutant you have taken?
It's a chlorophyricus, sir. It is a insect.
Insect. Okay. You are doing the degradation.
Yes, sir.
So where the degradation happened?
So, what you asking? Where I done or?
No. I'm asking what happened? Which bond broken or?
It's that I giving for the GC, sir, gas chromatography, sir. Then I can find out, sir, where it has happened, where the band going to break up.
That's why I'm asking.
Yes, sir. I'm giving the result for the GC, sir. Given the degradation solution for the gas chromatography, sir. Then I will get that, sir.
Okay, I'm just asking which bond. Say there is a lot of bond. between nitrogen and carbon, oxygen, phosphorus, sulfur with phosphorus, but exactly where the degradation happens.
First, I thought the methylene group going to break, sir.
Methylene.
Yes, sir. Methyl group.
Okay. Okay, thank you.
Thank you.
Thank you, Mrs. Vijayalakshmi.
Thank you.
Next, OP7, Dr. Sonia. Dr. Sonia.
Yes, ma'am. Is it visible, ma'am?
Yes.
Yeah, thank you. A warm good afternoon to all present here. I'm Dr. Sonia, working as Assistant Professor in the Department of Biochemistry at Research College for Women. I'm here to present a part of my research work titled Nano's Fabricated Chitosan Functionless Graphene Oxide Nanoparticle, a versatile nano drug carrier to deliver kappa carotene against cancer cells. The background of our research is, the main background of our research is India ranked third among nations in terms of highest number of cancer. According to as per the results of the National Cancer Registry Program, over 13 lakh of people in India suffer from cancer every year. The only treat that we rely for cancer is radiation and chemotherapeutic agents, which kill the normal cells and cause toxicity to the patient. So in order to, however, we have, however, many cancers still fatal, despite the effort being invested in preclinical and clinical research. One of the most important way to improve the survival rate of cancer patients is the targeted delivery of anti-cancer drugs. Therefore, we aim in developing a new anti-cancer drugs based on a marine source. The main purpose of target and pH responsive drug delivery system is, in the case of pH responsive drug delivery systems, the shortcoming, it will overcome the shortcomings of the conventional drug formulation. So that because of that, we can able to deliver the drugs in a controlled manner at a specific sedateness at a specific time. And most probably, the need of targeted is the main thing is it can act only at the diseased organ without affecting the healthy cells. So in our work, we have chosen the graphene oxide based nano carrier. So due to its most promising biomedical applications, we have selected graphene oxide as a nano carrier. In order to improve the stability and the bio applications of graphene oxide, we have functionalized this graphene oxide with chitosan. After functioning with chitosan, we are in need of identifying a potential target which must have a high endocytic efficiency, as well as it must have a low tendency to mutate. So we have chosen mannose as a targeting ligand. This was the first time to report chitosan functions graphene oxide conjugated with mannose. And we have selected this marine polysaccharide, that is red marine algae, Kappa Picus alversiae. This has been selected as a anti-cancer model drug. Using alkaline extraction method, we have isolated a compound called as kappa carotene, and that kappa carotene acts as an anti-cancer model drug. Yeah. So the main contribution of our work is to highlight the possible potential of the mannose as a targeting ligand for receptor-mediated drug delivery systems, and also to give a promising anti-cancer drug based on the marine algae, that is nothing but kappa carotene, which we have been used in our work. And these are the activities of our work. The first thing is we have prepared a graphene oxide based nano carrier, and that graphene oxide has been functionalized with chitosan. After functioning with chitosan, we have conjugated this GOCS system with a mannose, which is acting as a targeting ligand. And after that, we have been incorporated a drug from which we have isolated from a red marine algae, and we have seen the different structural properties, morphological, and then biocompatibility studies like hemocompatibility and cytotoxicity. And this is our methods, experimental methods. First, we have prepared a graphene oxide from graphite by using a modified Ammers method. And in order to improve the stability, efficacy, and the specificity of the graphene oxide, we have functionalized this graphene oxide with chitosan. So via amide linkage through the EDC-NH coupling process, where this EDC will initiate the formation of an amide linkage between the carboxyl group of the graphene oxide and the amide group of the chitosan. So after functionalization has been achieved, we have decorated the surface of the chitosan with mannose, resulting in the formation of a GOCS mannose carrier. And these nano carrier has been subject to various characterization techniques like UV, IR, and then same HRTEM. Along with it, we have been loaded the drug into this GOCS mannose nano carrier, and that also be undergone from further biological studies and characterization techniques. So next will be our research and discussion. This is a discussion for the drug-loaded nanocarrier and the nanocarrier. From the UV results, we inferred that this graphene oxide show a peak at 230 nanometer, which corresponds to a pi-pi plasmon peak transition. After functioning with chitosan, the peak has been shifted from 230, it has been shifted to 267, or almost 268. This is for GOCH, which may be originated from the N to pi transition of the peptide bond. And after conjugation with mannose, we can able to see an increment of peak around 258, 268. This shows conjugation of mannose onto the chitosan functionalized graphene oxide nanocarrier. Then after loading with the kappa carrageen, we can able to see a slight gastric change in the peak around 276. So all these peaks from the UV results, we conclude that the shift observed in the absorption spectrum indicate the successful conjugation of this kappa carrageen, that is a drug, onto the mannose conjugated chitosan functionalized graphene oxide system. So next comes the FTR spectroscopy studies. From the FTR research, we observed that there is a proper formation of graphene oxide nanoparticle, and the chitosan functions graphene oxide has showed interaction between the COH group on the surface of the graphene oxide and the amine group of the CS2, the amide linkage. So after conjugating with the D mannose, we can able to see absorption band at 1068 So here we can able to see a band at 1068, which could be due to the COH stretching of the mannose sugar molecule. So there is a clear evidence that the mannose sugar unit has been effectively conjugated to the GOCS, prompting a carrier called as GOCS mannose carrier. The stable loading of drug to this carrier was evident with the presence of peak at 1726 and 840, which attributed to the SOH stretching and bending vibration of COS. So next comes the scanning electron microscopy studies. These are the images of same micro images of graphene oxide and graphene oxide with chitosan, and the function is graphene oxide with mannose and the drug loaded nanocarrier. In the case of graphene oxide, we can able to see like flat-like structure with irregular molecular morphology. After functioning with chitosan, it leads to a well-discrete structure of agglomeration. And after this loading with after conjugating with the targeting ligand mannose, we can able to see high degree of agglomerated spherical particles upon conjugation. And in the case of final loading of the drug, we can able to see a well-dispersed particles which has been embedded on the surface of the nanocarrier. So here comes from the same research, we clearly indicate the successful loading of drug into the nanocarrier. So these are the results of HRTEM. So where the graphene oxide shows a cubical and spherical shape over a wide range of diameters in size, and when you look into the TEM image of GOCH, where it shows a graphene nanoparticles are embedded into the matrix of the chitosan. So after conjugating with mannose, you can able to see a multi-layered wrinkle streets. Upon loading of the drug, we can able to see the black spots, which shows the deposition of the drug on the layer of the chitosan functions graphene oxide. So when compared with the SAD patterns, we can able to see crystalline nature of the stuff, which has been represented in the concentric rings. So next comes the zeta potential. So zeta potential is one of the prominent one to characterize the stability of the surface modification of the nanocarrier, the drug to nanocarrier. Our research showed that the graphene oxide, that is zeta potential of graphene oxide is minus 26.2. It became positive after functioning with chitosan, where the values has been changed to 25.6. So it indicates interaction of the carboxyl group and the amino group which is present on the chitosan. And next comes similarly after conjugation of the D-mannose, the potential has been dropped to 3.8. It has been decreases, which can be due to the increased agglomeration, where we can which we can see in our same micrographs. And all this change in surface zeta potential of drug loaded. After loading with the drug, it shows a zeta potential value of minus 29.2. From the positive value of nanocarrier, after loading with the drug loaded nanocarrier, we can get a negative charge. This may be due to the presence of the sulfated polysaccharide, which our drug is considered to be a sulfated polysaccharide. This shows there is a successful loading of drug on the surface of the GOCSMA nanocarrier. So next comes hemocompatibility studies. So hemocompatibility studies is one of the most important studies to study about the interaction of the nanocarrier and the drug-product nanocarrier with the RBCs. So because this biocompatibility of nanocarrier play a significant role in drug delivery. So usually, during this hemolysis process, there will be a rupturing of RBC membranes that will cause us to release a hemoglobin, and that hemoglobin will be released in the plasma. So it is very important to study the effect of the nanoparticle via hemolysis process. Okay. So we have studied the hemolysis process of free kappa carrageenan and the mannose conjugated cytosine functional system and the drug-loaded system. Whereas the hemolytic behavior of free kappa carrageenan was around 14%, whereas after loading with whereas this without drug, it was around 15%, and after loading with drug, the hemolysis were occurred to 0.9%. So this hemolysis percentage, anything with this below 5 is considered to be a safe drug. So these are the light microscope images of the of a sample. This is with RBC with PBS, and this is the kappa carrageenan, and this is the drug. I mean without drug, and this is with drug. So from the hemocompatibility studies, we conferred that our drug, that is kappa carrageenan, it has a higher biocompatibility as well as can be used for drug delivery applications. So this is in vitro release studies. We have taken two different pH. One is pH 5.3 and one is pH 5.4. The temperature has been an optimal temperature of 37 degrees Celsius. In the case of pH 5.3, there is a rapid release. When look into the graph, in the first hour, there is a rapid release of almost 60%. And after a period of 70 hours, almost 77% of drug has been released. Whereas in the case of 7.4, only approximately 20% of the total drug has been released after 70 hours. So obviously, in the case of pH 7.5, compared to physiological pH, the cancer cells will flourish more in the acidic environment. So we need more drug to be released in the acidic environment so that it would have a more impact on the cancer cells. So in summary, when we compare with the drug release studies, this mannose decorated cytosine functions graphene mediated pH response drug release system is indeed a promising nanocarrier with a good stability and potential for the tumor targeting and control release. So this is the mechanism of kappa carrageenan release. Based on the drug release studies, we have done we have fitted the values to the different kinetic models like zero order kinetic, first order, Hagekuchi, and then Cos Pepper-Mayer. So these are the Arcoy values. Out of this three different kinetics like zero order, first order, and Haikuchi. The first order model has higher accretion value when compared to the zero and the Haikuchi. And the diffusion rate of the drug from the nanocarrier is directly proportional to the concentration gradient. And we have fitted the data into the Cos Pepper-Mayer and performed, which gives a better, higher Oscar values. Where the drug release at pH 7.4 follows a case to transport, and the drug release at pH 5.3 releases a friction diffusion, that is a swelling of the medium. So next comes the cytotoxic activity. We have taken a UH7 cell line. It is called as human glioblastoma cell line. In other terms, you can also call as brain cancer cell lines. We have tested this kappa carrageenan loaded graphene-based nanocarrier on this UH7 cell line. So without drug, upon exposure to 48 hours, 50% of cells has been killed. Whereas after loading with the drug, almost you have a viability. I mean, almost 80% of the cells has been killed. Only 21% of cells has been live. So this indicates that, from the cytotoxic results indicates that this nanocarrier system, what we have developed based on graphene oxide, has a potential to become as a cancer-mediated drug release system. And the drug, the anti-cancer model of kappa carrageenan proves its efficacy through this nanocarrier drug delivery system. So the next is the conclusion. From the outcomes and observation of the experimental procedure, we conclude that we have successfully synthesized graphene oxide, and we have functionalized this graphene oxide by and also we have conjugated this mannose targeting ligand. So to this nanocarrier, we have loaded the sulfate polysaccharide, that is nothing but kappa carrageenan. So this kappa carrageenan can be used as a potential drug system in future anti-cancer systems. Apart from that, this system, that is graphene, chitin, and mannose, it can be a promising drug carrier for the pH targeted and control drug delivery systems. From the biocompatibility studies, we observed that we analyze the biointeractions of our compounds with RBC via hemolysis assay, which shows more biocompatibility after loading with the drug. So from this, I conclude that this novel mannose conjugated cytosine functions graphene oxide, along with the novel drug kappa carrageenan, could provide a new platform by presenting this system as the system for intracellular release of marine algae-mediated anti-cancer drugs for glioblastoma. We have done for glioblastoma, lymphoma, and brain cancer. Out of these three cancers, we have got a better result for glioblastoma. So I conclude a single line like carbohydrates as feed option in the treatment of cancer. Thank you.
Okay, thank you for the presentation. It was a vast presentation. I have a simple doubt only.
Yes, sir.
What is the nature of the graphene oxide? What is the particle dimension will be?
You mean the particle size of graphene oxide, sir?
Yeah.
It is 176.
Does it grow when you?
Yeah, it grow upon it. There is a change after function with chitosan. It has been changed to 246, and after conjugating with mannose, it has been around 300, and after loading the drug, it has been around 350 something.
So whether have you taken a sample, or if you kept the sample after 3 or 4 months, does it have any difference in the properties?
No, see, it doesn't show any property. I mean, it doesn't show any difference in the properties of the prepared compounds.
Okay, fine, good.
Thank you, sir.
Hello.
Dr. Sonia?
Yes, ma'am.
Do you have a question from a participant?
Yeah, yes, ma'am. Yes, sir.
Ma'am, I have 3 doubts.
Yes, sir.
What are the ratio between graphene oxide and chitosan?
It is a ratio of 1:1.
1:1.
Yeah.
நீங்க கைட்டோசன் எடுத்துட்டீங்களா? சிந்தேசிஸ் பண்ணீங்களா இல்ல வாங்குனதா?
இல்ல, it's a commercial one, sir. It's a commercial one. Commercial one.
Degree of distillation.
It is around 96%.
நீங்க யூவில எக்ஸ்பிளைன் பண்ணும்போது சொன்னீங்க அமைட் பாண்ட்னால இந்த யூவி அந்த வீக் வந்ததுன்னு. ஸோ அப்போ இது டிகிரி ஆஃப் டிஸ்டிலேஷன் அதை வந்து அஃபெக்ட் பண்ணுமா? இப்போ கம்மியாக
அப்போ டிகிரி நம்ம நீங்க சின்சஸ் பண்ணும்போது நீங்க ப்ராப்பர் சென்ட்ரிஃபிகேஷன் பண்ணும்போது எனி அன்ரியாக்டட் அசிட்டிக் ஆசிட் குரூப்ஸ் இருந்தாலும் அது ரிமூவ் ஆயிடும். தட்ஸ் வாட் ப்ராப்பர் சென்ட்ரிஃபிகேஷன் பண்ணும்போது ரிமூவ் ஆயிடும் அது.
இல்லை மேம், நாம கைட்டோசனில் அமைன் குரூப்பு அதுக்கப்புறம் அமைட் குரூப் ரெண்டுமே இருக்கும். ஸோ அதில் வந்து நீங்கள் அமைட் குரூப் அதிகமாக இருக்கிறதுனால ஏதாவது
we wanted to bring out linkage. I mean, ஒரு covalent interaction மாதிரி கொண்டு வரணும் கார்பாக்சி குரூப்ஸ்க்கும் அமைட் குரூப்ஸ்க்கும். ஸோ அதனால தான் we have taken the coupling reagent like EDC and NHS.
ஓகே. இப்போ டிகிரி ஆஃப் டிஸ்டிலேஷன் அதிகமாக இருந்தால் அதோட எஃபெக்ட் அதிகமாக இருக்கும்னு சொல்கிறீங்களா?
ஆமாம், ஏன்னா வந்து நம்ம அதுக்கப்புறம் மேனோஸும் போடுறோம் இல்லையா? ஸோ மேனோஸ் போடும்போது மேனோஸ் எங்கே போய் பைண்ட் ஆகும்னா இட் வில் ரியாக்ட் வித் ஃப்ரீ அமினோ குரூப்ஸ் which is first வந்து கைட்டோசன்.
ஓகே. அந்த நீங்கள் கைட்டோசன் வாங்கினீங்களா? அதுக்கான கமர்ஷியலாக சோர்ஸ் என்னன்னு தெரிஞ்சுக்கணும்.
I think it is from marine sources, crustacean cells தான் அது.
Crustacean. Okay. Except எதுன்னு சொல்லுங்க.
Crustacean prawn. Mainly from prawn and crab.
Okay, thank you.
Thank you.
Thank you, Dr. Sonia.
Thank you, ma'am.
Participants are requested to stick on to the allotted time of 5 minutes, which includes the question answer session with the chairperson. Please don't elaborate on the introduction part and the experimental part. Hope you will understand the time constraints. Thank you. Next, we have OP8, Dr. Uma Maheshwari. Dr. Uma Maheshwari?
Yes, ma'am.
Yeah, you ready with the presentation, ma'am?
Yeah, I'm just sharing my window. Please, one second. Yeah, is my screen visible? Yes?
Yes, ma'am, yes.
Yes. Good afternoon to one and all present here. This is Dr. Uma Maheshwari from Chemistry Department, Ethiraj College. My topic is about in vitro wound healing activity of honey-loaded microsponges incorporated in hydrogel. Introduction. So wound healing is a multi-step process. So it involves 4 stages. And the drawback in the commercially available wound dressing is the inclusion of antimicrobial agent, which will cause the cytotoxic effect. Therefore, it will delay the wound healing. To overcome this issue, we need to use hydrogels as wound dressing material with natural products. So hydrogels, basically, it will keep your wounds moist, allowing them to heal more quickly by minimizing all these apoptosis, etc. So this is the brief work we have done already. So what we have done is we have taken the natural product honey and we have just loaded into the microsponge and then
Excuse
the
me,
best.
ma'am.
Yes, ma'am.
I'm sorry for the interruption.
Yes.
Ma'am, can you please go on to the result and discussion part, ma'am?
Yes, ma'am. Yes, ma'am.
Yeah,
Definitely. Yeah.
thanks a lot.
Yeah. So this is the objective of the present work. So we have fabricated the hydrogel with honey-loaded microspon, and here we have just studied the in vitro drug release study and its kinetics, followed by the wound healing activity. These are the materials and methods and results and discussion. So here the best loaded honey, best loaded hydrogel is just done for the in vitro drug release study. So we have just taken the liquids at 3 hours intervals, that is 3 and 6th hour and 9th hour. So when you see the at 9th hour, almost 95% of the active material got released. And whatever the data we have just got it from the in vitro drug release, so we have just made the data fit into the kinetics. So we have just chosen zero order, first order Igachi and Coase-Meyer peppers. So if you see these 4 models are hydrogel just fit into the Coase-Meyer peppers kinetics. So it just follows this kinetics because here the R square is 0.994. So it showed a cumulative drug release. And finally, we have done wound healing activity by in vitro scratch assay. So we have just taken a lower concentration and we have just created a wound on the Vero cells. And after the 24 hours treatment, so when you see at 200 mg per ml, it showed 75%, and whereas at 100 mg per ml, it showed 98% of cell migration. So it depicted the effectiveness of wound healing process. So this is about the microscopic images of wound healing activity for these best selected hydrogel. So the first row is about the wound created, that is at 0th hour, and after 24 hours, it is the microscopic images. So you can see, the cells are just migrated. So that was just captured under the inverted microscope. So this is the image after wound healing. Conclusion. So the hydrogel loaded with honey microsponge was successfully fabricated. The hydrogel with the lowest particle size was selected as the best hydrogel, and it was evaluated for further studies. So besides an excellent antimicrobial and antioxidant activity, the effectiveness of hydrogel with honey loaded microsponge was also checked for its in vitro drug release study, followed by wound healing activity. So here the in vitro drug release study depicted the cumulative release, which releases almost 95% of its active material at 9th hour, and this data was best fitted into the Coase-Meyer peppers kinetic model. And the in vitro scratch wound healing assay showed nearly 98.2% of cell migration, so that ensures the potential wound healing process. So hence the present work concludes that the hydrogel loaded with honey microsponge act as a potential wound healing agent with a high antimicrobial and antioxidant activity, with less side effect and better results. So in future, it can be checked for the in vivo wound healing study followed by the clinical trials. So these are the references, and thank you.
Fine, ma'am. Just a question. What is the hydrogel you have used here?
So here we have just taken the carbopol. So the carbopol is just mixed in a water, followed by the addition of TEA, that is triethanolamine, and propylene glycol. And then we have added our best chosen microsponge, that is the honey loaded microsponge. So we have just incorporated that honey loaded microsponge into the hydrogel.
Okay, so it doesn't mean that it completely is water. Hydrogel is not full of water.
No, sir, no.
Okay, fine.
Yes.
Thank you, Dr. Maheshwari.
Thank you, ma'am.
Next, we have OP9, Mrs. Kirtiga.
Yes, ma'am.
Yeah, you can share your presentation.
Yes, ma'am. and to one and all present here for this conference. I like to thank my old institution, Adarsh College for Women, and all the professors and lecturers for this virtual conference. My topic is molecular docking approach on and binding stability of symmetrical and unsymmetrical urea derivatives with di-HSA complex. Molecular docking is these are the outline for my presentations. Molecular docking is to which the big molecule interact with ligand to get we get a complex. From that complex, we can able to see their energetics and orientations in of the molecule. Need a whole small and
Kritika, we are not able to hear you.
Yes, ma'am.
We are not able to hear you, Kritika.
Yes, ma'am. Okay.
A lot of disturbance.
Yeah, you can hear. Yeah, you can talk.
Okay, sir. I have taken HSA as a host, HSA as a. Now we are audible, sir?
Yes, it's audible.
Okay, fine. HSA as a host, I have taken in my study. In HSA, we have 3 domain sites. In each domain site, we have 2 subdomain sites. And from HSA is a synthesized from liver. It has a high proportion of amino acids. It has 585 amino acids. For its demonstration, like 3 tennis ball can attached imposed in a cylindrical case like that. It looked like. Domain 1 and 2 are called pseudo binding sites, where the scientists who called pseudo, and domain 3 is called non-pseudo sites, and HSA as a versatile protein, so that it can be used as in our study. The competing guest is a dye that is Sosna based in dye positions or position exposition can be variated, and that's how I listed here. It is an excellent soluble in water and organic solvents. It mimics like CNADH analogs, and it has already reported excellent binding affinity with amide sugars and urea, amino acids, and etc. The guest I have taken is urea, symmetrical and unsymmetrical. The structures I have listed in left-hand sites are symmetrical and right-hand sites are unsymmetrical urea derivatives. In symmetrical urea derivatives, we have an hydrogen bond acceptors and donors. For the substitution of an alkyl chains, the donors will get increased that for both symmetrical and unsymmetrical urea derivatives. The scope for my work we will get info about the hydrophobicity, how the interactions of acceptor and donor of urea derivatives from the competing gas, that is dye, how the hydrogen bonding of with the ureas with protein, that is urea with protein, can be evaluated, how the symmetrical and unsymmetrical ureas where binding energies will be, how they differ, can be we will get info about that, and how they in urea derivatives, how the alkyl substitutions will change the binding sites and domains. That info also we will get to. And finally, we will get info about the energetics and molecular interactions of the host and guest molecule. Now we will see the results and the discussion about the urea and HSA with the dye, that is host with the guest with the competing guest molecules. the above slide is with the present, the above table is with the presence of dye, the below table is the absence of dye. In presence of dye, we get energetics of, that is the energetic of all the first stable conformers of all the urea derivatives. In presence of dye, in dye we get minus 3.54 as the energetic values. In presence of dye, urea is more stable by the values we will get the which one is stable. In molecular docking, the least negative value is be more stable. For absence of dye, we get minus 2.71 as a value for urea, whereas by the alkyl substitution increases, we will get the value for methyl urea and ethyl propyl butyl urea. For the presence of dye, we will see the urea is the best binding with the host gas complex. For in the absence of dye, butyl urea is the best binding in host gas complex. In absence of dye, we will get the same info about the energetics of presence of dye and absence of a dye. In presence of dye, we will again the urea will be the most stable. In absence of dye, 1 and 3 dimethylurea and 1 diethyl urea will be the most stable of value in docking. This table info about the domains and sites of the urea, the complex have taken in this presence of dye about the urea derivatives. In presence of dye, the non-pseudolose and pseudolosides too are more favorable, and hydrophobic interactions are called, no favorable interactions are not dye. In this table, we are able to see about the amino acid body involved in the interactions. This polar amino acids and non-polar amino acids. Polar amino acids for hydrogen bonding interaction and non-polar amino acids for hydrophobic interaction. This table about the urea derivatives with absence of dye. In presence of dye, it prefer non-pseudoloside and pseudoloside too, whereas in absence of dye, it's prefer only pseudoloside too. For urea derivative, it not preferred binding site 1 is not preferred in the absence of dye, whereas 8 amino acids are involved in presence of dye. In the 12 amino acids are involved for binding. These are structures of amino acids I have taken in our study. Polar, non-polar, charged, positive, negative structures are listed below. The 2D representation for a dye protein complex. We can be able to see the green color indicates the conventional hydrogen bonding. That is, hydrogen bonding is more predominantly in dye protein complexes. The before slide bondings are involved. This the for absence of dye, the 2D diagrams are in this no unfavorable reactions are existed. Now, non-conventional hydrogen bonding will not exist. Only hydrogen bonding are green color hydrogen bonding. For the symmetrical, the same hydrogen bondings are interactions are involved, except TMU. In TMU, that is tetramethylurea, the all alkyl substitutions are all alkyl substituted, so that there is no donor and acceptor. These are the structures of amino acids where I have listed before the R groups, that is polar, non-polar amino acids. These are the types. In amino acids, the R group can be varianted. So I like to conclude with my workers, and docking tool is docking method is tool we can use here to establish energetics and domains of their. From this, binding stability can be calculated. From this, I conclude in the presence of dye, that there will be in presence of dye, it is less than the absence of the dye. The binding energy is more stable. From the molecular interactions, I have already said when 8 amino acids or 10 amino acids are involved. In that amino acids, sulfur containing amino acids are not involved. It can be the work in progress. We will able to discuss. We will able to deal about the why the sulfur amino acids are not involved. And in amino acids, charged functional groups are not involved in the in my present study. That also we'll have to deal about it. From the alkyl substitutions, the urea can morely for the alkyl substitution, the urea binding energy can be varied because of the alkyl substitution. These are the elements I have taken in my work. I thank you.
Okay, fine. I have one question regarding this study. So which do you think more important, hydrogen bonding or hydrophobic interactions? Can you hear? Which do you think more important for nature of interactions, hydrogen bonding or hydrophobic?
Hydrogen.
Why? What is the reason?
We can tell about the how it can binding with the ligand because of the hydrogen bonding. The domains are can be calculated.
Okay, fine. Next person can give.
Dr. C. Priya Verma, OP10.
Yes, ma'am.
I think so.
Ma'am, kindly stick on to the time allotted.
Okay. Is it visible?
Yes, yes.
It's visible.
A very good afternoon to one and all. The presentation is on synthesis, characterization, and antibacterial screening of transition metal complexes of icytin 6-methoxy isonicotinol hydrosome. Like, considerable research has been done on the metal complexes of hydrosome type ligand during the past few decades, especially hydrosome containing a pyridine moiety. It's constitute an important class of nitrogen donor ligands with a wide range of potential biological applications. These are the azomethane compounds characterized by the presence of C-double bond or donor site in addition to C-double bond N-NH group. A wide range of applications have been reported due to their striking chemical properties, biological and pharmacological activities. The present study has been focused on the synthesis, characterization, and antibacterial screening of the metal chelates derived from the hydrosome ligand and its metal complexes. These are the various physicochemical methods employed for the characterization of the compounds, like elemental analysis, magnetic susceptibility measurements, spectral techniques such as FTIR, UV visible, and proton NMR studies. Synthesis and characterization of the ligand. Equimolar amounts of icytin and 6-methoxy isonicotinic acid hydroxide has been reflexed in ethanolic solution on a water bath in the presence of catalytic amount of glacial acetic acid for about 4 hours, and the ligand got separated as an orange colored solid. The characterization of the ligand was done by elemental analysis. The analytical data agreed well with the proposed molecular formulae of C15H12N4O3. The ligand was characterized by UV visible spectroscopy. The band observed at 272 corresponded to pi to pi star transition, and a band at 354 for the azomethane group and the amide part of the hydrosome moiety, and this is due to the pi to pi star transition. The IR characterization of the ligand, it was found that a peak in the range of 1612 corresponded to the characteristic azomethane group, and the band at 3,400 to 3,200 centimeter inverse range can be assigned to the stretching vibrations of NH group. The spectrum showed a sharp peak at 1705 due to the C double bond O group, and a peak at 1018 can be assigned to the NN stretching frequency. The proton NMR spectrum of the ligand is shown here. A peak at 3.65 can be assigned to the methoxy group of the isoniazid, and the NH group, a signal at 11.4 and 13.98, can be assigned to the NH group and the NH of the icytin ring. A doublet at 6.96 and 8.85 can be assigned to the aromatic protons of the isoniazid moiety. Multiplet in the range of 7.14 to 7.44 is due to the aromatic protons of the icytin ring. Synthesis of metal complexes were done by taking 1:1 molar ratio of the respective metal chlorides with a synthesized ligand, and it was refluxed on a water bath for about 5 to 6 hours. The complexes were cooled, evaporated, and they were washed with methanol after drying. And the characterization of the metal complexes were done by elemental analysis. The analytically found data agreed very well with the proposed molecular formulae. The cobalt-2 and copper-2 complexes were found to have the formula of MlH2iCl2, and the complex of nickel corresponded to the formula of Ml2H2O twice. This is the analytical data of the complexes. The magnetic moment values of the cobalt-2 complex was found in the range of 4.87, and the complexes of nickel and copper registered a magnetic moment of 3.24 and 1.97 Bohr magnetone. All these complexes were found to be octahedral. This is the electronic spectra of the complexes of the cobalt, nickel, and copper. In the spectrum, electronic spectrum of cobalt-2 complex, the three peaks in the range of 400, 600, and 1000 range corresponded to the three spinel-out transitions of 4T1GF to 4T1GP and 4T1GF to 4A2GF and 4T1GF to 4T2GF. These three allowed transitions can be attributed to the octahedral geometry of cobalt-2 complex. And the three peaks in the case of nickel-2 complex was found in the range of 243 and 362. Also, a band at 659 correspond to the ligand to metal charge transfer transitions. The copper-2 complex registered a broad band at 625, and it could be due to the 2T2G to 2EG transition, representing an octahedral environment around the copper-2 metal ion. These are the IR spectral characterization of the complexes. In the complexes of cobalt and copper, the ligand behaved as a bidentate ligand by coordinating through azomethane nitrogen and keto oxygen, whereas in the case of copper-2 complex, the behavior of the ligand was a bidentate one, coordinating through azomethane nitrogen and the enolate oxygen. It could be seen that the coordination has taken place in the cobalt-2, nickel, and copper-2 complexes through azomethane nitrogen, and comparing to the ligand spectrum, shift has been observed to lower wave number. Also, the NN stretching frequency of 1018 has been shifted to 1034 range and 1000 range in the case of nickel and copper-2 complexes. And the appearance of metal nitrogen and metal oxygen band in the range of 600 and 400 indicated their coordination. Based on these analytical and spectral and magnetic studies, octahedral geometries were assigned to these complexes. The antibacterial screening of icytin 6-methoxy-isonicotinol hydrazone and its complexes is given below. It was done by disk diffusion method. The 6 bacterial strains were taken in the study. Disk with PMSO without the drug was used as the control. And the diameters are shown here, the zone of inhibition. The copper-2 complexes exhibited higher inhibition effect when compared to that of nickel and ligand. The copper-2 complex show the highest activity towards the gram-positive bacteria. Thank Thank you, sir.
Yeah, it was a good piece of work. I have a question regarding your UV visible spectroscope.
Yes,
In
sir.
one of the slide, you have showed 1014 nanometer. I don't think so. It's from 190 to 900 nanometer. You can record in UV visible. But how did you get 1014 nanometer? Is it a typing error or it's?
No, sir, it is in the range of 1100, sir.
No,
We got
it is in the normal conditions and oxygen conditions. The spectrometer will give from 190 to 900.
Okay, but the range was from 400 to 1100.
In UV.
Yes, yes, sir.
Okay.
Scale was set up like that.
Okay, fine. Then how do you characterize, differentiate your N to pi star from pi to pi star?
In the case of ligand.
Yeah. You're
Yes,
given the data as pi to pi star and N to pi star. How do you just correlate that one or differentiate?
So in the N to pi star, it could be like it is from the non-bonding. So it usually appears at, it requires low energy. So the wavelength will be at longer side, whereas pi to pi star requires high energy. So it could be found in the 200 range.
Yeah, I agree. But is there any variation on the solvent properties? We can differentiate that one.
No, sir, I took it in the solid form, sir.
Okay. Fine. Okay, fine.
Okay, thank you, sir.
Thank you, Dr. Priya. We can have one more participant, Mrs. Divya, OP11. Mrs. Divya, are you there?
Yes. Yes, ma'am. Ma'am, is it visible? Ma'am? Is it visible?
Yes, it's visible.
Good afternoon to one and all present here. I am Divya D, Research Scholar, Department of Physics, Loyola College. My presentation topic is synthesis and characterization of ZNO RGO binary nanocomposite for photocatalytic applications. Introduction, it's just a general introduction about the metal oxides. We all know there are clusters of semiconductor-based metal oxides such as titanium dioxide, zinc oxide, nickel oxide, tin oxide, copper, Cu2O, CuO.
Excuse me, your voice is very less. Can you be somewhat, voice is less audible?
Now is it audible, sir? Sir, now is it audible? Sir?
Yes, it's audible.
Okay. So these metal oxides has drawn considerable attention due to their extensive presence in the environmental purification process as well as energy storage, sensor, and so on, other applications. And then comes the carbon-based materials. Some of the carbon-based materials like reduced graphene oxide, carbon nanotube, and fluorescence, they also gained an attention due to its immense potential. Then in my research topic, I have chose ZNO RGO, binary nanocomposite. We all know ZNO is an old metal oxide. Even though it is an old metal oxide, it has many advantages. So zinc oxide has its outstanding chemical stability, absorption ability to make a promising material for various applications. Similarly, the carbon reduced graphene oxide is a single layer of a carbon atom which has an high surface area with a superior electrical conductivity. So by combining these two things, I have the transition metal oxides and the composites of composite with RGO have its own super precious physical and the chemical properties. My aim was to synthesize a ZNO RGO binary nanocomposite through hydrothermal method and to study the characterization and to study about the properties. I took many characterization techniques and I used this material for a photocatalytic application. The method which I have used for my synthesis purpose, ZNO was synthesized by an hydrothermal method like zinc nitrate hexahydrate was added with the CTAP by addition of NaOH to maintain the pH value of 10 and is transferred into an aluminum autoclave of 150 degrees Celsius for 15 hours. And finally, I would centrifuge washed the precipitate and dried at 80 degrees Celsius 12 hours and calcinated the sample at 300 degrees Celsius for 3 hours to obtain ZNO and reduced graphene oxide RGO was synthesized first I converted the graphite oxide GO into an RGO by using hydrogen as a reductant, and this ZNO RGO is again I have used an isothermal method to convert it into a binary nanocomposite. Then powder XRD diffraction analysis, XRD pattern of ZNO, RGO, and binary nanocomposite. The XRD spectrum of bare ZNO, asserting the formation of a crystalline hexagonal versatile structure, which is actually confirmed through JCPS card number of 361451, and the broad peak observed at 26.6 degree, corresponding to 00 planes of RGO. It confirms the formation of RGO, and the 100 plane indicates a turbostatic disorder. In case of binary nanocomposite, it almost resembles XRD pattern of ZNO because I have added only RGO of 10 weight percentage, that is like 10 milligram I only added. Then high resolution scanning electron microscope. This is the same image of my binary nanocomposite where the RGO sheets is present, where ZNO nanoflakes are dispersed over RGO sheets. Then UV spectroscopy analysis. From UV analysis, the band gap of ZNO was known to be 3.08, and in case of binary nanocomposite, it was like 2.78. For RGO, I had got a broad absorption band from Sybil. Then this is a PL spectroscopy for a pure and a binary. There are two emission bands. I gave an excitation at 350 nanometer, and so I got an emission peaks, two emission peaks. The one emission peak was observed at around 383, and another one was at 510 nanometer. The 383 nanometer actually represents the recombination rate of the binary nanocomposite. The recombination rate for binary nanocomposite actually it was decreased, which can be indicated to the indicated through the intensity, and 510 nanometer that peak actually represents the zinc oxygen defect as well as an oxygen vacancies. From the range of 425 to 650, that is the broad band, indicates the induced emission in the region of blue to yellow from emission spectra. From this PL, I can confirm the recombination rate. My binary nanocomposite has a low electron hole recombination. Then I have not included my application part here. I have done with TC antibiotic and using the binary nanocomposite. And at last, I concluded that ZNO RGO binary nanocomposite was successfully synthesized by hydrothermal method. And from XRD characterization, I have confirmed the phase purity and also the hexagonal versatile crystalline structure. From SIM analysis, the proper dispersion of ZNO nanoflakes over RGO sheets. From UV absorption and PL spectroscopy, I confirmed that there is a decrease in the band gap after the addition of RGO, as well as a reduction in the recombination rate of the charge carriers. And finally, this ZNO RGO binary nanocomposite can be used for photocatalytic degradation of organic dyes, antibiotics, even for like other organic pollutants.
Yes, thank you for the presentation. I have one small question regarding your emission spectrum. So what is the origin of the peak around 425 to 400 nanometer?
That's due to literature review I have read, it was like defects, due to defects it's rise.
So in the spectra being the red one you can see a hump, you can see a shoulder and a peak, then once again a peak around 640. So is there any specific reason for that?
No, sir. For my binary, I got like this one.
Okay, then you could have carried out an 3D contour spectroscopy. You can get a clear resolution. Okay, fine.
3D, sir, once again?
3D contour spectroscopy, you can resolve the peaks clearly.
Oh, okay, sir.
Okay, fine. Thank you.
Thank you, Divyan. Thank you, Kumran sir. So now we'll just take a break for 15 minutes and we'll join back at 2 o'clock.
Okay, ma'am. Fine.
Thank you, sir. I would request Suji, the next oral participant, OP12, to be ready by 2 o'clock.
Yes, ma'am.
And once again, I request all the participants to kindly adhere on to the timings. Kindly discuss only the results and discussion part so that we won't have any constraint in the timings.
Good afternoon, Rajendran sir. Yeah, good afternoon, sir. We are just having a small break, sir. By 2 o'clock, we'll be rejoining, sir.
Good afternoon. We'll resume our oral presentation session post-lunch. We request the participants to stick on to the timing. Please don't elaborate on the experimental part and the introduction part. Just go on to the result and discussion. We are running out of the time. It's a humble request to all the participants. Please see that you don't extend your presentation for more than 2 minutes or 3 minutes. Thank you. Kritika from Satyabhama University is present.
Yes, ma'am. Yes, ma'am.
Okay. Sir, Kumran sir?
Yes, ma'am, you can start, ma'am.
We can start, yeah. Kritika, can you please share your screen?
Yes, ma'am. Yes, ma'am. I'm sharing. Ma'am, I'm not able to share this. Yes,
Kritika,
ma'am.
can you please share your PPT with us then?
Yes, ma'am. I'll put it in the WhatsApp, ma'am.
Yes?
Shall I put it in the WhatsApp, ma'am?
Share it to that ETCT Gmail. Mail.
Okay.
Yeah. Benazir, can you please turn off your video? Benazir? Kundan sir, there is a slight delay in the YouTube live streaming, sir. Or 5 minutes, can we wait?
Okay, ma'am.
Okay, thank you, sir. Kritika madam, we'll resume in 5 minutes. There's a slight delay.
Yes,
in the
ma'am. Yes, ma'am. I will just see it, ma'am.
Yeah, some technical issue with the YouTube streaming. Good afternoon. Dr. Kritika, you can share your presentation. Kritika?
Yes, ma'am.
Yeah, you can share your presentation. Please see that you don't extend the time limit.
ma'am, but I couldn't share my screen, ma'am. That is the problem.
Have you sent it to the mail?
Ma'am, kindly tell me the mail ID, ma'am.
ETCT? Or you send me WhatsApp. You send me in WhatsApp.
Yes, ma'am, I sent.
You can send to my WhatsApp. Yeah. Meanwhile, I'll call OP12, Siji. Siji is present?
Yes, ma'am.
Yeah, please share your screen.
Sure.
OP12, Siji.
I hope my screen is visible.
Yes, your screen is visible.
Yeah, all right. Thank you, sir. A very good afternoon to one and all present here. Myself, CGS. I'm doing my PhD at PG and Research Department of Public Administration in Adarsh College for Women. So coming to my topic, we are in a time where pharmaceutical and chemical science are making incredible progress in healthcare. And definitely we are here to discuss and explore the advancements. But it is crucial to remember that our responsibilities go beyond labs and hospitals. Our progress in medicine isn't just about healing and new discoveries. It's also about taking care of our environment. I welcome all of you to my presentation. My study is titled as Biomedical Waste Management and Environmental Impact, a comparative study of public and private hospitals in Kerala, India. This is a social science research paper. So as my topic says, the primary aim of the study is to comprehensively investigate biomedical waste management practices in healthcare facilities in Kerala with a focus on both public and private sectors. There were four main objectives in this particular study. The first one was to assess the effectiveness of biomedical waste management practices in public and private healthcare facilities in Kerala, evaluate the administrative mechanisms in place for biomedical waste management, and identify areas for improvement. Third one, to analyze the level of preparedness and awareness among healthcare workers regarding biomedical waste management. Last one, to assess the level of satisfaction among healthcare workers in Kerala regarding the existing administrative mechanisms for the management of biomedical waste. So coming to the research methodology. So as I mentioned earlier, a comparative approach is employed in this study. Moreover, this is a descriptive and analytical study. It used convenient sampling for the collection of data. The entire study revolves around the hypothesis that effective administrative mechanisms and well-trained healthcare workers can enhance the efficiency of biomedical waste management practices. So coming to the findings. There are three main findings in this particular study. The data highlights the marked difference in waste management practices between public and private hospitals. Private hospitals demonstrate a higher level of commitment, more proactive approaches, and greater resource allocation, resulting in more effective waste management. Public hospitals face challenges that need to be addressed, such as increasing the frequency of waste collection and reducing instances of improper disposal. The second one is regarding a notable disparity in level of satisfaction among healthcare workers in public and private hospitals regarding administrative mechanisms in biomedical waste management. It was found that only 50% of healthcare workers in public hospitals expressed satisfaction with the steps taken by the administrative systems for managing biomedical waste. In contrast, a significantly higher percent, that is 80% of the healthcare workers in private hospitals, reported being satisfied with the administrative organizations' efforts in biomedical waste management. The final one is the data shows that there is a noticeable difference in the level of preparedness and training among healthcare workers in public and private hospitals in Kerala regarding waste segregation. So based on these findings, a few recommendations are derived. So the first one is our integrated waste management training program, technology adoptions, more awareness campaigns, government regulations and incentives, regular audits and monitoring, continuous research and innovation, more healthcare worker engagement, environmental impact assessment. So coming to the conclusion, this research study sheds light on the critical disparities in biomedical waste management practices within Kerala's healthcare sector. It emphasizes the pressing need for a collective effort to reform and optimize these practices with a dual purpose. The first one, reducing their environmental impact, and the second one, to improve the efficiency in both public and private hospitals. So these are the major references used to make this particular slides. Thank you.
Maybe a general question regarding this one.
Sure, sir.
which state do you think has producing the most biomedical waste?
Yes, sir. So, as per the census of 1991, so it was found that Kerala is having more biomedical waste compared to the other states. So that's why that is the primary reason why I choose Kerala in particular.
Okay, fine.
Yes, sir.
Thank you, Suji.
Thank you, ma'am. Thank you, sir.
Dr. Prasudha?
Yes, ma'am, I'm ready now.
Yeah. You
Shall I
can
start, ma'am?
start your presentation. Please, again, a
Yes, ma'am.
request, don't exceed the time limit.
Good afternoon, everyone. I'm Dr. Kritika Tangavelu. Yes, ma'am. I'm Dr. Kritika Tangavelu from Associate Professor in the Department of Chemistry, Satyabama Institute of Science and Technology. Today, I will be presenting green synthesis of strontium oxide nanoparticles using henna leaves and its catalytic activity. So, we know that the green synthesis is a very good method in order to synthesize metal oxide nanoparticles and other catalyst particles, because we are not using their solvents, and we are not using any harmful chemicals there. So the synthesis method is also easy and convenient. Okay. Next slide, sir. Next slide now. Yes. So metal oxide nanoparticles will have different surface and optical properties compared to that of bulk. So it also has a different electrical as well as catalytic properties. So it can be used as a very good catalyst to synthesize materials as well as in other applications also. Next slide. Now. So this was actually I was telling about the green synthesis method. So this can be also used for large production, and this minimizes the side effects and the other side reactions also. Okay. Next one, ma'am. So the method of synthesis, we have chosen henna leaves, and we have prepared the extract from henna leaves. And this henna leaf extract is used to synthesize the strontium oxide nanoparticles. And for this, the raw material we have taken is strontium nitrate. And to adjust the pH, we have used sodium hydroxide. And the precipitate which we obtain, we filtered it and washed, and we have dried it, and we have used this as a catalyst. So this nanoparticles is characterized by various techniques, and we confirmed the nanoparticle formation by FTIR. So where the SRO bond, that is the metal oxide bond, we got it near to 800 centimeter inverse, and the other peaks we got can be related to the CO bending, and a very small peak we obtained between 3000 range, that we can represent the OH groups that may be present as an interstitial water molecules in the material. Okay, next one, ma'am. Yes. And the same picture has shown the surface morphology, and here the particles are not purely spherical, they are distorted and they are agglomerated, so that can be easily visualized from the same image. And the EDAX of this SRO nanoparticles confirmed the presence of 30% of weight percentage of strontium and 49.49% of oxygen, so that it confirms the product formation, and small impurities are present. Next one, ma'am. Yeah. So the material is actually crystalline, and that is obtained from the XRD pattern. So the crystalline nature is confirmed by the pattern. So this shows sharp peaks. The sharp peaks related to 30 to 40 2 theta values, like 31.78 or 34.41 and all. They are given to the database. From the database, we have confirmed that it is belonging to the strontium nanoparticles, and they correspond to different hexagonal planes also, like 1002, 002, 101, like that. So it confirms the nature of crystalline nature of the material. And the crystallite size we calculated from the Debye-Scherer law was about 40 nanometers. Next one, ma'am. And this is the catalytic activity. So the material we have just tested for catalytical activity by conducting an one-pot synthesis material. So this synthesis we derived a pyrene derivative, and this pyrene derivative we prepared by vanillin, melanonitrile, ethyl acetoacetate, and then we reflexed this using ethanol as solvent. And after that, we confirmed the product confirmation by the NMR, mass, and FTIR. And the reaction scheme is next one, ma'am. Next slide, ma'am. Nice. So this is the reaction scheme. So this reaction scheme, you can see that ethyl acetoacetate and melanonitrile and vanillin is added together. So this is like an one-pot synthesis, and then we prepared the product. This product we have confirmed from the FTIR, NMR, and mass spectroscopy. Next one, ma'am. So this is the FTIR spectrum. So the FTIR spectrum, we can see the OH, all the bonds that is formed in the functional groups that is present in the product. We have confirmed with the stretching frequencies that is obtained here. So OH and then C, CN, CO, NH, all these bonds we have confirmed from the FTIR spectrum. Next one, ma'am. And the mass spectrum shows the molecular weight as 330.12. So that exactly matches, and we got the molecular ion peak at this value. And the mass spectrum confirms the product formed with the exact mass. Next one, ma'am. So this is the proton NMR. So proton NMR, we have seen the NHC triple bond, all the bond formations we can see from the NMR spectrum. And this is C13 NMR. So C13 NMR also confirms the presence of the product formation. And we have given this thing to antibacterial activity. So the product that is formed, we are going to test it for antibacterial activity, how it is working. And conclusion, strontium oxide nanoparticles are synthesized by green synthesis method, and we have confirmed that by characterization techniques. And the catalytical activity we have tested by one-pot synthesis. So it shows that it is a very good catalyst for various chemical reactions. Thank you.
Madam, out of curiosity, I'm asking a question.
Yes,
what is the role of taking strontium oxide as your nanoparticle? There are many nanoparticles.
Yes, sir. Yes, sir. So actually, we have tried this reaction with other metal oxide nanoparticles also, sir. So we just, out of our curiosity, we just want to try with metal oxides, other metal oxides also. The yield was not very high. The yield was like 70%, 65% only we got yield for this reaction. So how to improve the reaction studies, we have just, we are in the planning, sir.
No, specifically you're taking the second group metal oxide. That is my question. So many of them that have taken zinc or something like Na2 plus or like that. So
yes, sir. Usually we do it with zinc or magnesium. So the same reaction with the zinc and magnesium, we got a very good yield, sir. But here we didn't get such a good yield. Maybe that material is not very high effective compared to that of zinc and magnesium. It may be like that, sir. So out of curiosity only, we also tried the second group elements.
Okay. So one more question regarding that one-pot synthesis. I have given a product there. So did you observe any side products? Because you have a lot of material characterization techniques. You have just told that you have got the product. Did you observe any side products regarding that one?
Actually, we didn't get any side products as actually the mass confirmed with the mass only we confirmed, and we recrystallized and taken that compound. So actually we didn't find any side products, sir.
Okay, fine. Thank you.
Thank you, sir.
Madam.
Thank you, sir. Yes, sir.
Hello. Hello.
Yes, sir. Yes, sir.
I am Professor Rajendran, Susha Rajendran.
Yes, sir.
You have made use of henna leaves extract.
Yes, sir.
What is the chemical constituent, active principle present in lazone? You have not mentioned that lazone is responsible for reduction of your compounds.
Sir?
Active principle present in henna leaves
yes, sir.
lazone, madam, but you have not
yes, sir.
actually wanted to ask a question, but I have given you the answer. That is mainly
Okay, sir.
responsible for that. And you have made use of FESM. It is available in your laboratory. Dr. Viswanathan is in charge of FESM. You have not made use of that.
Yes, sir.
Available in your institute. Then metal oxygen bond in FTIR will be around 600
Yes, sir.
nanometer and not around 800 nanometer. Please check up that.
Okay, sir. Okay, sir.
Your HOD,
Okay, sir. I will check.
Dr.
Yes, sir.
Karthikeyan sir will help you. I visited your
Yes, sir.
lab
Yes, sir. Sure, sir.
on August 22nd. Just to recollect, one stranger visited your lab, and that is myself. And we are missing
Thank you
your
so much, sir.
former HOD Sheikh maybe, sir. Then what is the difference between, you mentioned about mass, what's the difference between molecular ion peak and base peak? Is there any difference?
Base peak will be the percentage of the fragmentation which is having a lot higher concentration, sir. That will be the base peak, sir.
100% peak is called the base peak.
100% peak is
Yeah,
called as the base peak, sir.
100% peak, right? Sometimes both will be same. Sometimes they will be different.
Thank you, sir. Thank you, sir.
Then in what state MS is recorded? What state is MS in general? I am asking very simply.
Sir?
In what state in general MS mass spectroscopy is recorded? What I will give you the answer. Solid state,
Sir, I
liquid
didn't get your
state,
question, sir.
or gaseous
MS
state.
in mass you are asking, sir?
A mass spectroscopy is recorded in solid state, liquid
Yes, sir.
state, or gaseous state. Usually it is recorded in gaseous state, madam.
Okay,
Mass
sir.
spectroscopy is recorded only in gaseous state. The basic idea. Okay, madam. Thank you.
Okay, sir. Okay, sir. Okay, sir.
Thank you, Dr. Titik.
Thank you, ma'am. Thank you.
Yeah, thank you. Next, we have OP13, Ms. Vishwadhara.
Yes, ma'am.
Yeah.
Ma'am, can you see my screen, ma'am?
Yes, Vishwadhara.
A very good afternoon, everyone. I'm Vishwadhara, and I'm here to give a presentation on my project, Bio-Inspired Synthesis of Sulfur Nanoparticles and its Application, under the guidance of Dr. V. Sri Bharati and Dr. C. Jayaprabha. So let me quickly list out the scopes and objectives. First is to synthesize sulfur nanoparticles using Ficus religiosa leaves, and then to study the synthesized sulfur nanoparticles using various characterization techniques, and then to study the antibacterial activity of the biogenic sulfur nanoparticles.
Excuse me, Vishwadhara.
Yes, ma'am.
Can we skip the scope and objective and go
Okay,
to the
sure.
main part?
Yes.
Yeah, thank
Yes,
you.
ma'am. So we all know that our body is a home to trillions of microbes and especially bacteria. Well, though all bacteria are not harmful, bacteria like Staphylococcus aureus and Escherichia coli are the most prevalent species of gram-positive and gram-negative bacteria, which in recent studies have proven to cause severe bloodstream infections, which would lead to mortality. These are some of the diseases caused by Escherichia coli and Staphylococcus aureus. And this is a recent case study which was done on December 2022. Here you could see that most of the deaths are only due to the infections caused by Staphylococcus aureus and Escherichia coli. Moving on to the next slide. So, due to the increased mortality rate, so reducing the burden of death due to infection is an urgent public health priority. So, whenever we talk about antibacterial or antimicrobial agents, right from penicillin to plasmodium, the recently invented antibacterial agent, most of the drugs contain sulfur in it. And this is mainly because sulfur is a good antibacterial and antifungal agent. But due to the inappropriate usage of medicines, many bacteria have started showing resistance towards the sulfur drugs. But still, we have nanotechnology which has presented a new horizon to overcome abundant problems, including drug resistance. So, nano-sized sulfur, especially, has proven to retain its bactericidal activity. And we know that sulfur has been used as an antibacterial agent since our ancient time. So we planned to synthesize sulfur nanoparticles using Ficus religiosa leaves. And when it comes to green chemistry, there is no big explanation needed because we all know the advantage of green chemistry. So why specifically did we choose Ficus religiosa leaves? Is because first thing is because of its availability. So you could even see this tree growing from the walls. So that abundant the tree is. And not only that, they have a very great lifespan of around 900 to 1500 years. Apart from all of this, they are used in traditional medicines for curing diseases like asthma, diabetes, epilepsies, infections, and sexual disorders as well. So we synthesized sulfur nanoparticles using Ficus religiosa leaves, and these are the materials required. So Ficus religiosa leaves were washed and dried at room temperature, and around 100 grams of the leaves was taken, and it was mixed with 1000 ml of water, and then the leaf extract was obtained. And to the leaf extract, we added sodium thiosulfate pentahydrate. Along with 125 ml of 20% citric acid, and this was kept for stirring for 1 hour, after which the precipitate was centrifuged at 5000 rpm and the precipitate was obtained. And the resultant sample was given for testing. The basic preliminary laboratory test what we did was sodium nitroprusside test. So to the Lessines filtrate, we added few drops of sodium nitroprusside, and then the solution turned purple, which indicated the presence of sulfur. Followed by this, there were various characterization techniques done. So first is UV visible spectroscopy. Here, a peak which recorded at 298 nanometer indicated the formation of sulfur nanoparticles, followed by FTIR analysis. So a peak at 610 inverse centimeters showed the formation of sulfur nanoparticles, which was in reference with the literature. And along with the other peaks recorded for the biomolecules and the byproduct which is formed. So here the byproduct formed was sodium citrate. Moving on to X-ray diffraction analysis. So here the 2 theta values, the respective 2 theta values confirms and tells us the crystalline nature of the nanoparticles. And the crystalline size was found to be 23.4 nanometers. And this is the SEM image, which had a low degree of agglomeration, followed by energy dispersive X-ray analysis, which showed peaks for sulfur, carbon, oxygen, and sodium. So the peaks which was recorded for carbon, oxygen, and sodium might be due to the sodium citrate, the byproduct which is formed. And in order to confirm the exact size of the sulfur nanoparticles, dynamic light scattering was taken. Here, the size was found to be 23.9 plus or minus 7 nanometer, which was quite similar to what we obtained from X-ray diffraction. And the zeta potential was found to be minus 34.1 millivolt, which shows the stability of these sulfur nanoparticles. Moving on to application. So the biogenic sulfur nanoparticles, what we synthesized from the Ficus religiosa leaves, were showing good antibacterial activity against Staphylococcus aureus than Escherichia coli. So summarizing the entire work, a cost-effective and environmentally friendly method was adopted to synthesize sulfur nanoparticles using Ficus religiosa leaves, and the nanoparticles was characterized using various characterization techniques, and the nanoparticles was found to be in nanometer scale with the help of X-ray diffraction and DLS. And the future scope of the work is to combine these sulfur nanoparticles with purified elemental mercury and to study its anti-cancer activity using MTT-assay. Thank you.
Okay, it was a good presentation on sulfur-related thing.
Thank you.
It is well known that most of the antibiotics they do not react with methionine and cysteine amino acid in our body due to sulfur property. So it
Yes,
may
sir.
cause some allergic to many patients if they
Yes.
take. So in your
Yes.
case, we have prepared a sulfur nanoparticles for treatment of ailments. Okay.
Bacterial disease, yes.
So what is the role of sulfur there? It may not react with the amino acids, which may cause some inflammation or something like allergies. How do you account for that one?
Sir, I guess sulfur could be used specifically for certain diseases. For example, here in this case, the disease caused only by Staphylococcus aureus, because here we could see that sulfur was showing a good antibacterial activity against Staphylococcus aureus. So I think it could be selectively used for that particular disease.
Okay. So is there any trials going on that one, or is a new one for?
Sir, not the trials has not yet been started.
No,
Sir.
trials it has been.
We're
You
working
have
on
been
it.
okay, working on it. Fine. Okay. Fine.
Yes, sir.
Thank you.
Thank you, sir.
Thank you, Vishwadhara. It was a good presentation. Next, we have OP14, Mrs. Priya.
Yes, ma'am.
Yeah, you can start your presentation.
Yes, ma'am. Ma'am, can you able to see my sharing?
Yes, we can.
Yeah. Yes, ma'am. Good morning to one and all gathered here. I am Priya. I am D. Priya, research scholar under the guidance of Dr. Hen Hajra by V. Ma'am. Department of Chemistry, Sri B.S. Abdur Rahman Crescent University. And my title of the presentation is Efficient Photocatalytic Degradation of Methylene Blue by Green Root Synthesized Titanium Dioxide Nanoparticles using Centella asiatica. Outline of the presentation is introduction, objectives, materials, methods, results, discussion, application, and conclusion.
Excuse me, Priya.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
It seems Chairperson Dr. Kumaran has lost his connectivity. Just can you stay for 5 minutes?
Yes, ma'am.
Yeah.
I request all the participants to kindly adhere on the time. We request you to present only the results and discussion part.
Sylvia Anani from Ontario.
Sunita? Sunita?
Yes, ma'am.
Ask her to proceed, ma. Ask her to share the screen.
Okay. Priya? Mrs. Priya? Priya, you're there in the meet?
Yes, ma'am, she's there. She will present now, ma'am.
Yeah, ask her to present.
Yes, ma'am. Yes, ma'am, I'm sharing now.
Yeah, please.
Ma'am, can you able to see, ma'am?
Yes, ma'am, we can see, ma'am. Proceed, ma'am.
Okay, ma'am. Good afternoon to all, ma'am. My title of the presentation is Efficient Photocatalytic Degradation of Methylene Blue by Green Root Synthesized Titanium Dioxide Nanoparticle using Centella Asiatica. So the outline of the presentation is introduction, objectives, materials, methods, results, application, and conclusion. So that is what introduction of the work, how I am synthesizing, characterization, and application and expected outcome. Introduction of the work. See, that is water is very essential for the
Ma'am,
universe.
excuse me, please.
Yes.
Please directly go to the results and discussion part, ma'am.
Okay, ma'am.
You're running out of time.
Okay, ma'am. So this is part of the titanium dioxide nanoparticle by using the plant extract, that is 20 ml of the plant extract Centella asiatica is, that is in Tamil we can say that is Vallarakairai. Add 3 ml of titanium isopropoxide to that solution, and then it is stirring for 2 hours, and the color change is observed. It represents the formation of nanoparticles, and then after that centrifugation and filtration will be taken place. After that centrifugation, we have dried for 30 minutes in a hot air oven about 90 degrees Celsius. After that, and powdered and calcined at 400 degrees Celsius for about 2 hours in a muffle furnace. And then finally, we can get the white color powder, that is titanium dioxide nanoparticles can be obtained. So that is how the leaves has been showed. Then after that, the color change is shown in that picture. Characterization studies, that after the titanium dioxide nanoparticles formed, the UV, we have did so many characterization. In the UV results, it shows the 392 nanometer wavelength. It shows the conformation of titanium dioxide nanoparticles form. And then the band gap energy is calculated by TOC equation, that is a 3.11 electron volt. And then FTIR shows this. It has a phenol alcoholic group, so it is used as a reductant. It is used as a reductant and also as a capping agent. And then XRD analysis. The XRD analysis is perfectly matches the JCPDS of the titanium dioxide nanoparticle. It is an anatase form of the titanium dioxide nanoparticles are obtained. So there will be no peaks will occur in the rutile and brookite form. Only anatase form we can occur. And then FESIM analysis. The FESIM analysis shows that a morphology of the nanoparticle, titanium dioxide nanoparticles, and then EDAX shows a confirmed peak of the titanium and oxygen peak are shown in this EDAX graph. And then HRTM analysis of titanium dioxide nanoparticles has been shown. Here, the particle size has been calculated. It is around 10 to 12 nanometer particle size has been obtained by using this synthesis. This is 2D dimensional and 3D dimensional, both of them I have shown. And then finally, the application is what we have did is photocatalytic degradation by using the titanium dioxide nanoparticles. Particles. That is, I have taken the dye is methylene blue. The degradation has been taken place after the 4 hours. If you see that after the 4 hours, the degradation has been taken place. And finally, after 24 hours, complete degradation is taken place. The color is completely disappeared. The photo degradation has been shown in the graph. Conclusion. So from this, the green synthesized titanium dioxide nanoparticles, the biological property, as well as we are going to analyze further, as well as the photocatalytic degradation has been taken place, is good confirmation. And then titanium dioxide nanoparticles are confirmed by the EDAX analysis and spherical in structure. And then FTIR and XRD shows the crystallization and functional group of the titanium dioxide nanoparticles. The confirmed titanium dioxide nanoparticle obtained from leaf extract Centella asiatica has been proved of an effect of photocatalytic study on the dye removal. And then these are the references. Thank you.
Madam Priya.
Yes, sir. Yes, sir.
You are from the BS Abdul Rahman.
Yes, sir.
And the Hazar of the
okay, sir. Okay.
Your guide.
Sir, Dr. N.
Ramesh Kumar.
Okay, madam. Your guide is one madam.
Yes, sir.
Your HOD has retired, Iswaramurthy.
Yes, sir.
Kutti madam is there.
Yes, sir. She is there, sir.
That means I am familiar with your background. Your co-worker, Usha, is also presenting one paper.
Yes, sir. Yes, sir. Of course, sir.
Sir, right. You have made use of Vallarai.
Yes, sir. Vallarai, sir.
But you are not mentioning the active principle present in Vallarai, madam. Formerly, the Kanna madam also did not mention what is responsible for reduction.
Okay, sir.
And the titanium dioxide mediated decolorization of methylene blue.
Yes,
It's
sir.
a very old, very old concept. Usually, wherever you go, you can see papers, scopus indexed papers.
Hmm.
Titanium dioxide decolorization of methylene blue is old concept. You can make use of other dyes also.
Okay, sir. Further dice we will try, sir.
Other dyes, there are so many dyes. And the band gap we have calculated is 3.11 electron volt.
Yes, sir.
What is whether it's a semiconductor, conductor, or insulator?
Semiconductor, sir.
No, semiconductor means 2 to 3. 1 to
Yes,
6
sir.
is conductor, 2 to 3 is
E-
semiconductor, 3 above 3 it is insulator. This I may be wrong. It's a check up,
Okay,
but
okay, sir.
cleverly escaped. He did not say anything about that. Otherwise, your paper is very good, madam. Congratulations.
Thank you, sir. Thank you so much, sir.
Let us go to the next speaker.
Okay, sir. Thank you, sir.
Thank you, madam.
Okay, ma'am, we can continue with the next speaker.
Okay, sir. Okay. Next, OP15, Ms. Jeevita.
Ma'am, I'm sharing my screen, ma'am. Ma'am, may I start?
Yes, you can start.
Good afternoon, one and all. My project presentation is based on the topic phytochemical investigation and antimicrobial activity of the ethanolic extract of Glynas lotatus. I have done under the guidance of Dr. P. Tilagavati ma'am, Ethiraj College for Women. An introduction: as the quote, let the history tell the future. Phytochemistry aim to build the gap between modern science and traditional technology. It is the study of phytochemical, especially the primary and secondary metabolite. Secondary metabolite, though present in small amount in the plant, it is useful in the development of new drugs and treatments of various diseases. So the plant material used for this isolation is Glynas lotatus, which is collected from Palayamkottai. Around 2 kg of the powder sample was taken, and upon soaked in 5 liter of ethanol and followed by filtration, concentration, and the extracts were combined. The yield of crude extract was 0.430 grams only. The isolation was done using column chromatography. The column used has the dimension.
Excuse me, Jeevita.
Yes, ma'am.
Excuse me, Jeevita. Can you just cut short the methodology part?
Yes, ma'am.
Yeah, thank you.
So the column was packed with the ethanolic extract of the plant. The solvents used were N-hexane, chloroform, and methanol. On the concentration of 60% chloroform and 40% methanol, the fractions were obtained. That is between 108 and 142. These fractions has similar characteristic feature, so they were combined and concentrated. And I have named that fraction as GL142. And for purity check, I have done TLC analysis with the mobile phase as N-butanol, toluene, acetic acid, and water in the ratio of 3:1:1:1. I had got a single spot. It indicates the purity of the isolated fraction, and the fraction is subjected to preliminary screening to check the type of flavonoid, type of secondary metabolite, and it was confirmed with the Shinoda test in the presence of flavonoids. And upon HPTLC analysis, in the track 1 shows the ethanolic extract of the plant, and track 2 shows the fraction GL142. The yellow spot in the lambda 520 nanometer was successfully isolated in the fraction GL142. The yellow color shows the presence of flavonoid, and upon UV spectrum analysis, there were two major absorption peaks between 300 to 380 nanometer and 240 to 280 nanometer with reference to the literature. These major absorption peak correspond to the flavonoid, and the band 1 distinguishes flavones and flavonols as it is in the range of 344 nanometer, and the band at 276 nanometer indicates the presence of hydroxy group at the 4' position. And when it is subjected to GCMS analysis, the gas chromatogram shows the retention time 19.415 minutes as 100% intense peak. And when it's subjected to mass spectrum analysis, the mass peak shows that MBI is at 270 and the base peak at 74, which indicates the presence of apigenin, which is a flavone, which has a molecular formula of C15H10O5. And upon application studies, the fraction was subjected to antimicrobial activity. The increase in the concentration of the extract increases the inhibition activity of the growth of microbes. This is due to the presence of the flavone, which is apigenin in the extract, inhibits the growth of microbes. The various microbes used were some fungi and some bacteria. And this is the inhibition activity. And the conclusion was the Glynos lotidus was successful in the isolation of a fraction that contains flavonoid, that is apigenin, which is of high antimicrobial activity, and it was serendipitous and was unexpected. And these were the references, and thank you.
Okay, it's a good presentation, Ma.
Thank you, sir.
Fine.
Sir, we can't hear you, sir. Imran, sir. So can we go to the next participant?
Yes, ma'am. You can go for next participant.
Okay. Next we have OP17, Mrs. Usha. Mrs. Usha, you are there in the meet?
Yes, ma'am. I'll present now, ma'am.
Yeah.
Good afternoon, Ananda. I'm Usha, Research Scholar, Department of Chemistry, B.S. Abdul Rahman, Crescent Institute of Science and Technology. My topic is eco-friendly synthesis of titanium dioxide nanoparticles using desiccated leaves of Laurus nobilis. And my outline of presentation is introduction, objective, materials and methods, results and discussions, and conclusion. I have chosen metal oxide nanoparticle for the synthesis. Why I have chosen titanium dioxide nanoparticle means it have lot of wide applications, as we know already. Many papers are there. And I have chosen green synthesis, that is eco-friendly synthesis. Why I have chosen green synthesis means compared to physical method and chemical method, we have lot of advantages towards green synthesis. That is no toxic chemicals, no need more space, and it's environmental friendly, less time and renewable sources. And my objective of studies is to synthesize titanium dioxide nanoparticle, and characterization have done for analyzing the morphology, size, and functional group elements present in the material. And biological studies also done towards that. And what are the materials? My precursor material is titanium tetraisopropoxide, and I have taken desiccated leaf extract of Laurus nobilis. That is, Laurus nobilis is the common name. It is called as bay leaf, which is already known and proven material for antibacterial, antimicrobial activity from the ancient period onwards. So I have chosen this material for synthesis of titanium dioxide nanoparticle. In my synthesis, that is the Laurus nobilis Laurus material which is, that is, flavonoids, polyphenols. It actively involved for the involved as a reducing agent and a capping agent for my nanomaterial. And for the analysis of particle size, shape, and structure of material, I have taken UV visible, FTIR, SEM, XRD, TEM, all the things. And in UV visible spectroscopy, for me, I have analyzed that it is 312 nanometer. And the band gap of my material is around 3 point. And this is FTIR study. The functional group present in my nanomaterial, I have analyzed using that FTIR studies. Then using the XRD analysis, we have found out the crystalline phase of the material. And this is a SEM analysis which we have done. Here I have analyzed that my material is in spherical in shape, and the elements present in my material is titanium dioxide nanoparticle. I have confirmed use EDAX. And after that, application side, I have done disk diffusion using disk diffusion method. That is gram positive and gram negative bacteria towards an E. coli and Bacillus subtilis we have taken. Here actively it is it is confirmed that it is act as antibacterial. And antioxidant studies I have done using DPPH, then PM assay, then ABTS assay. Using all those things, I have analyzed that it is proven that it is a good antioxidant too. Then using anti-inflammatory, that is comparing with diclofenac. Already we know that diclofenac is it's an medicine we are using for anti-inflammation. While I'm comparing with my material, this diclofenac, almost it is equally effective. So I confirmed that my material is anti-inflammatory also, good anti-inflammatory also. So finally, I'm concluding with this. My material is antioxidant, anti-inflammatory, and also it is an good antibacterial agent. In future, I'm trying to anti-cancer study also. Thank you.
Yeah, good presentation. What is the structure of TaO2 there? Anatase structure or rutile structure?
Sir, sorry, sir.
What is this morphology of TaO2 here? Anatase or rutile?
Anatase, sir. It is anatase.
Okay, fine.
Sir, 1 second, sir. I am Professor Rajendran from Dental, sir. Hello?
Yes, sir. Yes, sir, please, sir.
I am very much pleased to see one of my MSc students at Dental.
I'm also very happy to hear your voice, sir.
Yeah, when she was doing her MSc, she received that ETCST student research project. And when she presented the paper in the conference, she was awarded the best paper awardee. She was the best paper awardee. I am very happy to see my student again on the screen. And she has worked with me there are many papers to be published. There are data research data with me. We will try to publish in reputed journals. Thank you. Best wishes.
Thank you so much, sir. Thank you for giving remembrance about me. Thank you so much, sir. I'm so proud.
Okay. So we can go to the...
Yes. Yeah. Next, OP19, Ms. Kayalviri.
Yes, ma'am.
Yeah. You can straight go to the result and discussion part, ma'am.
Yeah, I'm sure.
Yeah. Thank you.
So good noon to everyone. I am Kyle from WCC. Today I am here to present on the topic effect of metal oxide nanoparticles as modern and natural dye. As we all know, natural dyeing is obtaining dye from nature. Nowadays, our world is working towards nature. Since natural dyes are biocompatible and biodegradable, it is having wide applications. But the only drawback in natural dyeing is it is having a poor color strength. To modify this, mordants have been used. Mordants are nothing but they are binders for the color to get absorbed on the fabric. Generally, we use potash alum, that is potassium aluminum sulfate, which is used as mordant. The other examples of mordants are metal and metal oxides. Some other examples such as ferrous sulfate and copper sulfate can also be used as mordant. Here we have used zinc oxide nanoparticles for our study. The zinc oxide nanoparticles the nanoparticles used for zinc oxide. The nanoparticles used for the study is zinc oxide. These nanoparticles were synthesized sonochemically with the help of zinc chloride and sodium hydroxide. Here, why I have chosen zinc oxide nanoparticles is it has wide range of applications due to its unique physical and chemical properties. And in the case of nanoparticles is having high volume surface area to volume ratio, and it is also having high surface energy. When this zinc oxide nanoparticles is used in the fabric, it also increases the durability of the fabric. Now, the prepared zinc oxide nanoparticles was characterized by FTIR spectroscopy and scanning electron microscope. With this, we can able to confirm the structure of zinc oxide nanoparticles as hexagonal shape. Now we'll move on to the Move into the dyeing of zinc oxide nanoparticles in cotton fabric. The dye used here is sapenwood. It is also known as Caesalpania sapenwood, and it belongs to the family Caesalpaniaceae. This dye extract is prepared with the help of boiling water. It is boiled for a few minutes, and the dye extract of red color is obtained. The sapenwood dye shows red color due to the presence of a chemical compound brazelin. So, due to this presence of brazelin, the dye exhibits its red color. Now, when we look into the chemistry of the metal oxide here, the metal ion of the mordant is acting as an electron acceptor, and the bracelin is acting as electron donor. So when these combine, they form a coordinated complex of zinc oxide nanoparticles and the bracelin present in the complex, and they show the color when it is dyed in the cotton fabric. Now, this is a sample of dyed extract, that is sapenwood plus alum. And second image is about sapenwood extract, alum, and with the synthesis of zinc oxide nanoparticles. Now, this is confirmed by two fastness tests. One is washing fastness and other one is rubbing fastness. With these results, we are able to determine, we can able to say that the washing fastness and rubbing fastness is more for the sample, which is having zinc oxide nanoparticles, alum, and sapenwood. With this, I would like to conclude that with the help of nanoparticles, we are able to we can able to synthesize different shades of colors, and we can reduce the use of synthetic dyes, which will be helpful for our nature. So, with the help of nanoparticles, there is a high washing fastness and rubbing fastness to improve the textile. Thank you.
Okay, ma'am. It was a good presentation.
Thank you, sir.
The next person can give a presentation.
Okay. OP20, Ms. Janita Heps.
Shall I start the presentation?
Ms. Janita.
Yes, ma'am. Can you hear me?
Yeah.
Good afternoon. So I'm Janita from Women's Christian College. So the topic for this the study is the effect of carbon dioxide nanoparticles as models for natural dyeing of cotton fabric. Natural dyes are derived from the plant sources, which are biodegradable, whereas the synthetic dyes are chemically synthesized and they are not biodegradable and carcinogenic.
Ms. Janita.
Yes, ma'am.
Sorry to interrupt. Can you please skip the introduction part?
Yes, ma'am.
Thank you.
So the scope of the study is the preparation of the carbon dioxide nanoparticles as mordants and effectively using the dyeing process of the cotton fabric. Methodology used is the preparation of the fabric using the auxiliary mordant carbon dioxide, the extraction of the natural dyes from the plant sources, and the analysis of the dyed fabric. So in this study, we are more concentrated on the D. So the synthesis of copper nanoparticles, the equal proportion of the copper nitrate and urea is being used, and it is kept in oven for about 20 minutes, washed with ethanol, water, and acetone in the sequence, and it is centrifuged, and the copper oxide nanoparticle is being synthesized. The extraction of dye, the tea powder is being boiled in distilled water for about 20 grams per liter at 40 degrees centigrade, and the tea extract is being obtained. The dyeing of the cotton fabric. The cotton fabric along with the mordant, potash iron, is being dyed and it is being dyed using the steel starch. The fabric is being obtained. And along with the above process, the copper oxide nanoparticles, the auxiliary mordant is being added and the finally dyed with the tea extract and the fabric is being obtained. So using these good fabrics, the research analysis have been done. So first, the characterization of the copper oxide nanoparticles using the UV visible observing. So band is being seen with 228.6 nanometer, which confirms the copper oxide nanoparticle. participants synthesized. And the FTIR spectra of the copper oxide nanoparticle has been assigned at 1418.40 and 419. We assigned as a vibration of copper 2 oxide bonds, and the sharp peak at 669 confirms the presence of the copper oxide nanoparticles in the broad band, and broad peak at 3630 is due to the OH stretching of the water molecule. The sum of the copper oxide nanoparticles shown to be spherical in shape, and the size is moving about 42.26 nanometers. The effect of models and dyeing. The T constants of the chemical constants such as catechin, gallocatechin, catechin gallate, and gallium catechin gallate. So these comes under the category of polyphenols, which are the class of the natural small molecules that are composed of one or more phenol hydroxide groups. So using this, the copper oxide nanoparticles binds very well and gives a good results in the fastness property. The fastness property is categorized into washing fastness and doubling fastness. So it is graded in the scale of 1 to 5, where 1 has a high degree of color transfer, whereas 5 is no color transfer. So the washing fastness of the copper oxide plus T is 4.5 in the washing fastness when compared to T. And in rubbing fastness, using the copper oxide nanoparticles in wet is 3.5, and in the dry is 4.5. It shows a good increase in these quantities. And when checking the antibacterial activity, the copper oxide used nanoparticles in the margins in the dyeing process gives a good significant results in the gram-positive and gram-negative bacteria. So conclusion, by using copper oxide nanoparticles is found to increase in the fastness property and the anti-significant antibacterial activity. Thank you.
Yeah, in this presentation, what do you expect the transition of the electronic spectroscopy? You got a peak for copper. So what is the transition, possibly?
It is about 228.6, sir.
Yeah?
228.6
No, what could be the transition? Is it a D to D transition or a metal to
Pi to
ligand
pi star,
transition?
sir. Pi to
Yeah?
pi star transition. This pi to pi star transition, sir. N to pi
I
star
can't hear you.
transition. N to pi star transition, sir.
When you have a metal and a ligand there, the possibility of a transition at very low wavelength is difficult to get. Did you check it out with some other
Yes, sir.
metal?
We found it with reference to the literature, sir.
Okay, fine.
Yes, sir.
Okay, thank you, Janita. We'll go to the next participant, OP21, Ms. Gauri.
Yes, sir.
You can share your presentation.
Yes, sir. Good afternoon, everyone. I'm Gauri from Women's Christian College, and the title of my presentation is Microwave Assisted Synthesis of Carbon Dots for Drug Sensing. Carbon dots are carbon nanomaterials of size less than 10 nanometers, and apart from carbon, they have different functional groups such as carboxyl group, hydroxyl group, etc., which increases the hydrophilicity range. They also have photoluminescence properties, and due to high quantum yield, they are used in various fields such as biomedicine, catalysis, etc. The objective of my project is to electrochemically sense the dark nitrofurantoin using carbon dots, which is prepared from sucrose, and they are doped with hydroatoms such as nitrogen and sulfur. Here we have prepared the carbon dots using the microwave, as it is a very less time consuming process. Okay, so nitrofurantoin, it is a very powerful and good antibiotic, and it works against a wide range of bacteria in the urinary tract. But since it contains a nitro group, it is necessary to monitor the dosage, and it is also a harmful pollutant of the environment, and hence the monitoring of the dosage is necessary. And so we are detecting the nitrofurantoin here using cyclic voltammetry. The glassy carbon electrode is used as a working electrode, platinum wire as a counter electrode, and the calomel electrode as a reference electrode. And from the voltammogram, we can see that the modified glassy carbon electrode shows sharper peaks than the unmodified glassy carbon electrodes. This is because the unmodified glassy carbon electrodes are not able to sustain the carbon dots present on the surface, and hence we are modifying it with Nafion, which is an anionic copolymer membrane, and it acts as a matrix, and hence the carbon dots are able to sustain on the electrode surface.
The characterization of the carbon dots was done using UV visible, FTIR, and SEM techniques. And from the UV visible spectroscopy, we can observe N to pi star transition of CO and CN. From the FTIR analysis, we can find the OH stretching, NH stretching, C double bond C, C triple bond C, C double bond S, and C N stretching of the carbon dots. From the same analysis, we can find that the approximate size of the carbon dots that we have prepared ranges from 20 to 50 nanometer. Apart from drug sensing, carbon dots also have strong absorption, high stability, non-toxicity, biocompatibility, etc. And because of this, they are used in various fields. And in conclusion, I want to conclude that the carbon dots that we had prepared using sucrose, which are doped with nitrogen and sulfur atoms, were able to detect the nitrofurantoin drug effectively. Thank you.
Yeah, what is the drug nitrofurantoin used for?
Sir, it is an antibiotic, sir, and it works with urinary tract infection.
Okay, fine.
Thank you, sir.
Thank you, Gauri. Next, we go to OP22, Ms. C.T. Dalmi. Ms. Dalmi, you are there? Yeah.
Yes,
Good afternoon, everyone. I'm Dalmi from Women's Christian College, and I have worked on electrochemical detection of lead ions using carbon dots synthesized from glucose. So, as we all familiar with carbon dots, they are quasi-spherical nanoparticles with sp2 and sp3 hybridized carbon, less than 10 nanometer of size, and it has the ability to show fluorescence. And when they are doped with metal oxides or heteroatoms, they show promising effect in sensing drugs, heavy metals, etc. So, moving on with our project, so the objective is to electrochemically sense the presence of lead ions in the solution using carbon dots as biosensors that are synthesized from glucose. So we have adopted a very simple method of microwave assistance. So first we have taken glucose and thiourea. Thiourea here acts as the donor, electron donor, or the nitrogen and the sulfur present in the thiourea serves as the electron donor here, and followed by the microwave assistance synthesis. And here comes the lead detection using cyclic voltammetry method. So first we have prepared a varied dilutions of lead nitrate solution from 10 to 40 ppm, and their observations are made between the potential window of -1 voltage to +1 voltage. And here is our CV setup, that is the classic carbon electrode acts as the working electrode and platinum wire as counter and calomel as a reference electrode. So as you can see, why we have modified GC is because the carbon dots that we prepared is water soluble, so that the classic carbon electrode may not be providing the perfect surface for the attraction of the lead ions that are incoming. Therefore, we have modified it with Nafion matrix, that is, it provides as an anionic copolymer that provides a surface for the carbon dots to fit in, so that it can attract more and more lead ions, and more will be the sensitivity. So here are all the results that we have obtained from all the ppms, different ppms, and here is the comparison, which clearly shows that so as you can see, the arrow mark of this peak is very less, and whereas the current observed here in the 20 m ppm is more. That shows that the modified classic carbon electrode can sense more amount of lead ions. So characterizations, we have taken UV in order to support the data that are the system that we used have carbon doped doped carbon dots. And FTIR is used to, it also supports the data that it has, it contains, our carbon dots contain sulfur and nitrogen groups, and some analysis. So this is to verify that the carbon dots that we synthesized are between the range of 20 and 50 nanometer. So here are the applications. Because of the good stability and eco-friendliness of CDs, they are used in various fields like biomedicine, anti-counterfeiting, and catalysis, energy storage, etc. So moving on to the conclusion. So therefore, we conclude that the carbon dots that we synthesized from glucose serves as a better sensor in the detection of heavy metals like lead. Thank you.
So what is the reason for choosing glucose here?
Sir, to be precise, like we have very stipulated time, and we got the availability of only glucose here in our campus. So,
Yeah, in most of the studies, they have taken glucose, but they have not taken fructose. What could be the reason?
maybe because of the optical activity of fructose. Like, glucose is also optically active, but it is like very much levorotatory, whereas dextrose is dextrorotatory. Sorry, glucose is dextrorotatory.
Okay, so it means the specific rotation also plays a major role here.
Maybe, sir, it might also interfere with the reaction.
Okay, fine.
Thank you, sir.
Thank you, Dalmi. Next, we have OP23, Dr. P. Malti. Dr. Malti?
Thank you, ma'am. I'm available, ma'am. Am I audible, ma'am?
Yes, ma'am.
Thank you. So, very good evening, everyone. My scope of presentation is completely different from those who have presented before. So, my topic is on obstacle avoiding robo using Arduino and voice control using Bluetooth. Let me share the screen now. Is the screen visible, ma'am?
No, ma'am. Yes, now it is visible.
Okay, thank you. So, main aim is to design a robo car that detects an obstacle using an Arduino board, and ultrasonic sensor and motor drivers are used. The ultrasonic sensor, the purpose of ultrasonic sensor is used to detect the obstacle, and the motor drivers are used to drive the servo motor and the motor wheels. And the servo motor also helps in changing the direction of the robo car whenever it hits an obstacle, and makes it to navigate a smooth navigation, and helps in smooth navigation of the robocar without hitting any obstacles. So the ultrasonic the sensor is mounted on the servo motor in order to rotate the wheels at different angles and to detect the exact path without hitting the obstacle. So the robocar is controlled using Bluetooth, which is available in the Android phone. So the present proposed technique is using ultrasonic sensor and Bluetooth module, and is also controlled using voice messages, and it can be used. It can be controlled using smartphone, and both manual and automatic control is possible in this robocar. Um uh, this is the essence of the project, and whenever the ultrasonic sensor finds an obstacle, it gives
Excuse me,
the
ma'am.
Your slide
yes,
is
ma'am.
not moving.
Excuse me, ma'am. Excuse me, ma'am.
Yes, ma'am.
Ma'am, your slides are not moving.
I'm landed at this slide, ma'am. I'm landed at this particular slide, ma'am. Hope it is visible now. The block diagram for proposed system. Hello, ma'am.
Yes, ma'am. Ma'am, can
Hello.
you just put it in slideshow mode?
Yes, yes. Ma'am, is it okay now? Ma'am?
Slide is not moving, huh? It's not moving, ma'am.
Ma'am, I'm landed in block diagram for the proposed system.
Yeah. We could
That,
see the slide,
ah,
ma'am, but
yes,
it's
ma'am.
not in slide share mode. Still, it is in
I've
the.
just made it. Ma'am, is the slide changing now?
No, ma'am.
Schematic diagram. Schematic diagram.
No, ma'am. It's still in the block diagram for proposed system.
Okay, ma'am. I'll stop sharing and sharing again. I'll try to share again.
Yeah.
Is it okay now, ma'am?
Yes, ma'am. Now it is in slideshow.
Okay. Okay. Thank you. So whenever the robocar find an obstacle, it used to sense the obstacle using the ultrasonic sensor, and with the help of the signal received from the ultrasonic sensor, voice messages are given to the Bluetooth module through the mobile phone, and the signals are then transferred to the Arduino board, and the Arduino board tries to control the robot. Is the slide changed now? Has my slide changed to block diagram of the system? Hello, ma'am. So the purpose of ultrasonic sensor is to sense the locate the obstacle where it is. So we know that velocity is equal to distance traveled by time taken. If we know the velocity of the sound wave and time taken for the ultrasonic sensor signal to travel back and forth, we can easily calculate the distance of the obstacle. I mean to say where it is located. And these are the description, Arduino board description. And though the motor driver is capable of driving both the DC motors and two servo motors, and the Bluetooth module is meant for transmitting and receiving the signals. So whenever the pin enable pin is high, it can able to send the signal. Whenever the enable pin is low, it can able to receive the signals from the robocar. So this is the completed model of the robocar, and this is my conclusion. And ultrasonic sensor is used to sense the obstacle and to navigate without any hassles. The motor driver is used for driving the DC motors. An Arduino board is used to control the movement of the robot. And in order to justify its performance, it is tested under by changing the number of obstacles and by changing the number of crowd. I mean to say more crowded and less crowded space it is tested, and by changing the shape of the obstacle also the robocar is tested. And in future we have planned to install a camera in the robocar, and also to install a temperature sensor to avoid fire hazards. And in order to make it sense a wide range, we are going to implement the infrared radio frequency Zigbee technologies, and it is supposed to work in all environments, and also without any human intervention also. These are my references.
Madam, can we make use of data science in your field, madam?
Yes, sir. Yes, sir. Yes, sir. It's possible, sir.
Impossible or possible, madam?
Possible, sir. It is possible.
Then is it an experimental work or only simply data collection from the review?
No, sir. It is a model, complete model done by my students named Melvin Roger, Arnold Matthew, Lokesh, and Danish. So I wish to submit the credentials to them also. So I'm also presenting on behalf of them.
Because see, you are giving so many references. I thought that this is a collection of review of literature. It is a basic work done by your students.
Yes, sir. Under my guidance. Under my guidance.
Under me? What? Who is your
Under
guide?
Sir?
Under my your guide. Who is your guide?
Sir, I am their guide. I am their guide.
Oh, you are.
Yeah.
You must be knowing Dr. Madhavan, madam.
Yes, sir. Yes, sir.
Wow. Madhavan, sir? Mahalingam, sir?
Mahadevan, sir. Dr. Mahadevan.
Dr. Mahadevan.
Yes, sir. Yes, sir.
Okay, madam. Congratulations.
Thank you, sir. Thank you very much.
This must be familiar to you.
Yes, sir. Very familiar, sir. Dr. Rati, sir, is working along with me. He's my colleague. Yes, sir. Yes, sir.
You have recognized, okay.
Yes, sir. Yes, sir.
Thank you, madam.
Thank you, sir. Thank you very much. Thank you, sir.
Kumaran, sir?
Okay, ma'am. That was a good piece of information. Thank you.
Can we proceed with the next presentation, sir?
Yes, ma'am.
Yeah. Now I call upon oral presentation 24, Mrs. Ashwini. Ashwini ma'am, can you please share your slide?
Ma'am, can you hear me?
Yes, ma'am, we can hear you.
Yes, ma'am. Good evening to one and all present here. I'm Ashwini, research scholar, Department of Chemistry, New College. Effect of third harmonic generation of carbon nanoparticles by nonlinear optical activity under the supervision of Dr. S.J. Askarali, sir, Associate Professor, Department of Chemistry, New College. Objective of the present work: to synthesize graphene oxide and reduced graphene oxide by modified Humbers method and then characterized by spectroscopic analysis to study the nonlinear optical activity of graphene oxide and reduced graphene oxide by both second and third harmonic generation. Materials and methods: using the natural flake graphite are oxidized with potassium permanganate, hydrogen peroxide, sodium nitrate to form a graphene oxide. The graphene oxide is further reduced to dimethyl formamide to form reduced graphene oxide. Structure of graphene oxide and reduced graphene oxide. Results and discussion: UV visible diffuse reflectance spectroscopy. For graphene oxide, the absorption peak at 234 nanometer is attributed to pi to pi star transition. For reduced graphene oxide, 272 nanometer is due to the presence of pi to pi star transition of the aromatic C double bond C. The reduced graphene oxide exhibited blue shift from 234 to 272 nanometer. FTR spectroscopy. For reduced graphene oxide, the presence of stretching vibrations of conjugated bond and CC bond, which confirms the successful reduction of graphene oxide to reduced graphene oxide. Raman analysis. The two prominent band, D and G band, for graphene oxide, the ratio of ID by Ig is equal to 1.18, whereas the reduced graphene oxide shows 1.16 value, which indicates the lesser defects on the surface of reduced graphene oxide. X-ray diffraction analysis. XRD pattern for graphene oxide shows a broad diffraction peak for 2 theta at 10.6 degree, whereas the diffraction peak of 10.6 degree disappears in the reduced graphene oxide pattern and forms very broad diffraction peak for 2 theta at 23.4 degree. This shows the successful reduction of graphene oxide to reduced graphene oxide. X-ray photoelectron spectroscopy. X-ray photoelectron spectroscopy. The carbon oneness signal for graphene oxide and reduced graphene oxide shows two binding energy values at 284 and 286 electron volt, which corresponds to non-oxygenated CC or CH bonds. For a oxygen oneness signal, the graphene oxide and reduced graphene oxide shows one binding energy at 532 electron volt, which corresponds to C double bond bonds. Scanning electron microscopic studies, the semi-images of graphene oxide shows flaky texture, whereas the reduced graphene oxide shows highly wrinkled structure. This may be due to the low content of oxygen functional groups. Thermogrammetric analysis, TGA spectrum for graphene oxide. The 50% weight loss for graphene oxide shows thermal stability at 364 degrees centigrade, whereas the reduced graphene oxide shows 818 degrees centigrade. On comparing the thermal behavior of the graphene oxide and reduced graphene oxide shows higher thermal stability. Nonlinear optical activity, second harmonic generation. Second harmonic generation is a nonlinear optical process that results in the conversion of doubling frequency. The SSC efficiency for the sample were represented in the table 1 using a reference with the reference of KDP value. Both the samples shows zero efficiency. This may be due to the second harmonic generation dipoles forbidden due to the partial symmetry. Third harmonic generation is a promising application to predict the nonlinear optical behavior of the material by Z-scan instrument. The open aperture measurement is used to predict the nonlinear absorption coefficient, whereas the closed aperture is used to calculate the Kep coefficient. the open aperture and closed aperture for graphene oxide, and the open aperture and closed aperture of reduced graphene oxide. The third harmonic generation values for carbon nanomaterials were represented in the table 2. On comparing the nonlinear optical parameters for graphene oxide and reduced graphene oxide shows shows higher value for nonlinear refractive index. This may be due to the two-dimensional van der Waals heterogeneous structures of a significant role in the nonlinear optical field. Conclusion: the carbon nanoparticles like graphene oxide and the reduced graphene oxide were synthesized by modified Humber's method. The spectral and it is characterized by spectroscopic analysis. The nonlinear optical behavior of a graphene oxide and reduced graphene oxide by second harmonic and third harmonic generation. Second harmonic generation efficiency is not good enough. The third harmonic generation were analyzed by Z-scan measurement. On comparing the Ken nonlinearity values, reduced graphene oxide shows higher order of nonlinear refractive index respectively. Future recommendation: the study is further extended to the potential application of optical switching devices, photosensor, and laser amplifiers. References. Thank you.
Very good work. Have you published this article somewhere?
Under publications, sir.
Okay,
Sorry.
fine. Good.
Thank you, sir.
Thank you, Ashwini ma'am. With this, we come to the end of today's oral presentation session. We thank Dr. Kumaran sir for evaluating today's oral presentations amidst his busy schedule. Thank you so much, sir. Now let us
Thank you, ma'am.
Thank you, sir. Now let us move on to a special session by Serbian scientist, Dr. Marijina. For this, I welcome Dr. V. Sri Bharati, Assistant Professor, Department of Chemistry, and Adarsh College for Women, to welcome our scientist.
Good afternoon, madam. I am delighted to introduce Ms. Mirjia L. Erjovic, scientist from Serbia, who will be presenting a special session in our conference. Madam completed her undergraduate, postgraduate, and doctoral studies at the University of Belgrade in Serbia, with over 12 years of experience as a faculty member specializing in physical chemistry. She has made a significant contribution to her field. Currently, Madam holds the position of Senior Research Associate, the Institute for Technology of Nuclear and Other Raw Materials. Her academic work is reflected in an impressive track record, 53 publications in Scoopus Index Journal, with notable citation 842. To her credit, Madam shows multidisciplinary skills and extensive expertise allows her to excel in various fields and making a valuable contribution to scientific research and environmental sustainability across her diverse career.
I request Ashwini ma'am to kindly stop the presentation. Ashwini ma'am. Ma'am, can you kindly stop your presentation so that our guests can share their PPT?
Welcome, Marija, ma'am. Ma'am, it is not audible, ma'am. Marija, ma'am. Good evening, Marija, ma'am. Ma'am, your voice is not audible, ma'am.
Yes, you can go to the next slide. You can go to the next slide. If the voice is really doesn't matter because it is a recorded presentation.
Hello, sir. Hello, good evening, Rajendran, sir. Hello, sir.
Hello, yes, madam.
Sir, actually, our video has come, but the audio is not clear. Shall we resume tomorrow, sir?
Oh, okay, madam. Okay.
Okay, sir. Thank you, sir.
Dear participants, due to technical glitches, we were unable to hear the audio from Dr. Marijwana. So, with this, we come to the conclusion of today's session. So, tomorrow we'll be resuming the conference at 8:30 a.m. in the morning.
We can request the tomorrow's participants to
Yes.
send their PPTs in advance, madam.
Yes,
So
yes,
that
sir.
we can be
We
prepared.
can avoid these technical glitches.
We can avoid the delay and the technical problems also.
Sure,
Because
sir.
of
Sure,
their
sir.
places, there may be some power cut, madam. Many places
Maybe,
power
sir.
cut. They don't have alternative ideas. So they
Yes.
will find it difficult. It is better
Sure.
as far as possible. We can collect the PPTs in advance, and that will be a very easy process also. We can
Sure.
learn a new lesson from the today's session. Thank you, madam.
Oh, thank you, sir. We thank all the participants for your kind cooperation. Thank you so much.
Thank you, madam.